on people is that it is unfortunately the machine has not learned properly. So here, before learning means something going to happen or the machine is trying to understand something. So the data that is given to that particular machine to be prepared, or the AI ML model that needs to be prepared, the data that is the basic ingredient. Ingredient means the raw material, the raw information that the machine needs to understand was not proper. It means it has its own problems are there. So that is what the basic step that we need to understand. Whenever we try to prepare some AI ML model, means a machine which is trying to do some automation for us, make sure that the data which you are giving to that machine to understand and learn the things, what are the things that needs to be taken care. That is what the steps. So the today's session for the next 1 hour, we will try to understand. So the things like the stages and components of AI data pipeline. So what are the different steps? What are the different stages at which that data that needs to be prepared properly so that the machine can understand it and the AI model can be properly developed and can be used for the proper decision making. So what are the different steps involved in that? That is what our point of discussion. Please remember, we are not looking for the AI ML model. So I'll tell you what is the topics that are given to you. So our focus will be from data collection to AI model deployment. That is the main purpose. In that, what are the steps or the stages and the components that are involved in the data collection, data processing, making some preparation of the data, and making the AI model development and the deployment accordingly. So before that, try to understand what is artificial intelligence. This is a buzzword, artificial intelligence. So let us have some interaction. Sorry that if you are uncomfortable with responding to my queries. Basically, my way of going through is to have some kind of question answerings in the form of discussion. So let us have some kind of discussions here rather than simply one-way delivery of my talk. So try to respond to me. What do you mean by AI? In your own words. I'm not looking for a textbook definition or a literature definition. Based on data processing, we interpret it and make results. Okay. Any other views, please? Yes, please. Yes, sir. Sorry, replicating the human brain. Mimicking the human brain, right? Any other views? Making the machines to take the decisions, right? Simulation, right? Any other? More or less, yes. But making some decisions by the machines themselves or mimicking the human brain, whatever you are trying to understand here, how that can be possible. So one thing is that something called as artificial intelligence. So what is artificial intelligence? In other terms, what is intelligence? Intelligence, understanding from the past experiences. Human brain understands a lot. Yes. So before understanding, so let me just give an analogy or analog that suppose now as a human being, we have different sense organs. The sense organs are eye, ears, the skin, right, tongue. Okay, these are different sense organs. What are we doing with these sense organs? Or what is the help of our sense organ? Receive some data. So we are collecting some data. In other terms, we are trying to perceiving or collection of data through different sense organs. So through eyes, I am trying to visualize the environment. The environment can be seen. Through ears, I am able to hear. Through skin, I am able to sense the environmental temperature or whatever it may be. Through nose, I am able to smell. So there are different ways which I am using my sense organs to perceive this particular world. World means the real world entity, the real world abstraction, or the physical world. Physically, I am seeing so many things here. What I see, these are physical objects. And what I see, you all basically human beings. So I am trying to use my sense organs to collect some information. Once my sense organs are collecting that information, what is going to happen afterwards? Interpretation, analyzing? No. No, no. It is saved. Yes, one way it is saved. Saved where it is saved? In the brain. But brain is also not only meant for saving, some other thing. Processing. Processing. Before making some analysis, before making some decision, some kind of processing is going to happen. Please remember, before analysis and decision, processing means some kind of cooking is happening. So that cooking process is happening where? In the brain. Once that processing is done, based on our cognitive levels from our childhood, we understood how the things happens, how the processing happens. God has given that gift. Once that processing is done, then we try to understand. That depends on our cognitive levels, the memory and the different aspects are there. So once the processing is done, the analysis is going to come into picture. Once the analysis is done, or once the analysis is known by your brain, after that, yes, analysis done, take decision. Decisions will be taken in terms of what? How the decisions will be happening? By actions. Actions. It means from our nerve system, from our brain, the nerve system will make some, the decisions will act on our another body, means another body organs, hands, legs, or your body will try to do some kind of actions based on that. So much of things are happening here. What are those things? One is perceiving. Perceiving means collection of information by our sense organs. After perceiving, we are able to process it. After processing it, make decision and act according to that new situation. That entire process is nothing but intelligence. If we are able to collect, process it, take decision and act accordingly, if that things are done in that way, that is basically called as intelligence. And if the same process, the process is collection, processing, analyzing and making decision is done by a machine, then that machine is said to be artificially intelligent. It means the machine is now artificially intelligent. Now this is what, according to me, of course this is not a textbook definition, I write like this: the ability to perceive, understand and realize the new situation is called as intelligence. And if this intelligence is given to a machine, then the machine is said to be artificially intelligent. So why we are making the machine to be artificially intelligent? That's the next question. Yes, why you want to make that machine to be artificially intelligent? The machines can be faster. It means for our day-to-day life, in our day-to-day activities, whatever the activities which we are doing, that machine can assist us. It can support us. It can make our things easier. It can make our things in a better way. To many of the applications, for healthcare applications, for transportation applications, for our day-to-day activities, if that machines can be used for our own day-to-day activities, that machine will be very much useful. It is not that we can also do it, but at the same time, there are certain limitations for us. How much memory, how much data processing and all are there. So we take the help of that artificial intelligence to do certain tasks for us, which will help us in our day-to-day activities, for our betterment of our life, for the better quality of our living standards to be improved. Like that, so much of advancements have happened over the past 2 decades. The last 20 years or so, there are a lot of advancements are happening in the software and hardware, where we are trying to make those artificial intelligence systems for our day-to-day activities, for our different applications, across the applications. So in order to make that artificial intelligence to be developed for a machine, the important ingredient is the data. Data is the most important thing. That's why the first example that we are seeing, the Amazon, what the problem that Amazon has faced is the data that is considered for preparing an AI model. Unfortunately, the data itself is been biased towards certain information. Obviously, the machine also prepared its own, according to its own understanding has come that only male applications were selected. Obviously, that was happened in the past. So ultimately, it has led to the wrong decisions making. So here, the most important ingredient that needs to be understood, that in order to prepare an AI model efficiently, we require data. So data is the foundation of any AI system. Data is more important. The 80% of the project task, please remember, when your project means whenever you are trying to prepare an AI ML model, the most of the tasks, majority of the tasks, most of the time, most of the cost involved in preparing that AI ML models will be spent, will be utilized, will be handled over this particular data preparation only. 80% of the time. The remaining only 20% is where the algorithm, the method, and the technical considerations will come into picture. Only the remaining 80%, the initial 80% is where data is most important. We have huge quantity of data, but unfortunately we are not using the data in an efficient manner. So the data preparation is what? So what is data? It can take many forms. So the data can be available in different forms. So the numbers, text, images, videos, audio, like we have sense organs. We are collecting the data through visualizations, through audio, through sensing. So we have different forms of, as we have different sense organs collecting different forms of data. Similarly, the artificial intelligence systems can also be prepared by understanding different forms of data. So different forms of data exist in the market. Please remember, market means in the real situations, in the real world scenarios. So here data can come, the data can be from the different forms, number, text, images, videos, or so on. And we take the type of data depends on the purpose of the AI system. So which data to be considered for preparing the AI model or AI system, we require certain kind of data to be processed here. So data allows AI system to learn from patterns. So what is the data is making to do? Like when you collect some data by your brain is trying to understand some information. So your brain is understanding. So from the childhood, we understand that this is red color, this is yellow color, this is blue color. So a bus looks like this, a room looks like this, human being looks like this, animals looks like that. From the childhood, we learn ourselves. The learning has happened. So that learning has made to understand certain patterns in the data. The same way, whenever you give some data to the machine, some learning capability should be given to the machine to understand the intricacies that are involved in the data to understand a better, so that the machine can understand the internal details in a better way to prepare a better AI system. Any doubts, ma'am? Patterns means relationships. Relationship between one element within another element. So here, if I say what is relationship here, it means, suppose you have an object here. So if you are taking an object here, this is a fan. How do you come to know this is a fan? So in your childhood days, the teacher used to make the student to understand by showing some pictures, colors, fruits, means animals, birds, things. These are called physical things. So from the childhood days, your brain has understood that relationship between different elements. Elements means, when I say element means one thing with another thing. So that pattern was understood by you, depending on your cognitive levels. Cognitive level means the memory capabilities which you have it. So some students may learn it very quickly, some students may learn it with a slow, some are slow learners, some are fast learners. Means there are different types of learning capabilities. We are not looking for the rate at which learning is going to happen. But the patterns means basically the relation between this with the fruit, the relationship with this with the human being or an animal. Some kind of association or some kind of correlation between one element with another element. How the things are going to be related with each other. That is called learning patterns. Learn from the patterns. And once the patterns are being learned, we make accurate decisions or predictions. If the learning is not proper, the decisions may not be also proper. So remember, one important thing for the AI system or the ML model to be prepared, garbage in, garbage out. Garbage in, garbage out. What do you mean by garbage in, garbage out? If you give a garbage in for your AI preparation, the AI system also will be useless AI system only. So if you give a quality data, then only the AI system will be a quality one. So what is the quality characteristics that needs to be followed when you prepare an AI system? Please remember now, it is not that only computer science or AI programmers only need to understand these topics. No, AI is not related to only computer science and IT. AI is related to everybody now. 10 years back, of course, that is the infancy stage where AI is to be understood that it belongs to some computer science and IT guys. No. Since we are using in our everyday, we are in our every walk of our life, we are using the AI now. Now, this process has to be understood by every individual, everybody, whether you are literate or illiterate also. If you, some kind of intelligence is going to be there. So definitely you want to make use of that intelligence for making the system. But to make a quality system, certain stages, certain steps has to be followed for a quality output to be obtained. If you don't prepare a quality system, obviously there won't be any use. For that quality system, what are the important things? So these are some of the examples of data. Suppose you might have seen what is called data now. Data can exist in different forms. For your e-commerce applications, you might have seen some recommendations in the form of pictures, in the form of audios, in the form of videos, multimedia data and all. They're all nothing but data only. Data, everywhere data. So these are the different forms of data. So what is AI system? AI system has become a powerful tool for solving. So why we are using AI system? Just before the discussion I told you, for our day-to-day life, we are using that AI system which will help us in our life with a easy way of doing the things. So it can solve certain problems where we cannot do it on our own. So problem solving, automating the processes. It means it is like an automatic system. But of course, that automatic system is developed by us only, ultimately. But we are using it for our day-to-day activities, to make our ease of life. Then making some decisions in a better way. So AI systems depend on high quality data. High quality, that is the very big term here. The quality, how do you measure the quality is a very difficult thing. So poor data leads to poor model performance. That is what I was telling. Garbage in will get garbage out only. So remember those things. So you need a structured pipeline. Pipeline is nothing but a set of steps. So what is that structured pipeline? That makes us to have an accurate and reliable AI system. So that pipeline should make sure that it gives a proper output, accurate output. The data is going to be processed in a consistent manner. It should be scalable. Scalable means today you got certain amount of data, but tomorrow the data will be increasing. So even that new data should be understood by your AI system so that it should be scalable enough to understand the new data that is going to be originated over a period of time, so that the AI model can have a better understanding with the new data also. It should be scalable and it should be reliable. It should be trustworthy. It should be believable. So that kind of systems, the AI system should have it. So what are the key stages of AI data pipeline? So technically speaking, there are 5 stages here. The first stage is data collection, then data. After you collect it, then we have to do some activity that is called data annotation. The other name for data annotation is data labeling. Labeling, you need to give certain labels to your collected data. That is also called as data tagging. Data tagging, labeling, annotation, all 3 means the same. So afternoon session, we have certain lab. Lab includes this particular exercises. We'll do the annotation process. Then once you do the annotation, you need to do some kind of pre-processing, because we need to make a quality data that needs to be given to your AI model. So you need to have a pre-processing steps. Then once the pre-processing is done, then in order to make the data to be used for preparing an AI ML model or AI ML system, the data that you prepared a certain characteristics with certain quality data needs to be divided into certain parts for training purpose, for validation purpose, and for testing purpose. That process is called as data splitting. And once the data has been splitted, then you are trying to feed into your AI models. So actually many of the people, they understand that AI models is where the actual AI modeling is taking place. But remember, the AI model is not the crucial step. Qualitatively, the quality data needs to be prepared. So these are the important steps that needs to be done. In order to do these steps, you need different components. These are called the core components. Components means important blocks or important entities, important stages where this will be helpful for you to realize or to implement these particular steps. So these steps, what are to be done, can be done by a process called as Data collection is a process can be done with a process called as data ingestion. Ingestion means pumping some data, giving some data. Once the data is given, the data has to be stored. Like I told you the analogy which I have given to you. Collect the data, store it, process it, then make some process. After processing, make some analysis and make some decisions. So here, once the storage has been done, then you need to do processing, you need to do annotation, then we need to validate it, whether your processing has been done properly or not. You need to counter verify it, validations. Then the AI modeling comes, then the actual usage of that particular AI system. That is called as a deployment. Of course, we are not looking on this particular two aspects. We will be concentrating on these particular aspects. Our scope of discussion and practice for today's session is on these three aspects, not on the last three steps. So how the data collection, let us understand the data collection takes place. So what are the various ways in which data can be collected? What are the different steps where data can be perceived or data can be made use of? So simple steps. So like our sense organs are collecting the data. You can also collect the data from various sources, from various ways, from various means. There are ways and means to collect the data, proper data. Data is basically a plural thing. Datum is the singular form. So data is a plural form. Plural form is nothing but the lot of collection of information that is to be taken for you to prepare some AI system. So from where you will get data? What are the different sources available to get the data? So there are just the first step. We are looking into the first step called as stage 1, data collection. So please remember, we have seen these particular stages. Now we are understanding each stage, how it can be implemented and how it can be carried forward. How do we move forward from this particular thing? So gather raw data from various sources. From where you get the data? From data can be brought out from human beings, machines. We make use of machines. Obviously, machine also generate lot of data, lot of information. Digital platforms like your social media websites or your WhatsApp, your LinkedIn, Facebook, or your e-commerce websites. There also will get a lot of data. Of course, artificially sensors. We collect environmental information from deploying those sensors. Like we have natural sensors with us. Same way, we use artificial sensors that can be deployed at different fields or different domains so that you can collect different data pertaining to that particular domain information and prepare the AI systems. Similarly, you will have the public sources. Public sources like people do a lot of researches, industries, academia, where a lot of information is available, a lot of data is available based on their past experiences. They publicly make that data to be available so that it can be shared and that can be used by many people in different ways. Similarly, we have government statistical websites. That statistics itself will give us a lot of data, like weather data, weather information for forecasting purpose. Similarly, your business data. Similarly, some policy making decisions. So a lot of data is available. No need to write, ma'am. The material will be, I will give the entire material, same material only. Write down some important points, but don't miss the points which I am trying to share with me. So please, this material will be shared to you. Don't worry. When you come to the lab session, I will give a link for you to download it so that you can download it to your email or to your system. So there are so many sources through which you can collect the data. But remember, the most important thing when you collect the data should be relevant. If you take a relevant data only, you can prepare the expected AI model or AI system. If you don't take a relevant data, obviously what is your expectation cannot be done. For example, if suppose I collect data related to, data means some information related to Amazon sales. Now the Amazon sales, the data is related to the America. Suppose if I take during Christmas time or during any festival time, I collected the data that is related to the Amazon sales. But that data belongs to which country, or the data belongs to which country? America. If I use that data, it means during this particular month, these are the products which are being sold and these are the income, some kind of data which I collect from there. If I use the same data for our Indian context, and I want to prepare a machine learning model. I want to prepare an AI system using that particular data, the data which is pertaining to American context. Will I be able to use that model in an Indian context? Why? Because, yes, as I said, the answer is no. Why? Because our Indian behavior, our Indian community behavioral aspects are different from them. So if you want to prepare a AI system with respect to our own scenario, with respect to our own community, then obviously you need to collect the data relevant to our own community behavior data, rather than bringing the data, oh, I have data from that country, from that university, I can use that data to prepare AI system, and that use that AI system in Indian context. That is not proper. So relevant data is very much required. Relevancy, that's most important. Diverse data. What do you mean by diverse? Diverse means different data. As you need to have different data so that the machine can understand in a different way. High quality data sets. High quality data set is also very much required here. Suppose another example I'll try to provide to you. Suppose if you might have seen that while in the email conversations, if suppose you might have used Gmail. In the Gmail, whenever you receive a message, the Google will give you some kind of suggestions at the bottom of your message. It means automatic suggestions will be done. Okay, thank you. I will get back to you. Some kind of phrases or some kind of sentences will come in the messages. How it was done? Google has prepared a machine learning model based on the subject, based on the content. You get it from a sender. Automatically, what kind of reply you want to give, it will automatically prepare some suggestions for you. For that model to prepare, it has used millions of data records, millions of data informations. That is one scenario. It means how much quantity of data that Google has used to come out with that particular kind of activity. Some millions of records, 2 million plus records were used by that Google to prepare such kind of systems. There is another example. There is one Chinese professor. He is a medical kind of medicine professor. He used certain X-rays and MRI photographs, MRI images, around 630 images only. With using 630 images, he prepared one AI system, and that system is also accurate. Now see the two scenarios here. One scenario where Google has used millions of records to prepare one AI system. In another scenario where one professor is a well-known professor in the particular field. I cannot remember. It is Tamanga, some name is there. I cannot remember it. But he has used little data set. Now my question is, whenever you want to prepare an AI system, how much quantity of data is required? High quality data, but I am asking a question. The question is, how much quantity of data is required? Is it depending upon task? Any other views, sir? It is not exactly depending upon the task also. Of course, the relevant data, diverse data is required. My question is, number. Is it required 10, 15, 1 lakh, 10 lakhs, it means 1 million or 2 million, or just only hundreds and thousands? The question is sample size. Yes, the question point here is sample size. How much data samples are required to prepare an AI system? Remember, in literature, there is no hard number, no number for anything. As you mentioned, depending on the context, depending on the requirement, depending on the quality that you want to prepare a machine learning model, there is no as such a number for that. Please remember, there is no fixed number. So quality, that's what the quality matters. The more the quantity of information you use it to prepare a machine learning model, the better AI system will be there, because it will have understood the learning has improved with more number of huge quantity of data. So with huge data, when I say huge means there is no quantification for that. Just remember that in the literature there is as such there is no number. So there are several things to consider when collecting the data. But remember, whenever you are selecting certain data for you to prepare an AI system, so from where does the data come from? That's what, from the source, whether it is American data or European data or Indian data or in Asian countries data, where, from which particular source. whether it is the college data or whether it is this particular college data or another college data from another source or whatever it may be. Where does it come? What type of data is there? So the data includes numbers, text, images, or your numerical values, whatever it may be. How much data and what attributes do I need? Attributes means technical word. Attributes means features. Yes, technically there are so many synonyms for attributes. So let us discuss. Attributes is one particular attributes. Features you said, yes. Any other? Characteristics, yes, 3. Columns, 4. Actually, I think you might have used it some software development. That's why you're using. But for others who are very beginner stage or just trying to understand, let us have some discussion. Only 4 synonyms. Sorry, sir. Recognitions, no, ma'am. No, that is not. That is attribution. Attribution is different from attributes here. Titles we give for that one. No, ma'am. I want a related word in related context. So far, I'm telling you attributes, characteristics, features, column. Yeah, column names, fields. Fields is another 6th one. Technically speaking, dimensions. We use another term called as dimensions. Now 7 words are come. What else, please? Labels, 8. 8 are come. I want 2 more. You can get it. Just try to apply. It's not class. No, class. Tag, yes. Tags, 9th one. Yes, 10th one. Just let us complete last one. Synonyms. Because the students also, whenever they want to learn it, please remember, all the names has to be given to them. Because when they read different textbooks or different context, whenever they are referring to some materials and all, they usually confuse with one word with another word. So always it is our habit to make it. Since you are from mathematics or physics, you will have one related word. That's what I'm just waiting for that. Property, yes. Simple thing, property. There are 10 synonyms are there here. All 10 means the same. But in different contexts, we use different names. So just remember, those are called attributes. Because that is what more important when you are preparing an AI system or a AI modeling. What is happening? It has been seen here. Okay, now I just connection of this I will lose connection. తెలుసా మీకు తెలియకపోతే అతను ఎవరైనా Okay, so here let us see what are the different ways in which you can collect the data. So as I said to you, through humans you can collect some data. So what is that? How you can collect some data from the human? So there is, how do you collect data? If I want to collect some data from you all, what I need to do? Survey. So survey forms. So survey forms, I think you are most already familiar with those, how the survey forms looks like. You just put the screen print here. So a Google form is the most thing. In the olden days means of course when the Google applications and other software applications were not there, we used to collect by manually by typing the content means the question answers on a paper, and we do circulate the papers here. Because with the advancements in the internet today, what we are doing, we are not collecting the data manually. We are trying to prepare one form. So in that form, a proper questions are being prepared here. So those questions are being basically curated questions. It means who prepares that questions? Who prepares that questions? Means some questions. Is that everybody can prepare the questions on their own? We will not call researchers, some experts in that particular domain, experts in that particular field. Experts in that particular means usually whenever you try to, why experts are required? Because if the quality of the questions are not good, the answers also will not be good. That's why quality questions will be asked. It is not that junk questions you give it and junk data you collect it, and obviously that junk data you give it to the machine to understand, doesn't happen in a proper way. So quality questions, of course, the experts they will be helpful because they have certain kind of domain expertise, and as well as they also have certain prior experiences there. Then they will help us to prepare how to means what data need to be collected and in what form the data needs to be useful for us. So once the data has been collected from the form, that is the first activity which you do it in the afternoon session. I also prepared one Google form there. So once the data has come here, so what is that you are doing with the data? You are storing that data. So where the data will be stored, once you collect the data from the forms, where the data will be stored? Spreadsheet. So spreadsheet is one particular a kind of database, basically the basic. So in computer software terminology, there are so many different types of databases are there. But the most generic form where it is easiest to understand for everybody is basically a spreadsheet, or in short we call it as a sheet itself. Excel is the name of the company, means name of the product which has been developed by a company. So it's a worksheet kind of stuff. So here we collect survey forms which are human curated entries, and expert driven data collection will be there. So different forms I think you are already aware of. This is one way where you are trying to collect some data. So once you are collecting the data from different forms, now there is another way also to collect the data I already mentioned to you. What is that another way? Using sensors. Of course, I am from that particular area. I can talk to one day also, but I just want to mention little bit only. So we are collect the real-time data for different applications. Suppose you take an agricultural application. So what is that agricultural applications? So what do you do here? We deploy certain sensors. That sensors, when you deploy it in an agricultural farm, so what is that you are collecting the data from that agricultural farm? What data will you collect from them? Plant growth. It's not plant growth. Basically, yes, plant growth is one aspect. The soil, yes, soil parameters, environmental parameters like temperature, humidity, what type of gases, soil moisture, means these different parameters. So what is that you are doing with this? Once the data is collected from the sensors, we try to put that data in the dashboards, and we try to store it, we try to process it, and make decisions in the real time. Real time means, what do you mean by real time here? Again, important thing, real time. This is a technical word, real time. Everything happens. Data collection, data processing, data analysis, and making the decision. Everything happens within less than nanoseconds. Within less than nanoseconds. If everything happens within less than nanoseconds, this we call it as a real time. Real time has got different names. Okay, I'm not technically going on through this one. But collection of data, processing of data, make some decision. Yes, now the soil moisture content is very low. It needs to be watered up. Yes, again there will be signal will be going to the pump to switch on the motor and make sure the water has been immediately been there, so that harvesting can be done, plant growth can be maintained properly, everything in the real time. So lot of data collection is happening through sensors basically. Similarly, if you see, lot of data collection can also happening through your wearable devices. Nowadays you are using smartwatches. So what is that you are collecting from the smartwatches? Data related to your blood pressure, data related to your skin temperature, heart rate, blood pressures. Nowadays, data collection. So suppose your blood pressure is increasing now. Obviously, you'll get a signal now. Yes, now I need to not to stress it. I need to relax myself. How many walking steps I have done in today's. So much of information is coming in the real time through your sensors, through your wearable devices. So through wearable devices, basically these are IoT systems. It means data is being collected, data is getting processed, and AI systems have been built to make proper decisions for us in the real time. Similarly, nowadays you are seeing in the on the smart cities, where in the smart cities you are taking the help of a lot of sensors that are deployed for transportation purpose, for efficient use of parking slots, for your clean and green purposes and all. So a lot of sensors are being deployed here. That's why using sensors and IoT systems, you also try to collect some data. So this is one way to collect the data. Manually, you are collecting the data from the human beings. You are also collecting the data from machines and physical devices, so that the data can be processed. Similarly, from where else can you get the data? From where else you can get that? Suppose you are trying to develop a automation process for your banking applications. So you want to develop an AI system for your banking purposes. But where you will get the data for that AI system to be developed for the banking purpose? The banking transactions, usually lot of information is stored during, means where they are stored in the, where they are stored in the log files. So there will be transactions will be happening, sender, receiver kind of information, from where it is coming, from where it is going, how much money is going. All these things are being logged here, where the computer systems and the servers keep a track of all that information from the log files. So the log files, from there also you will try to get lot of information so that you can prepare an AI system. That is for the banking applications, where you can get lot of data for you to prepare an AI model for your banking applications. Similarly, there are other methods called as web scraping. Web means, what is meant by web? In internet terminology, or in your own words at least, web corresponds to what? In your own words. I'm not looking for any technical or textbook definition. Web, World Wide Web. Network. Yes, in another terms, web is nothing but a network. Scraping means capturing by how you capture the data. By searching is a very technical term, sir. I will not use that technical term. I am sitting on my computer now. My computer is connected to the internet, but I want to get information that is available from another university or from a company's website that is there on the internet. How do I get it? Browsing. No, I don't want to go each and every website across the internet. If you start browsing, your day will be over. Day will not be sufficient. Your months will not be sufficient. Years also will not be sufficient. Yes, please. Crawling. Yes, crawling. What is meant by crawling? Crawling means moving, just nothing. But a small child crawl means what he will do? He will make small steps. He will move in different directions. It means on the web is nothing but internet. Internet is nothing but network of networks. So I will sit here. I will write a program. Programmers, usually the software engineers, software developers, they do this one. This is what happening in the last decade, web scraping. But now that is what little bit outdated also. That is what that strategy is outdated. People used to extract information from different websites and from different servers and from different machines which are connected over the internet. From different locations, they extract that information, collect the data, and they make the data to be properly processed and make some better AI systems. That process of extracting the information from various other web sources is called as web scraping. That is the technical term, web scraping. And that is usually you need to write a program for that one. Nowadays, you need not sit and write the program. Means that then there is no requirement of a software engineer or a software developer or a software programmer to sit and write the program. Automatically, AI agents are coming into picture. They themselves, whatever you do it manually or whatever you write a program, they are also doing on their own now. That is what automation has went into that particular extent. So web scraping also has been automatically done there. That is another process of collecting the information from various sources, where you will get a lot of data from different websites and different companies, organizations. So what type of data you get it here? That's what automated extraction from website. That data can be related to some kind of market data. That data can be related to social media contents, so on and so forth. You try to scrape the data, means collect the data by moving to that particular website. Now there is another strategy where you get a structured data. Structured means a particular organized data from some external sources. That collection is basically called as APIs. Technical term is called as API. API stands for Application Programming Interface. Application Programming Interface. What is this APIs? Nowadays, you can also use these APIs to collect the information from different websites and from different sources. If that company or that organization allows you to use their data, for example, weather data. I want to get the Hyderabad weather data and I want to understand tomorrow whether it will be rainy day or sunny day or it will be a very cool day. If so, what will be the temperature? I want to have past 10 years of data or 20 years of data. From where you will get it? There are companies are there. They will allow you. Some are free, some are paid. So obviously you can get those data. How do you get the data? That mechanism is called as API. So in the afternoon session, we will see how to collect the data from different websites. Not only for the weather data, suppose stocks data. Today, what is the stock trend? So I want to know the last 10 years or 15 years, particular products, what are the trends of that particular stock? And I want to make some automation of that one. I want to make some program from that data. So I need some data. So data can be brought out from various sources. That way of bringing the data through APIs, that is also one way of getting the data. So what are the different ways in which we are trying to collect the data? So far, what are the ways which we have seen? Data collection, manual one. Yes, please. Yes, using machines, that is through your sensors and other physical devices. Yes, please. Using? Sorry, sir. Websites. Using websites. Websites also, you need to little bit understand that the web scraping is there, APIs are there, as well as getting the data from log files. Very much log file means is a very important file. Remember what exactly is happening in the banking transaction process. They keep a complete data. So these are the various sources where you get the data here. These are the important stages. Now we are moving to the next stage called as data annotation. The annotation, the name of that, okay, I have not given elaborately notes. They are very, very important points. I am trying to give some descriptions and little bit explanations here. That will be, I think, sufficient for you to get on to that material. So just go, this material will be shared to you. Don't worry. No need to spend time in simply writing these things. Okay, and the next stage is nothing but data annotation. Technical name in the computer science and IT field, we use the term called as annotations. But in layman terminology, it is nothing but labeling. In another term, it is also called as tagging. Or in another term, it is also called as, in simple layman terminology, labeling process. Or labeling means naming. Yes, very simple to say. Give proper namings to your data for your machine to understand and to prepare some models. So here, adding meaningful names to raw data. Please remember here, still we are in the data collection and the data is been in the raw data only. So there is a raw data. When I say raw data means this is the actual, the factual data, facts. These are the real facts. But sometimes that preparing the AI system from the raw facts is not correct. Sometimes what is to be called as a fact, we understand that the data is a genuine and the real fact. But for machine, even if it is a fake data, that is not a real data. So sometimes these things will come into picture. I will come back to that after some discussion. So how do you give meaningful labels or meaningful names to the raw data? So there are different ways. Essentials for supervised learning means when a machine is getting learned, when a machine is getting prepared to understand the data, that process can be done technically. There are different ways. One particular process is called supervised learning. The machine is getting learned from the data. That process is called supervised learning. Means some supervision, some kind of supervised information is already given along with the data so that the machine can understand what is that particular process to be understood. That type is called as supervised. Another type of learning is called as unsupervised learning. There is another type of learning called as reinforced learning. So like this, in technical terms, we have different types of learning, AI and ML learnings. But for you to understand at this stage, supervised learning is the most appropriate thing. So supervised learning, I think camera is not there here. Last time I brought my laptop. Supervised learning, camera is there, huh? I don't think so, right? Camera. How supervised learning happens? Have you seen any practice in the yesterday's or previous classes? Sorry, sir? Teachable machine, you have seen it? Then you understood. In the teachable machine, when you are using Google's teachable machine, when you are collecting the images from the camera, what is that you are giving that information? A label, the class label. That is nothing but giving a label, giving a name to the collected images is nothing but the type of learning to be given to the machine is called as supervised learning. That is what an example. So if you try it, go to your, just click that link, you'll go to the Google's teachable machine. So it is very easy, no need to write any programming code. It is a no code platform, and you can use it to prepare your machine learning model. But the first step will be basically your annotation. Annotation means once the images were collected, you are giving a label to all those hundreds and 200s of images with a particular class name. Class name basically an object name or whatever it may be. Then that object name will signify that those so and so images are named with so and so. That will be useful for proper classification of images during the testing step. So that is already you are doing it. So what is that annotation? Annotation will improve the accuracies and reduces the biases in preparing your AI system. So it helps in feature learning. Feature learning means, what is feature learning here? The relationship between those particular elements of that particular images or the text or the data. The relationship between the data elements, some kind of, what is that association that is happening? What is the relation is existing there? So that machine can understand in a proper way. That is called as feature learning. It itself is a very big topic here. So annotation methods in the lab class, we'll see. Have you done annotation? No. So let us do it with small annotation. No code means no need to write any code. We'll see some software, one or two tools, how to do it. The lab activity which we have prepared in the next session. So how the annotation will take place. Okay, now you collected the data, you store the data. Now how the annotation happens. There are multiple ways. One is through manual and another one is through automate. Automated means already there are certain softwares. Because annotation itself is a very laborious process. Laborious means it consumes lot of time, lot of patience is required, lot of amount of work need to be done. If until unless you don't annotate the data properly, the machine cannot understand what the data is. Obviously, the machine cannot be prepared properly. So annotation process is what is a very, very crucial step. So tomorrow, if you want to prepare your own AI system, and if you can have collected your data, the immediate step will be store the data and start annotating process. So today you will see how the annotation takes place manually, and if time permits, we'll do the automation also through using the software in the RoboFlow. You can try to do this. So annotation method, when you're doing it manual, please remember, annotation, who has to do that annotation? That annotation has to be done by the experts themselves, especially for the medical field. In the medical field, if you collected the MRIs or CT scans or X-rays, those images will be used for you to make a AI system. Suppose you want to see, suppose there is a tumor in the brain, and you are preparing an AI system to automatically recognize once the MRI image or once the MRI is been scanned, immediately that machine AI system should trigger that there is some tumor in the brain. If you want to prepare such kind of machines or such kind of AI systems, then obviously that machine needs to understand huge quantity of data with tumors and without tumors. Both the data sets are to be given. But how the machine will understand that so and so area, so and so region, so and so particular small part is having some tumor? How? So first you will take an image. Once you take an image, then you need to label that image. Who is going to do that labeling? The radiologist or the medical doctor. They have to be the experts. You have to take their help, annotate it, huge quantity of data. Normally, the radiologists, the doctors will not have time to sit and mark it like this. So let us see in what is exactly happens in annotation, and you will see what is the difficulty in annotating those things. So usually our computer scientists or programmers, usually they themselves will do to prepare certain AI models. So these were the olden days strategies, what was happening. But nowadays we are using AI assisted softwares. It means already machines, programs were written to do some kind of annotations so that it will help us in our process. So these are the two important steps. One is manual and another one is automated. So what is the use of this annotation? Why those annotations are going to be useful? And where are going to be those annotations? So annotations, once you label it, once you name those particular images or your text, then they can be used for some kind of applications like classifications, detections. So and so image is this, so and so item is this, so and so text is this particular value. So you will be using that particular annotations for various kinds of recognitions or various kinds of decision makings. So that you will be using. How these annotations can be done? Using one method is using through classification. It means you will be giving certain data as spam or not spam. It means you will have certain emails with you. So you will directly give a label. You directly tag that particular email. This is to be not a normal email. This is to be a spam email. Something like that. You give a labeling. That is what labeling by classification. Whenever you are doing certain annotations on the images, bounding boxes, you will use certain box so that that particular region, that particular area is going to be given a particular name. That you are going to do it in the afternoon session. See what is called as a bounding box, you will see there. Sometimes this segmentation is another topic. It means you need to partition that images, especially for the medical images. I just told you that tumors, only a particular small part has to be segmented from the other parts, and that needs to be labeled properly. That is one type of annotations. That is also called as segmentations. Sometimes you need to use transcriptions also. Like whenever I am speaking, when an audio is been generated, means automatically my words are getting translated, or it can be transcript, means the English words you see it. During your online meetings or YouTube watchings, you can see at the bottom of your screen, the English text has been transcribed for you to understand, to read it. Suppose sometimes you get it. So that transcription is also one way of annotating the data. Then we also have certain things called as named entity recognitions, NERs, especially used in the natural language processing. Natural language processing, if you are preparing an AI system to work with our natural language, it means to either in English or the regional languages, you prepare an AI ML system. Obviously, there is need to identify from that particular text which are name, which are place, which are organization, which are different entities. You might have seen in our childhood days, we used to play name, place, animal, thing. Identify certain kind of nouns and pronouns used to be there. From the sentence, before you try to prepare an AI system, you need to tell which is to be called as a place. Hyderabad. Hyderabad is a place. For certain context, maybe Hyderabad is the name of a person. It means you need to tell, you to inform the system whether Hyderabad is a place or it is a name of a person. How the system will come to know? Until unless you don't give that labeling that Hyderabad is to be understood as a place, the system will not to know. That's why you need to give names. That means you need to give certain labels to your text. So you have a paragraph with you. Inside the paragraph, sometimes some words will be there. Sometimes some word is Elisa. Now Elisa is it a place, it is an organization, or it is a name. How that things can be identified by your machine? Until unless you don't label that particular respective text in a proper way, the machine also will not to know. So you need to label them, the text. If time permits, you'll do that exercise in the particular software. There is there in the afternoon, next session you'll do it. So nowadays you can identify the name, whether it is a name, whether it is a location or an organization. Suppose you take an example. Nagendra Kumar works at University of Hyderabad. Now in that single sentence, please you tell me which are names here. Yes, Nagendra Kumar is a person here. Please remember, this is also name. University of Hyderabad is also name only. But this name corresponds to organization. This name corresponds to person. So suppose you are given a very big paragraph, very big chunk of data. Chunk means huge quantity of data here. So, and that data needs to be properly annotated. Once they are annotated, then the machine will be able to understand. Okay. So who are the names of a person? Which things are being called as organizations? Which things are called as locations? Which things called as dates? Which things called as time? Which things called as identifying a particular entity? That's why they are called as named entity recognition, NER. So named entity recognition is very much useful concept in preparing an AI system which is involving the natural language processing here. So this activity also is one type of annotations that needs to be done here. Then once you get the data, store the data, and you do the annotation, once those things are done, then immediate thing is, yes, your brain has collected the data. Yes, it has done some annotations based on your cognitive levels. Now the next step will be pre-processing. It means some kind of data needs to be processed. So what is that to be processed here? Data pre-processing is nothing but it is a process of clean and preparing data for AI model. It means you need to clean some data. You need to have some proper data, quality data to be realized, quality data to be obtained for you to prepare certain AI system in a better way. So what are those tasks that happens during this pre-processing stage? So the data that you collect is a raw data. So most of the time that raw data will not have the actual data. Some missing data will be there. So how to handle that missing values? How do you remove the duplicates? Before you go to prepare the AI system, you need to remove the duplicate data. Otherwise, it will be time consuming and costly and other works will be there. Sometimes you need to do normalization and scalings, and you need to encode the categorical values. Then you need to remove the unwanted data. Unwanted data with respect to that is called as noise removal. So if you take an example here, one example I just preparing here, just see here, there is customer ID, age, gender, monthly charges, contract type, and churn. What are these called as? Labels, features, once again please, attributes, column names, properties, characteristics, dimensions, all of the 10 which we have seen earlier, all this. So these are your column names. First column is customer ID, second column is age, third column is gender, the fourth column is monthly charges, contract type, and churn. Now if you see the data, you collected some data either by manual way or from the machine, you got some data now. From the log file, somewhere you got the data, and the data looks like this. For first row, this is first row here, customer ID 1, age 34, gender male, monthly charges 70.5, contract type month to month, churning means whether that subscriber is going to continue with that subscription or not. Churn is a foreign word here, foreign name, so don't confuse with that. So, but the second record, the age is not available here. Similarly, for the third record, monthly charges are not available. It means they are missing values. Some values are missing in this data. So how do you handle this data? Because you cannot give the same data for your machine to understand this. So before giving the data to be given to the machine to understand the relationships and the actual data here, so you need to fill these values. How do you fill these values? How do you handle these missing values? So here, handling the missing values. Fill in the missing age with the average age. Yes, sometimes you see the average among this column, what is the average value? So what are these actually getting an average value? What does that mean? Some statistical measures, some statistical techniques are to be applied so that meaningful data may not be accurate data, but some kind of correlated data or some kind of meaningful data, you can give it to the before making the machine to understand that one. So you can prepare that, that's why you call it as pre-processing data here. So you can handle this missing value. Similarly, monthly charges, you can make use of median here. So it is not that only mean and median, there are various techniques are there. But these are just a small example which I like to bring it to you to your notice, that some kind of statistical mechanisms need to be applied for handling the missing values. It is not the only thing, there are various other techniques are also there. Suppose now you can see here, what are these variables here? Gender. Gender is male and female. Sometimes there will be another category also. Others you can take it. So only 3 categories are there. This is one type of categories. Similarly, you have contract type. How many categories are there here? Month to month, 1 year and 2 year. There are 3 different types of categories are there. Similarly, you have churn. Churning means whether you continue the subscription or not. You have only 2 values. It's a binary value, binary variable here. It means this is the attribute concerning only 2 different values here. But see here, these are categorical values. These are not numerical values. So whereas this particular column is a numerical, whereas this column gender, contract type, and churn is a categorical values. The machine cannot understand the categorical values. Please understand. Category values are understood by our human readable things only. But machine cannot understand. That is also some data only. But the meaningful information cannot be understood by your machine. So most of the time, if you want to prepare a machine to understand and to make some decision on its own, the data should be available in a numerical form. So most of your data sets, if you are given in the numerical form, so that machine can take proper quantity information, numerical representation. The data is there in the numerical decision will be helpful for the machine to take proper decision and make some actions to that. So what you need to do is you need to convert these categorical values into proper numerical forms. That process is called as, encoding. This is another technical term which you use it in the computer science and IT field. Most of the time these categorical values are been transformed, or they are been translated, or they are been changed from categorical form to numerical form. So there are different techniques again. It's not that only one technique. One technique that which we are using called it as, what the name of this technique is called as, is one hot encoding. This is the technique that used is basically is called as one hot encoding. So how it is being done here? The gender contains two different types, male and female. Contract type contains three different things, are now categorical. So when you do this label encoding for gender, so male can be represented by 0, female can be represented by 1. A numerical value 0 and 1 are being considered for understanding that these are the two different categories with different numbers here. Similarly, one hot encoding, we call it as one hot encoding. There are three different categorical values, month to month, 1 year and 2 years. So you can convert this particular 1 to 1, month to month as contract underscore month to month, contract underscore 1 year, contract underscore 2 year. Three different columns are going to be added here from these three different types. Then similarly for this particular column which contains two different categorical values, which is basically binary, we can replace this yes with 1 and we can replace no with 0. So here once you transform it, how the data will be looking like. So here gender is nothing but zeros and ones. Similarly contract month, contract 1 year, 1 year, 2 years and month to month are also represented by the numerical representations here. But the meaning is not lost. Please remember, meaning is not lost. We just translated, we are converted to represent the data from categorical to numerical formats here with adding three columns here. And the churning is also the binary value replaced with, that is yes and no is replaced by 1 and 0. So now if you look here, the entire table is basically a data. Yes, please. One second, ma'am. So here, this contract underscore month to month, 1 is given for which particular record here? For this particular record number, whose age is this one? Whether another ones are there here? No. So when you give a meaningful information to the machine now, this is a logic. That is a logic, means some kind of strategy here. Machine to understand, yes, this particular aged person, he is subscribed to month to month subscription. He is not subscribing to 1 year or 2 years. Meaning is not lost. Where is the meaning lost here? Yes. Yes. You mean to say this, now that there comes the attributes here. So here this column representing is represented by gender. So these values are not representing for these things. They are not related to this. You are restrict means you are already fixed that this data is pertaining to this particular field. This data is pertaining to these fields. This data is pertaining to these fields. You can go for another coding, madam. That's not that binary coding. You can go for A, B, C also. But when you get a result here, when the machine is going to give here the answer, what is the gender of 34? If you give a question, once the AI model is prepared, it will give the answer as 0. Then what is 0? Again, your answer should be 0 pertaining to male or female according to your encoding which you have done before. Again, there will be a last step will be taken care here. Only for the machine to process the data, to prepare the data, because number processing is easier than categorical processing. Category means the text contains letters. Letters processing is not easy for a machine. Machine can understand, machine is nothing but a digital system. Digital system means the numbering representation is very much required. It will understand only, yes, please. That is one thing, yes. That memory is occupied and processing that one is a huge task for the machine. You are just making the machine to process it. Processing is also to be done by a programmer. He has to give that information to the machine. How to process also you need to give. Everything has to be given by a machine. Machine cannot understand on its own. Nothing will machine can understand. Until unless you give the complete information, what to be done, how to be done, what is this, how to handle that one, everything. Machine will not confuse here. Machine will do whatever information you give it. Machine will not have its own interpretation. Please understand that. So here, once you prepare it, it is just for you to make the machine to, it is not just 4 records, it will be millions of records will be there. So ultimately that accuracy, everything is be considered into picture in the later stage. For you to understand, I just brought one snapshot here. What is the point we need to understand here? How to handle the missing values. How do you normalize it? How do you encode it? These are the different techniques that usually happens in the data processing. That's the point of discussion here. Now, how to do all these things? Those who have done software programming, the programmers use different software tools. These are the names of the tools I have given here. It is not that compulsory you need to practice all those things. If you can use those tools like pandas, packages, numpys, and your scikit-learns, these are the different software tools which are helpful for you. Whatever I told you just now, they will do it by writing the programs. So that usually done by your programmers. So once the data pre-processing is done, yes, now the data, some kind of quality data is there, which you handle some missing data, which duplicates are removed, some kind of encoding is there. The next stage is basically your data splitting. So your session is up to what time? 11 o'clock. Huh? Just give me 5 minutes time. I'll just complete it. 5 minutes time, so that almost I'm done. So what is the next step you need to do is, yes, you have a data set with you now. The important thing you have done it, cleaning is done, normalization, some kind of important features are extracted. Now that data has to be given to different processes now, different processes. Those processes are called as training process, validation process, and testing process. So it is something like this. I'll give a simple example here. A student is learning some subject by reading the textbooks. Okay, so he read some subject by reading the textbook. So before going to the final examination, the student has attempted the mock examination. Now my question is, why the student has attempted or why the student has undergone the mock examination? Test is capabilities. It means self-assessment. That is nothing but self-assessment. But the actual examination is the next step. That is the next step will be there. Testing, that the actual testing will be there. So this mock examination is like validation. There's not verification. The technical term, the analogy of that example is nothing but validation. He is validating himself. Yes, now, okay, now I understood the question and what answer should be given for a question to be given. He prepared himself. That is called validation. So you prepared, what happens is you are using the data set to make a AI system. So what you do is you use some quantity of data for your AI system to be prepared, but you use that some other quantity of data for you to validate it. Yes, now whether the model has understood it properly or not. And you use another quantity of data which to be tested for that model which has been prepared. So that testing data should not include the data which is being used for your preparation purpose. That should be unknown only because it is a real testing that is going to happen here. Validation data can have some part of the data and unknown part as well as some known parts to have validate the system here. Now, how much percentage to be used for that training process, for validation and for testing? Normally, you go for 70 to 80% in the training phase, 15 to 20% in the validation, and 15 to 20% data set can be used for your testing purpose. So that we use these particular things. For what purpose I have taken here. So why we want to do this data to be splitted once you prepare the data? Why? Because if you're not doing that splitting, if you are using the entire data, 100% data, entirely for training, it means the machine can be called as overfitting. Overfitting means it has understood what test data is also there, that data is also there in the training. So machine has understood these my test questions are also there in that. So automatically the machine has called as, technically term you call it as overfittings. There are problems like if you're not splitting it, underfittings, sometimes biasings, and sometimes not accurate. All these problems are going to come if you are not splitting the data to a proper way of making the system to learn it, make it some validations and testing for accuracies. So that's what you call it as. Overfitting called as model memorizes the training data. Underfitting is called as model is too simple. Means you use only little quantity of data. That quantity only you are using testing. That quantity you are using validation. With less quantity of data, then it is called as the underfitting. data leakage. Sometimes the test data is also used in the training purpose. The test data is not separated from the training data, then you call it as a data leakage. Sometimes inflated accuracies. So these are all the problems when you are trying to make use of the data in preparing your training the AI model if they are not properly split here. So once your data has been used, then you can convert the data into your features, give the data to your ML models, and test that data model once the data is prepared by using what metrics? Metrics. What are these called as? Accuracy, precision, recall, F1 scores. I think everybody, mathematics and physics, chemistry, everybody knows these things. What are these? What are these metrics? These metrics you need to assess that particular valuation of, yes sir, exactly, valuation of paper. After that valuation is done, what are these basically? They are depending on what? The accuracy is depending on what? Precision is depending on what? What is the background? No. Yes, your concept is correct, but I'm expecting a right word. Model, no. What I'm looking for is, okay, I'll call it as what are called true positives, what are called true negative, false positive, false negative. I have not come across true positive, true negative, false positive, false negative in statistics. What is called true positive? True positive. Your machine has given some answer now. Machine is telling a particular machine has prepared and you have given some input to the machine. Now that input data is pertaining to a man. And the machine has predicted that this is a man. Machine has given the answer as man and you have given an input as man. It means both are same. So then that is called as, then you know what is called true positive. Yes, what are those? Precision, you don't know? Precision, recall, the formulas are that. True positive, true negative, yes, false positive, false negative. Please recollect those things. Basically nothing but the logically whether they are correct or not. So basically if their opposite answers are coming, then it's called false positives, false negatives are going to come into picture. So actual true positive should be very high. It means the real input is there and the machine also predicting the same thing, then only the true positive will be high and the accuracy will be high here. So there are certain metrics are there you need to look for. So here data ingestion, storage, processing, validation and delivery, that's what you need to do on activity. In the morning session you'll do it, in the next section you'll do it. Collect data from multiple sources, batch time processing will be happening. Storing the data in the form of Google Sheet, that will do it now. So data cleaning, transformation, this is the steps usually happen. Data validation to check for quality and anomaly. You can use the Looker Studio to, once your data has been ready, you can use some softwares to understand the data, the quality of data in the form of reports, in the form of dashboards. What usually we do is, we project the data for making some important decisions. The data can be projected on a softwares, using softwares. It is on the dashboard. It means on the main screen, you try to see how you represent the data. If you want to make some decision, structured data in the form of pie charts, in the form of some graphical representations, pictorial representations of data will be there, so that the managers, the decision makers can be done. Using the software, you can do it here. So please remember challenges in AI data pipeline. Most of the time, what are the important challenges? Data biasness. One example I have already given in the beginning. Privacy and security. The data can be used for some other purpose by some other people. High annotation cost. Annotation labeling. Scalability concerns means you need to improve or add more data to your data so that the AI model can do it. So what is in conclusion? Data is the backbone of AI. AI to be prepared here. So well-designed pipeline improves the performance of the AI system. Quality annotation determines the model success. Efficient components ensure scalable AI systems. These are the points. So we'll see the part 2 session in the lab. So I'll give you a break here at this point. Thank you. Any doubts here, please? We'll discuss it in the next session. Just relax yourself. Then question answers, I'll answer it. I'll be the same person who is going to come. So let us meet in the lab, right?
Yeah. So now we'll proceed for tea break. After tea break, we'll meet in the computer lab. So please be on time, 11:30. Thank you.
Yeah, sorry, I eaten 10 minutes. Okay, don't worry. Yeah. Go.
The क्वेश्चन से पूछो कुछ खाली है क्या? Then we can try to out there.
सबसे उस दिन के लिए पूछा ना, उसको नहीं दे रहा है।
हाँ, दे रहा नहीं, खाली है क्या?
अच्छा ठीक है।
खाली एक लक्ष्मी मैम किससे पूछे तो खाली है लेटर लेके आओ बोले तो then you can go straight talk with JRC. वो दिक्कत नहीं है।
all those 4 into your local machine. Yeah, if anybody is having any difficulty, please raise your hands. I will come to your place. Yes, ma'am. This one. ఇది క్యాపిటల్ కే సార్, ఇది క్యాపిటల్ కే ఉంది కదండి, తప్పు ఉంది ఇక్కడ అడ్రస్. అవన్నీ డౌన్లోడ్ చేసుకోండి సార్. ప్లీజ్ డౌన్లోడ్ యువర్ లోకల్ మెషిన్. యూ కెన్ కీప్ దట్ మెటీరియల్స్ విత్ యూ. యా ప్లీజ్ డౌన్లోడ్ ఆల్ ఆఫ్ దెమ్. యా, ఫ్రూట్స్ డేటా సెట్, ట్రాఫిక్ సైన్స్ డేటా సెట్, one PowerPoint presentation. బ్రౌజర్ ఓపెన్ చేయండి సార్. ఎనీథింగ్, క్రోమ్ ఆర్ ఏదో రావట్లేదు మీకు వస్తుంది సార్. బాబు ప్లీజ్ లాగిన్ టు దిస్. అది వేరే వాళ్ళు లాగిన్స్ యూజ్ చేయకండి మేడం, జస్ట్ ఇంటర్నెట్ కనెక్షన్. ఓకే. Yeah, fruits data set. We will do some exercise, sir, now. We will do some data annotation. Just download it. No, don't open there. Download to your local machine. Download this one. Click download. So once you download, the file will be in a zip format. You please enter that code that you received from the phone. Sir? Yeah, please let me know anybody is having any doubt, any difficulty. So we start activity now. Once you downloaded the materials, how many of you completed? Please raise your hand. Still, okay, just complete it in a couple of minutes. Please do it fast. This password, do you know the password, sir? మీ పేరుతో ఉండదు సార్, జనరల్గా అది సార్ మీ పేరుతో ఉండదు. అది అంటే ఇది కాలేజ్కి, అంటే యూనివర్సిటీ నెట్వర్క్ కనెక్ట్ చేయడానికి అతను వస్తాడు, అతను వాళ్ళ లాగిన్స్ అవుతాడు. మీ లాగిన్తో క్రియేట్ అయి ఉన్నది. ఇది ఓన్లీ ఇంటర్నెట్ కనెక్షన్ కోసం ఫస్ట్. బాబు, ఐ థింక్ సమ్ ఆఫ్ యూ ఆర్ హ్యావింగ్ ప్రాబ్లమ్స్ రిలేటెడ్ టు ఇంటర్నెట్ కనెక్షన్. You need to authenticate. Just please call us, because authentication will be done by college person. There are 4 files will be there. Yeah, yes, sir. Okay. అది కాదు సార్, ఆ వెబ్సైట్ కూర్చోండి, పర్లేదు కూర్చోండి సార్, మీరు కూర్చోండి సార్. ఇది అవసరం లేదు సార్, ఇది కాదు సార్, ఇది క్లోజ్ చేసేసాను. ఇప్పుడు ఇక్కడ మీరు ఎంటర్ చేయాల్సింది ఇది క్యాపిటల్ కే సార్, స్మాల్ కే కాదు, క్యాపిటల్ కే. తప్పు ఒక అక్షరం తప్పున్నా రాదు అది. ఎంటర్ కొట్టండి. Small thing, sir. That's sorry. You just set flash. Enter capital, small letters. or okay, you download it. It will open sir. Flash. అవన్నీ డౌన్లోడ్ చేయండి సార్. 1 2 3 4 ఉన్నాయి అక్కడ. క్యాపిటల్ ఎంటర్ కొట్టండి. 4 డౌన్లోడ్ చేస్తాం. Okay. Those who have downloaded the materials, please start working on all of you please try to do the first exercise. Open another browser, open another window or another tab, or open another browser, whichever is comfortable to you, and enter the address. So the first data collection. So morning time you have seen that in the data collection stage, the first step is to collect some data. Now for you to understand, just you are doing some 5 minutes activity. I am collecting some data from yourself, means some form is created, it is a curated form. So once I collect the data, I will show you that the data is being stored at Excel sheet, and that Excel sheet data can be used to represent that meaningful information on a dashboard. So that exercise, to do that one, please enter this form address. The form address is this. Are you able to see the the second URL, please enter the second URL to complete your data entry. You can double click that file if you want. You can double click it, or you can use this any one, it is up to you. Suppose you are practicing orange software. Have you done? No, not yet. Maybe you will be doing in the later stage. Okay, so I will tell you what to be done in the later stage. I will tell you. Complete this, just 5 minutes task, please. Please complete that form, sir. Within 5 minutes you should be able to complete it. Yeah, most of them are open, right? Yeah, please try to complete that. What happens? ఇక్కడ సార్ మీరు సర్చ్ బార్లో కాదు యూఆర్ఎల్లో ఎంటర్ చేయాలి సార్. జస్ట్ కట్ దిస్ ఫ్రమ్ హియర్. ఇది మనకి బ్రౌజర్ కదా, కంట్రోల్ వ్యూ కొట్టండి సార్. కంట్రోల్ వ్యూ ఎంటర్, ప్లీజ్ ఎంటర్. రైట్, జస్ట్ సెలెక్ట్ చేయండి సార్. ఫస్ట్ వన్ ఈజ్ ఆల్రెడీ యూ డౌన్లోడెడ్ some material. Did you need to download the materials? Then okay. One second sir, not in the search bar. You have to enter here sir. ఇక్కడ ఇది యూఆర్ఎల్ అక్కడ తీసుకోండి. ఇప్పుడు అది ఫస్ట్ వన్ ఇన్ని మెటీరియల్స్ డౌన్లోడ్ చేసుకోండి. HTTPS జస్ట్ ఫస్ట్ వన్ // షార్ట్ URL .80/6 capital small ch capital press enter. మీరు డౌన్లోడ్ చేసుకోండి. ఈ మెషిన్లోకి మీరు ఎన్ని సెలెక్ట్ చేసుకుని ఒక్కొక్కటి డౌన్లోడ్ చేసుకోండి. ఈ అంటే కొంచెం డేటా సెట్ ఇచ్చాను మీకు నేను. మనం వర్కౌట్ చేద్దాం. ఇప్పుడు ఇక్కడ క్లిక్ చేయాలి. ఇది క్లిక్ చేసుకుంటే ఈ హ్యాంబర్గర్ మెనూ అంటారు మనం. హ్యాంబర్గర్ మెనూ నుంచి క్లిక్ చేయండి, డౌన్లోడ్ అయిపోతుంది. అట్లనే మీదే కూడా ట్రాఫిక్ క్లిక్ చేయండి, 1 by 1 చేస్తుంటుంది. అది వదిలేసింది సార్, అది వదిలేసింది. మీరు ఎట్లా సర్వే చేస్తున్నారు కదా ఇప్పుడు, నొక్కండి, పోర్టల్ చేస్తాను అక్కడ క్లిక్ చేయండి, డౌన్లోడ్ అవుతుంది. ఈ లోపల సర్వే కంప్లీట్ అయింది సార్. సబ్ అంటే మీరు ఏదో అది స్కిప్ చేసి ఉంటారు క్వశ్చన్ చూడండి సార్, కంపల్సరీ క్వశ్చన్ అప్పుడే అది ఎనేబుల్ అవుతుంది ఆటోమేటిక్గా. Yeah, only 1% has submitted as of now. 1% has submitted. Just check. Have you submitted, sir? No, just check. 2%. No, I can see the count here. Previously 44 was there, now 47. 3 persons have submitted. I can tell the 3 persons also who have submitted. No, just check it, ma'am. 3 persons are submitted. It will come, ma'am. Just hold on. Yes, red star marks are compulsory. Please, compulsory fields has to be entered. Yeah, 4 people have entered. I can tell Narasimhappa Raghavendra garu, Dr. Gandhi garu, Dr. Basha garu, Dr. Mallikarjuna garu, they already entered. 4 people have entered it. Yeah, 50 means 6 people have submitted. Just complete it within 2-3 minutes, please. No, this is not the only activity. Just check yourself. Some people have submitted. Just check. Let have a practice of submitting also. That is also one exercise only. Sir. Okay. So I think you selected a wrong form. If you are selecting the form from the shareable folder, that will not allow you to submit. It is only the data, the form is been shared. Please take it from the link. You might have clicked the opening the form from the folder. Please don't do opening the form. You want the link, huh? Okay. Yes, sir. What happened, sir? Which one did you select, sir? This form from this folder? Then you will not get, sir, because that is an editable one. Please సారీ యూ ఓపెన్ అడ్రస్ ఈ సెకండ్ నుంచి చూసారా ఇక్కడ ఈ కాదు సార్ ఈ అడ్రస్ చూడండి ఇక్కడ మీకు ఈ అడ్రస్ డిఫరెంట్ ఇది కొద్దిగా సారీ అది ఇది తీసుకోండి సెకండ్ అడ్రస్ తీసుకుని మళ్ళీ టైప్ చేయండి సార్ అదే ఫార్మ్స్ డాట్ టైప్ చేయండి సార్ ఫార్మ్స్ డాట్ రాదు సార్ అది రాదు అది మీకు అది సారీ మిస్ అయిపోయింది కొత్త ఓపెన్ చేయండి లీవ్ ఇట్ నో డోంట్ యూ మైట్ ఓపెన్ ఫ్రమ్ హియర్ రైట్ సార్ ఇందాక మీరు ఇక్కడి నుంచి ఓపెన్ చేస్తారు వద్దు అది మీ దగ్గర ఫామ్ ఉంచుకోండి నెక్స్ట్ ఉంచండి న్యూ ట్యాబ్ ఓపెన్ చేయండి సార్ అక్కడ ఎంటర్ చేయండి అక్కడ సార్ అక్కడ యూఆర్ఎల్ ఇది సర్చింగ్ ఆల్వేస్ మన అడ్రస్ ఎక్స్ప్లెయిన్ ఇక్కడ ఎంటర్ చేయాలి సెకండ్ వన్ మీరు ఇంటర్నెట్లో లేరు సార్ కానీ ఇది ఈ విండో వచ్చింది మీకు కొంచెం అండి అయితే ఆల్రెడీ ఇందాక లాగిన్ అయ్యారు మీరు ఎంటర్ చేసి ఇది అయితే పర్వాలేదు ఇది జస్ట్ క్లోజ్ చేసాను అంతే అదే నా డౌట్ ఉంది ఇప్పుడు అదే మల్టిపుల్ విండోస్ ఓపెన్ ఉన్నాయి క్లోజ్ చేసేసుకోండి సార్ లేనటువంటి you already submitted sir no most likely you might have submitted sir ఒకసారి అంటే వన్ టైం నేను సెట్టింగ్ చేసిన ప్రకారం ఒక్కసారి తీసుకుంటాను అనమాట అంటే మీరు సబ్మిట్ చేస్తుంటారు ఆల్రెడీ చేయలేదా అయితే మీరు సింపుల్గా మళ్ళీ ఓపెన్ చేయండి అట్లాంటి అప్పుడు మీరు మీ ఓ అది ఇది సైన్ అవుట్ చేయండి అట్లాంటప్పుడు ఇది సైన్ అవుట్ చేసిన తర్వాత మీరు మీ సైన్ ఇన్ చేయమన్నాను అందుకనే ఫస్ట్లోనే మీరు మీ సైన్ ఇన్ చేయాల్సింది అది అప్పుడు చేయలేదు అది ఇప్పుడు సైన్ ఇన్ చేయండి సార్ ఇప్పుడు సైన్ ఇన్ చేసిన తర్వాత అది ఇది నొక్కండి No, they might have opened from the folder. No, I told not to do that. That's why where it is. One second, sorry. ఒక నిమిషం అండి ఇది తీసుకుని కాపీ చేసి ఇక్కడ పేస్ట్ చేయండి అంతే వెళ్ళారు సార్ ఇల్లు సారీ ఇది ఒక్క నిమిషం ఏమనుకోద్దు మీరు ఆ సెకండ్ ఎంటర్ చేయగలుగుతారా సార్ మేడం ఒక లింక్ ఉంది కదా ఒకసారి టైప్ చేయండి ఇలా టైప్ చేయండి మీరు అది కంప్లీట్ చేస్తే ఫినిష్ చేశాను మేడం ఒకసారి ఫార్మ్స్ డాట్ నో దట్ వాజ్ ఆల్సో ఇన్ ప్రివ్యూ ఒక్క నిమిషం మేడం మీరు ఎక్కడున్నారు వదిలేసాను పర్వాలేదు టైం వేస్ట్ చేయకండి ఇంకా వదిలేసాను చెప్తాను ఒక నిమిషం ఇప్పుడు వస్తుంది మేడం మీకు ఇది ఇప్పుడు ఇది వస్తుంది అది ఓకే So I suppose majority of them have done. Let me just check how many of you have submitted. Around 65. 65 means previously there are 44. 65 minus 44, 21. 21 people have submitted. 30 members. Okay, still 9 people are yet to be submitting. How many are still doing? Can you please raise your hands once? 1, 2, 3, 4, 5, 6. Now I am going to share the previous batches. Last week we conducted one training program. Their responses are also there. I am going to share the entire data to you. Whatever you entered data also now I am going to share to you all. Just give me 2 minutes time. Now why I am going to share the data to is, I am giving some data. Now this data is what important here. You are seeing different questions are there. For different questions different people have responded it in a different way. So what will be the most likely the issues with respect to this data? Once we collect the data, what problems are likely to be foreseen? Usually, normally what problems were there in the morning session we were discussing there? Missing data, very good. So here, actually when I am collecting the data itself, I put some star marks. It means the data has to be compulsorily entered. If suppose I might have kept option, some people may enter or may not enter, yes or no? And those who are not entered, definitely there will be a missing value will be there, empty value will be there. Now that is the biggest problem for me later, how to handle that empty. Not only that, when I am collecting the data, I already kept one important point, only one response for one participant. If I allow more, obviously more data will be coming, it will be basically a problem. What type of problem? Duplicates will be there, yes. But while collecting the data itself, I am avoiding all those things. Empty values I am avoiding, trying to avoid. Duplicate values also I avoided it. But still, can you just foresee or try to think what else the problems can be there? Multiple selection answers can be there because multiple options I have given it as curated questions themselves I have given the multiple answers. So, well, data analysis is going to happen, means the data analysis or the AI machine learning model has to be prepared now. Now, with this data, what AI system I can prepare? Can anybody tell me? Okay, I collected the data now. What is that I am going to do with this data? Data is very valuable to me here. So, what is the data I collected? I can just show you the data now. 68 people have completed. Let me view this data here. So, where the data has been stored? Data has been stored in a Google sheet, in a spreadsheet. So, if you see here, this is today's date is 10th, yes, exactly last week there was data. So, from here 46th row onwards, so these are the data items if you see here. Now you see here, one of them have not entered the mobile phone. There is a missing value in your group only just now. And one of them have entered the mobile phone in a different one because I did not kept in a different, now the different format. So, do not look at that, I am not looking for anything, just for our discussion purpose only here, just trying to understand the data problems here. Sometimes, yes, here see the mobile number is 94, the mobile number is incorrectly entered now. Different issues are coming here with the data entry itself. Definitely there is, if you collect the data from all the citizens of Hyderabad, now you see the millions of records will be there. Now, how do you process that data? What pre-processing techniques has to be applied? This is very important. Now, with this data, what AI system can be developed? Can anybody tell me? Before understanding that one, what is this indicating? What is this first row is indicating? These are your attributes, very good. So, with attributes or called as features or called as characteristics or called as dimensions or called as what else? 10 different synonyms are there. Now, you tell me with those attributes what AI system can be modeled. I have some questions which have been specifically been asked from you to answer it. Background of the participants, very good ma'am. Just one question now. I want to automate it. What will be the participants' knowledge or what can be the skills that are already been existing there, so that I will come to know now some kind of decision I can make it. I means basically machine can make an understanding here. So, how to properly train you for the next sessions or how to make an understanding, some kind of understanding is been done from your data collection actually. Now, to make some understanding of the data, once you collected the data now, to have some basic understanding, what are the tools to be considered? If you have seen my slide, now what is the software which I mentioned it in my slide? Please see the slides now. Please open your slides in the next window. Open the slides now. Teachable? No, teachable machines, that is a data machine learning model to be prepared. I am not talking about that is annotation. Yes, please. Yes, Looker Studio. I have given a link there. Now, open lookerstudio.cloud.com in the next window. Okay, please stop entering the data in the form now. Those not entered, do not worry. You have time till today evening. Whenever you have some free time in the evening, please enter it. Don't worry. Now let us do that exercise here. I am going to share this particular thing to you all now. So if I am going to share the data to you all, you might already familiar that when you are trying to download it, it is asking in what form of data you need to download. Traditionally, these are the different .xlsp, then .csv. So most normal form, most common form is what your dot comma separated values. .tsv stands for dot tab. So, but I am trying to download using CSV here. I download it and I will try to send that file to you all. Okay, I have shared the data to you all. Just check your emails now. You might have received the Excel sheet. I just send the Excel sheet to you all. In your email, whatever the email you entered in your, I am able to do that one automation. You don't worry about that. Already I obtained your email IDs. Just for your classroom session discussion, I will not misuse your email IDs. Don't worry. I will not abuse you. Don't worry about that. Yes, that's why. What is the first step that you already done? You agreed to that data collection, but what is the first step? No. What is the first statement that you already agreed to that? You put a tick mark. Already taken the consent from you that I am collecting it for experimental purpose only. Always data should be, that's why don't give your mobile numbers, your email IDs to anybody until unless it is a scientific purpose. This is also because you are all one group only, we are sharing the data with you all for understanding purpose only. So don't worry, it will not be misused for some other purpose. Right. Did everybody receive that Excel sheet? Okay. Now one exercise I am telling you, upload that Excel sheet into your own drive. In your drive, in your Google Drive only, please upload that Excel sheet into your own drive. How do you upload to your own drive? Already you download. Add to drive, yes. So go to your, otherwise those who are not aware of, please look onto my screen. Click here, drive. I already logged into my account. So you will have the drive apps. Just click the drive option, click the drive, then select, please look onto my screen, new, then file, upload. Once you select the file upload, your Excel sheet will be there with AI modeling workshop. Select this AI modeling workshop and click open. So at the bottom of your screen, you should be able to see a tick mark, once a green color tick mark, which indicates that the file is uploaded to your drive. Yes, ma'am? Done. Okay, now please open to the Looker Studio. Go to the Google search bar. All of you please look onto the screen, please. Looker Studio. So you will get the first link itself. This is a free software only, you don't worry about that, please. I think you will be learning another tool called Orange. So you can use Orange also. This is another tool. In the Orange also you can use your Excel sheet to prepare your AI system. That another teacher or another instructor will be giving you the steps. That's why I don't want to disturb you with that one. I'm just showing you with another software called Looker Studio here. Click the Looker Studio, Google Looker Studio. Are you getting this one, ma'am? Okay, no problem. Lookerstudio.google.com, anyone you can take it, ma'am. You will come up to, you will land onto this particular page. No, did you log into your email account, ma'am, first? Then 19, okay, I am coming to you, just hold on, ma'am. Others, are you able to land onto this page, please? Yes. Now, just I'm coming, ma'am, just hold on. Once you get this one, please select blank report. Okay, please select this plus symbol, blank report. Click here. Once you click here, then it is asking connect to data. It means it is asking where is your data. Sorry, sir. Okay. First time, because you are logging for the first time. Sorry, I forgot to tell one step. That is just asking you to where you are going to use that particular software. Just country login. Okay. After that, your company self. Just say self. SCLF. Self. Or you can give your name of your son. Just that it needs some dummy data. Yes, allowing your, if you are logged in with your college email or college domain name, Google will not allow, because college may have not subscribed to that. Then you will have organization. కాదు మేడం, మీరు ఇక్కడ మీరు ఈమెయిల్ మీరు ఆ డేటా డౌన్లోడ్ చేసుకున్నారు ఇందాక ఎక్సెల్ షీట్ రాలేదు మీకు, అది మీరు సబ్మిట్ చేసుకున్నాక నేను ఆ ఈమెయిల్స్ కాపీ చేసుకుని మిస్ అయి ఉంటారు. డోంట్ జస్ట్ ఒకసారి అబ్జర్వ్ చేసుకున్నాను ఏమనుకోండి. నో దే డి నాట్ రిసీవ్ ఇట్. ఐ అండర్స్టాండ్. జస్ట్ ఆస్క్ దెమ్ టు సీ. Yeah, it is not the important. Next, another task is that is important task. Just no problem. Okay, blank report. Why it is taking time for one. Your college address పెట్టారు ఇది. No one select them. ఇది స్లోగా మీరు వస్తుంది మీకు వస్తుంది. Yes sir. So already you got the data, right? Your data from your drive, right? Sir, yes, you upload చేసుకున్నారు కదా sir. After this, yes. So once you landed up to this page, you need to bring the data. the data will come from your Excel sheet. Either you can upload the data from the Excel sheet, or you please select this one. There is an option will be there. Here you can see, just scroll down. Once you scroll down, it will ask you to, your data is present in Google Sheet. So data can be present in different ways. Google Ads, if you see here, there are various ways, various sources where data is available. But in our case, at present, our data is present in the Google Sheet. So I am just selecting the Google Sheets here. Excel sheet also you can take it, sir, no problem. Don't worry. Microsoft Excel sheet. So now once you select the Google Sheet, all of you just listen here once. Then whatever the Google Sheets that are there in my Google Drive, it will be displayed like this. Now, yes, now you can select the Google Sheet from this one, sir. This is a software where you are not writing any single line of code. Please listen here. Like Orange also, you will not write single line of code there, because you are non-computer science and non-IT guys. So just have a practice of how to visualize the data, how to prepare AI systems without writing single line of code. That is the basic purpose of this exercise. Yes, I am just selecting this particular, whatever the name of the sheet is, AI modeling workshop, participant survey. Click add. So once the sheet is added here, now you see you are about to add data to this report. Yes. Then the data will be shown. All of you see here, on the right hand side, your actual data will be shown here. On the left hand side, on the dashboard, there will be empty screen here. All of you just look onto the screen please once. Please don't do it simultaneously. Just listen to me, then I will give the time for you to do it. Okay, just listen to me here. Once you upload the data, your Excel sheet will be shown here. That is what under the name data. So what is there in this one? Section 5, research and career, 10, 12, whatever the questions you have given here, all the questions along with the data values, it will be there. Now what is that you are going to do with this data now? I am going to first visualize the data, means understanding of the data, because most of the time before preparing the AI system, your data will be very huge. Always any programmer or any developer first should understand the data. It is not that directly, oh, I have now data, I will write my program to prepare an AI system. No. So minimum common things that are required is to understand the data first. To understand the data and some internal details about the data, you need to visualize the data. That's why this is called as report preparation. You can give a name, you can save that and understand the data properly. To understand the data in the visual form means in the diagrammatic form. So what are the various ways in which you can visualize the data in the diagram form in your school days? Usually graphs. Very good. Graphs means two-dimensional charts. Two-dimensional charts, if you might have remember, in our school days we used to plot the data in the form of charts. So that you have bar charts, pie charts, so many forms of charts are there nowadays. You can practice all of them without writing single line of code. Please understand. That's what this software is going to give it. Of course, I am not teaching you everything in this particular half an hour. Later when you have time, when you go home, later you need to practice it, you need to explore it. So please take some time to understand various forms of charts, various forms of things, how the reports can be generated here. Now, for example, so I am just taking, once the data is here, right. I told in the CSC, if not from the Google Sheet, you upload the sheet, sir, don't worry. There will be another option here. Just check it, it will be uploading option will be there. That uploading option you try to put it there. Just try it, I am coming there, one second. Okay, just give me 2 minutes time, just see it on the screen, still not completed. So once you give it, select the responsive layout. So you are seeing the responsive layout has been selected. Once the responsive layout has been selected, so suppose confidence in building the AI model. I am just bringing that particular question. Now I drag that particular question. I drag that particular question onto this particular screen now, and select that particular question values and select whatever the charts you have it on the insert menu item. In the insert menu item, you have different types of charts are there. So you can visualize this particular data in different formats, in different forms for you to understand that. So you can see here now pie chart is generated. Pie chart has been generated here without writing a line of code. What is the meaning? You can see here. You can just visualize it. So a lot of email people have given. Let me just show you another step one more time. How many people are interested in AI? So there is one question was there. Area of interest. Area of interest in AI. You don't know how many people were really interested. How much is the percentage of people who are really interested in AI? Now I want to visualize it just by looking to that data. So what I do, I select that question there, area of interest, select that question, drag it onto your screen here. Select it, drag it here. Once you drag it here, once you select and drag it here, you got some responses here, area of interest, that is the response coming. If you want to pictorially see it, so select that data and go to your insert and again go for your pie chart. So now you can see here the pie chart is generated here. How many people were interested in AI? Let me just see the answer once. So I can see here machine learning around 16 people, 22.5, others around 20 people, 28.2, IoT plus AI only 3 people, 4.2%. Along with the percentages, I can see it here. Generative AI, around 8 people are interested. So immediately I can know here. If you at all thousands of people's of data, millions of records are there, immediately once I visualize it, I get the dashboard so that I can make some decisions accordingly. So this is one small exercise to understand how to prepare some dashboards. Similarly, you will practice again in another software tool called as Orange, that you will see it in the later stage. For this exercise, just try to understand how I am bringing the data and visualizing the content to make some kind of understanding and making decisions. This is one small exercise. Please, I'll give just 5 minutes time for you, 5 to 10 minutes. I'll be moving around. Try to complete at least pictorially representing some fields here. Okay? So please raise your hands. I'm coming there. Yes, please. Okay. So did you bring the data ma'am here? Okay, you have not brought the data from here. One second, sir. I'm coming. You have some APSCHE, FDP on March, some data, some Excel sheet is there here. Okay, because did you keep the data? Yes. So this you did you download, ma'am? Did you download it? Okay, go to Drive here. Drive. This is just AI modeling workshop. This is done here. Refresh it. This one, right? Tab separated values. Yes, sir. Tableau. Yes. Same thing. Tableau is another software to same thing. Whatever Tableau is doing, this Google Looker Studio is doing for you. This is equivalent to Tableau. This is equivalent to Orange. Same thing. But these are all free. But Tableau requires payment. For some days, it is trial versions will be given. After 30 days, again you need to pay. 1 second. Yeah, tell me, sir. No problem. I'm listening. Please tell me. మీరు ఇది డేటా అప్లోడ్ కాలేదు మనం, అందుకని ఏం చేయాలంటే ఒక్క నిమిషం, లెట్ మీ గో బ్యాక్ టు ద ప్రీవియస్ డేటా సోర్సెస్.
Okay, now where is this Google Sheet, right? Okay. Where is consultancy ఇక్కడ డ్రైవ్లో రావాలి యాక్చువల్లీ ఇక్కడికి డ్రైవ్లో రావట్లేదు అంటే ఓకే CSV ఫైల్ అప్లోడ్ చేద్దాం డైరెక్ట్ ఈ ఆప్షన్కి వెళ్ళండి ఆథరైజ్ మీ గూగుల్లో లాగిన్ అయి ఉన్నారు కదా ఆల్రెడీ ఓకే యాడ్ ఫైల్ వెరీ దిస్ నాకు డౌన్లోడ్ చేసిన ఇక్కడికి డౌన్లోడ్ అకౌంట్ ఇక్కడ కానీ డౌన్లోడ్ లోకల్ కదా మీరు డౌన్లోడ్ చేశారు కదా ఇందాక ఇందాక డౌన్లోడ్ చేయలేదండి మీరు ఇది ఉన్నది ఎక్కడ ఉందంటే ఇట్ ఈస్ డౌన్లోడ్ ఇప్పుడు అయింది మేడం ఇది ఇందాక అవ్వలేదు 12:21 ఇందాక మీరు డౌన్లోడ్ చేయలేదు యాక్చువల్గా మరి డౌన్లోడ్ చేయకుండా ఎట్లా అప్లోడ్ చేశారు మేడం అది అవ్వలేదు అది సారీ ఆ మిస్ అది మిస్ ఓకే లెట్ ఇట్ బి లెట్ యాడ్ ఫైల్ హియర్ go to download yes now you can upload this one. Name here ఇక్కడ వచ్చింది సార్ ఇక్కడ వచ్చింది సార్ ఇప్పుడు ఈ స్టెప్ ఇందాక నేను చెప్పాను కదా ఇది అది నౌ యూ కెన్ స్టార్ట్ వర్క్ దీస్ ఆర్ ద ఫీల్డ్స్ నౌ ఇక్కడ ఇప్పుడు ఇందాక నేను చెప్పిన స్టెప్ చేయండి సార్ yes sir that's it but you can design it properly later okay yes that's that then you got this right and you can customize now this one customize this with all the fields that you want to have it later you can do it sir now it is done yes you can get it from the download but you are able to do it no sir now that is fine sir that should be okay sir that is what the need for this is at this hour is that one only yes sir yeah okay if you are not you are not in the drive okay those are not able to put them in the drive you can use CSV file you already I uploaded it డేటా ఇక్కడ చూపించాను మీకు కంటిన్యూ రావట్లేదు మేడం అది ఒక్క నిమిషం చూపిస్తాను లేదు మేడం ఇక్కడ సిగ్నల్ రావట్లేదు మీకు ఇక్కడ ఇది సిగ్నల్ ఇక్కడ పాయింట్స్ ఫైల్ విచ్ ఐ షేర్ టు యూ దోస్ యు ఆర్ నాట్ రిసీవ్డ్ ఇట్ ఓన్లీ 3 మేడం జస్ట్ లెట్ మీ నో యువర్ ఈమెయిల్ ఐడీస్ మీ గ్రూప్లో పెట్టేసండి సార్ ఏమైనా if you can access from the WhatsApp ma'am please access from the WhatsApp or just tell me I'll send it from here 1 second ma'am Durgamama ma'am yours I think Ishwar Rao garu yes sir I think Sharmila garu okay and Venkatramana garu I think you might have not received these files for these four people I am just sending the files again ma'am Madam, I have sent just now. Please download the files now. Yes, ma'am. Which one, ma'am? Yes, see, okay, these are, okay. This data is there, ma'am, actually. Now, where are you? Why you come up to this point, ma'am? Actually, where are you? Once you added, you have not added this one, actually. One second. Let me go back here. Where are we? CSS upload. Oh, you missed the step somewhere. Yes, we are not able to connect it here. Let me connect here. Then you will say add report will come here. Yes, create report is there now. Now this is a free software. Looker Studio is a Google software only. So tomorrow it will be useful for you whenever. Now you got it. Yes. Now you go to response field. Okay. Click here. And now suppose you have to this based on you want to analyze now. That is what analyze is. So you will have actually this is a huge quantity of data. You will have millions of records there. So it will be very difficult for people to understand the data first. But to understand the data, you have to visualize it first. So what you are seeing is nothing but visualization. So how have you published? Suppose I want to know how many people have published. So I want to understand this data. Just select it and drag it to your screen now. Now the data is coming here now. See here, have you published any research paper? Some people have given the answers to this one. First you select this one, go to insert here and you select the mode of display. Suppose I want to see how many in the form of, everybody knows pie chart, that's why I am taking pie chart example here. So now let us see here, we see how many people are, yes, so 50% almost actually. 50% say that they know how to publish, some people say they don't. Immediately I come to know, but how many people are there? Around 70 people are there actually. Out of 70, it means 35 people are yes, 35. Like this you can understand the data immediately now. Drag it and select it. Yes, sir. This is stacked bar. This is called stacked bar. What do you want to do? Oh, you download it, sir. You click here now. Okay. So what do you want to do, sir? You downloaded it now. Then what do you want to do, sir? Yes. You want to upload this data now. You go to see now. You see this is. I will tell you from the beginning. You just give a name to this one, sir. All of you, please give name to your reports, your Excel sheets. Of course, I am not telling that particular point. You just click here. Okay. You just save it. Please save your works. Please try to know how to save your works. Something like sample one idea. Okay. Now you give the name, then go to file. Okay. So make a new report here now. So once the new report comes, then again you need to connect to that Excel sheet. Yes. So which one Excel sheets are you using? You downloaded, no? Okay. Google Sheets means that file should be there in that. It is locally available, no? It is CSV file download. CSV file not authorize that one. Yes. Okay. Email authorization. Okay. Yes. Add file. Then this one only, no, sir? Then click open. This is something like sample 2. You give it. Continue. Yeah, it is loading, sir. Just a moment. Yes, once it is loaded, now you add this data set to your report now. Click add. Yes, click to add it to report. So many things here. The requirement is very high, sir. According, I will show you the syllabus what is given to me. So, you just give name to this one, ma'am. Yeah, display. Select the field, sir. That's it. Yeah, select it and drag it to the left. Yes. Then now you display it. Yeah. Give a name to it. Yeah. Yeah, responsibility. Response means response is there between you and the system actually. That's called responsiveness. Yeah. Then you select pie chart, bar chart, different types of representation. Okay, now I will move to the next data set. Those who completed that, let us move to the next data set. Those who are not able to do it, don't worry. Still time is there. I am coming to your system, but those who have completed it, so that I will not waste their time. Please follow the steps on my screen. All of you, please just give 2 to 3 minutes time and look onto my screen.
So most likely, see here on my screen, you might have downloaded one data set. The data set is called as fruits pictures, right? You already downloaded. I am showing it on my screen. Once it is downloaded, it will be downloaded as a zip file. What I observed in the last week is some people unable to extract the zip file. For them, I am just showing you how to extract the file. That is the only purpose. Otherwise, those who know it, please do it now. If that is a zip file, I hope you can unzip the file, right? Those who don't know, please look onto the screen. Once you downloaded that fruits, please all of you look onto my screen just for 2 minutes only. Yeah, because you will be receiving a zip file. You can see it on my screen. So zip file always will be shown something like this. It is not an ordinary file. What do you mean by zip? Zip means it is compressed file. Compressed means the actual data size will be different. That files are all been compressed to using a particular technique, using a particular algorithm. The file was condensed. Condensed means it was reduced to a particular size. So you will also be, once you open, you will be coming to this zip file. If it is a zip file, what you need to do is go to that folder. Mostly in your downloads folder will be there. Right click that particular zip file, select it and right click your mouse and go to extract here. Extract here. Just click this extract here, or you will see some systems will have unzip. Extract all. Okay, you might have downloaded the other files also, no problem. Extract all or unzip all. Any two words you may be seeing on your system depending on the operating system. Some systems will be having different. So what I am showing is, I am clicking here, extract here. Once you extract here, yes, once you extracted here in the downloads folder only, that's what extract here means. This zip file is been unzipped and you will see a folder symbol here with the same name, fruit pics. First you need to get this to this folder. All of you have to unzip it and get this folder. Once you got this, double click and see, basically you will see some fruits pictures will be there. You are not getting fruit pictures, ma'am? Oh, okay, names, that is just a appearance only, ma'am, don't worry. If you are getting names or icons, let it be, ma'am, you have the data. It is only you are to select the different view, that's all. Go to the view and see. Once you got this one, all of you listen here, the important step. Go to the website, makesense.ai. Makesense.ai. No, don't type it, please listen here, just give me 2 minutes time, otherwise you will miss the step. Once you go to that makesense.ai, you will come to a particular browser, a web page. Please listen here, please all of you, I request you, don't see your monitors, because the important step will be missing. First you see the step, again it will be a repetition for me. Okay. Now once you come to this, right side bottom you see get started, just click the, just click here, get started, click the get started, then it will give an option of drop images. It means you need to upload your data set. So click, so where you have to go for, you have to go to your fruit pictures. So select the fruit pictures. Sir, please don't do it, just see the step here. Select the fruit pictures and click open and select all the pictures or few of them, is up to you. Once you click here all 60 images, I have uploaded it. Now the first step of data annotation, you are seeing something called data annotation. So you are selecting object detection, click object detection. Please all of you listen here, sir, please don't see the important step here. You will come to this particular page, go to the plus button, click the plus button and first to give the labels to your data set. So what are the labels? I know that I am playing with a data set called as, I'm using a data set called as fruits here. So you know, or you may be seeing, you might have seen that images there, and you know that most likely the fruits are, some are apples. Then use this particular screen first to create a labels. So there is a different ways of importing the labels.
or if you don't know how to import it from a file, you can give the names here explicitly. You can give the names here. So apples, then I'm adding another one, orange, I'm adding another one, I think banana, right? So banana, like this, some, okay, you can add some more things later. So you add all the, sir, just listen here, sir. First add all the labels. Once you created all the labels here, later also you can do it. Once you create all the labels here, then you click the start project. So once you click the start project, now you see here by default one image will be shown on the screen. Whatever the images you uploaded, the one of the image will be shown. You can see one by how many images you uploaded, 60. It means you can use these arrow marks to scroll to the next images. Now I am playing with one particular image. So what you see here in this image, actually we all know that these are fruits and related to apples. But now the machine should understand this looking to this image, which is to be called as apple. Which particular image part, which particular part of the image is to be called as apple. So for that I need to annotate this one, I need to label this one. So what need to be labeled here on the right hand side, of this image, you will see rectangle, you will see point, you will see line, and you will see polygon. All these things you have to practice it today. So first I am using this rectangle here, please listen here, rectangle. Once you select this one, otherwise if I am using polygon, polygon will be shown like this. If I am using rectangle, rectangle will be shown like this. So you will be having a cursor pointer. This is called as a cursor. You can use your mouse pointer. Use your mouse as a cursor pointer now. So now I am selecting this. So use your mouse, select the image, select it properly. The shape of that image was selected is rectangle shape only. So I use this mouse pointer, click here at this particular point, and I drag that mouse pointer to this particular point. It means I am selecting a particular region of this. One region is being selected here. This region is nothing but, now once this is highlighted here, this box is called as, basically this rectangle shape box is called as bounding box. Please remember, this is called as bounding box. Basically this is nothing but, if you see clearly what is x, what is y, the coordinates of this box are being shown. These coordinates always start from the top left will be 0 0, top left this particular thing, not this particular thing. The top left is 0 0, and this will be the maximum size of that image. So coordinates will be increasing in this way. X and y coordinates. This is x coordinates, these are y coordinates. So you are simply using this mouse pointer here, this particular image. Now you select here. What is this called as from this image? You have to give a label to that. What is that label? Yes, select that. So before labeling, already you listed out what are all the possible labels are there. So among this list, you select that particular label now. So I am just selecting it as apple. Similarly, I am selecting another image here. Now you selected this already. This is called annotation. This is called labeling from the image side. These are images, and you are labeling that images. Now again, this particular thing also is apple only. So again, you have to give some label to this. This particular thing is also apple. Now you see here how laborious it is. Each image you need to accurately specify which particular part of the images are apples. Here also this is apple. Now you go to the, once you are given the labels something like that, go to the next image by clicking this. Now this is also to be called as apple. Suppose like this, every image, how many images are there? 60 images are there. You have to give the labels in each image, which part of the things are there. For example, if I go to, all these are apples of different sizes. Now what is this one now? Yes, select that particular image, select that particular part. It is not apple, actually it is banana. So picture number 22 of 60. Now this I have labeled as banana. Now go to similarly like this. I am just randomly I am selecting here, but you have to do it. What are to be called as banana? Now here, yes, this particular thing is apple. This particular thing is orange. This particular thing, the third one is called as banana. I am giving multi labels here. In one image only, multiple labels I am giving here. Not only one single image, single label, but I am giving multiple labels. So like this, now this is grapes. Now you don't know the label here. Again, where you have to get grape label? You go to your actions part and add the label and bring the label here. So now here this is what to be called as orange. This is to be called as selected. Your mouse pointer is important here. This is to be called as apple. This is to be called as banana. Every picture. How many pictures? Like this, 60 pictures. 60 pictures itself will take almost 60 days for you if you are doing it. And once this data is been annotated, please remember one last step I am telling, then I will give time for you to do it. Then what you need to do is go to actions part and you have to select export annotations. Export annotations means, yes, you have seen the so many images are there. Each image you have told that this so and so is apple, so and so is, it means so and so features the machine will now understand. Oh, the color of that fruit, the size of that fruit, the orientation of the fruit, with the different lightnings of that images, different positions, all that, so many things. That is called huge collection of data. You give that huge collection of data to the machine. Now the machine will understand apple means this color, this size, this picture. Banana means so and so image. Grapes means so and so image. Then the machine will understand. So in the childhood days, when the teacher is trying to make the student to understand, teacher will be showing some pictures. This is banana, this is cat, this is fruit, this is like the same thing. Now we are training the machine actually. To train the machine, you need to do the annotation. This is manual annotation. Manually you are doing. This type of annotation is called manual annotations. But this is a laborious process. But if you do it properly, this will be the accurate process. But to prepare a machine learning model with so many image classifications, huge collection of data is there. So earlier, data entry operators, people were recruited for this kinds of preparing machine learning model in the last 10 to 15 years. But nowadays, this laborious process is also been minimized by taking the help of AI models. Some algorithms have already been developed not to do this laborious process. Algorithms have come that is automatically doing. One such automatically doing software is called as RoboFlow. So when you go home, please try to use the RoboFlow. This is also free only. You can use the RoboFlow for automatically annotating it. But today, for this thing, okay, now you do this exercise. In the last step, export the annotation. So click, you are exporting. It means these images along with this image, what are the labels? You are entirely exporting it now. And when you export it, what you see here is carefully is what you are exporting it in terms of different formats. Formats are there. For preparing it in a machine learning model, different formats are there. So one such format you already know. What is that format? The basic format is CSV. That is very old traditional format. But later today, because of the advancements in the software and the processes involved in preparing the data properly, different formats have come. One such format is called as JSON format, JavaScript Object Notation, because that format will allow transport of data from one process to another process very easily, from one machine to another machine very easily. Before JSON, there was another format called as XML, Extended Markup Language. CSV, Extended Markup Language, were there in the market for almost 20-30 years, but they have their own disadvantages and limitations. But for today's technology, the latest format which can be used to transport the data, because now you have done annotation on your computer, this computer, but tomorrow your machine learning model will be developed or prepared on another machine. For that, you need to now take this data and put the data and give the data in another machine. So which is the most apt way, which is the most appropriate way? The format is JSON format. And another format is called as YOLO format. You only look once. YOLO is the abbreviation for you only look once. You only look once. Yes, that is one algorithm, one methodology. With the latest Ultratix companies, most of the image classification, image detection algorithms, they use this particular YOLO format. So depending on the technical knowledge, the machine learning model preparation, you need to collect the data and export it and send it to that. So your data is, your task in this class is up to only exporting it the data. So once you select this one, single CSV file I am selecting for you to understand. Export it. Once you click here, yes, now you see the labels. You give a project name, then that project name will be created under that one. Up to that one, you please all of you do this exercise. Now you have another 15 minutes time. Please do that one. And one more software tool is there. Please try to complete within 10 minutes so that in another 5-10 minutes I will show you another tool. Yes. I'm coming. So please, sorry sir. 10 images, 10 to 15 images, need not be 60 images. Just 5 to 10 images, at least 5 images, try to do it. You will come have some exposure to. Whenever you have time, later you do those exercises. You can just select it, ma'am. Select it and remove the name. You see, there is a symbol here. What is this symbol? Cross mark. You selected this one, huh? You select this one and click this. No. That one you are removing the another. One second. Where is this box? Huh? Box you just select it and click delete me. If you don't know that, but you say selected, you automatically highlight it down. Yeah, any doubts are there? Please raise your hands. I'll come to your place. Overlapping can be done. It is very much accurate, technically speaking. Sorry, sir. You select all, sir. Yeah, you selected only one image now. How to select multiple? Yeah, select shift. No, put your mouse pointer there. Shift key, use shift key. Select all. Drag it. Mouse pointer. Just to select this. Immediately select this one. Drag this. Yes, sir. Any doubts, sir? You select all of them, sir. You select just open. 1 second, sir. Maybe you select this, sir. Shift పట్టుకోండి arrow mark యూజ్ చేయండి అని సెలెక్ట్ చేసుకోండి అట్లా మీకు ఎన్ని కావాలంటే నేను సెలెక్ట్ చేసుకుని ఓపెన్ కొట్టండి ఓపెన్ క్లిక్ చేయండి ఆ ఇమేజ్ వచ్చింది ఇమేజ్ రికగ్నిషన్ వద్దులేదు సార్ ఇమేజ్ డిటెక్షన్ చేయండి ఫస్ట్ లేబులింగ్ చేయాలి కదా మనం ఈ బ్యాక్ వెళ్ళండి సార్ ఏమనుకోవద్దు బ్యాక్ వెళ్ళండి జస్ట్ యూజ్ దిస్ బ్యాక్ బటన్ ఓకే ఒకసారి ఓపెన్ చేయాలి నెక్స్ట్ సెన్స్ ఈ డేటా సెట్ డౌన్లోడ్ చేసుకున్నారు కదా సార్ ఇందాక డౌన్లోడ్స్ ఉంటుంది మోస్ట్లీ ఎక్కడ ఫ్రూట్స్ మీరు ఫ్రూట్స్ది లేదా ఇది ఇక్కడ ఉంది కదా ఫ్రూట్స్ ఇది ఉంది కదా ఇది సెలెక్ట్ చేసుకోండి ఇంకా ఫ్రూట్ పిక్ చేసి ఇక్కడ ఉంది కదా అంటే వేరే వాళ్ళు చేసినట్టున్నారు అదే లాస్ట్ వీక్ అది సెలెక్ట్ చేసుకొని ఈ ఇమేజెస్ ఇట్లా సెలెక్ట్ చేసుకొని 28 ఇమేజెస్ సెలెక్ట్ చేస్తారు ఇది లేబుల్స్ యాడ్ చేసి ఎట్లా చెప్పాను కదా అంతే వాట్ హ్యాపెన్ సార్ ప్రాబ్లమ్ మేక్ సెన్స్ వెళ్ళండి సార్ ఇక్కడికి వెళ్ళండి ఇది సెలెక్ట్ చేయండి క్లిక్ చేయండి సార్ ఇది ఫ్రూట్స్ మీకు డౌన్లోడ్ చేయలేదా సార్ ఇందాక వన్ డ్రైవ్లో పెట్టుకున్నారా వన్ డ్రైవ్ అసలు ఇంటర్నెట్ స్లో ఉంటుంది నెట్లో లేరు ఇప్పుడు అక్కడ ఇక్కడ ఎల్లో కలర్ మాకు కొంచెం నెట్లో లేరు ఇక్కడ కెన్ ఎనీబడి లాగిన్ హియర్ గివ్ ఇంటర్నెట్ కనెక్షన్ ఓకే స్టార్ట్ ప్రాజెక్ట్ మ్యామ్ స్టార్ట్ ప్రాజెక్ట్ అది ఇంటర్నెట్ నెట్లో లేదు ఎస్ మ్యామ్ మీరు లేబుల్ ఇచ్చారా ముందు లేబుల్స్ స్పెసిఫై చేశారు మీరు అట్లా సెలెక్ట్ చేసుకోండి క్లిక్ చేయండి అక్కడ లేబుల్స్ ఇవ్వలేదు మీరు ముందు అందుకే నేను ఏం చెప్పాను ముందు మీరు ఫస్ట్ స్టెప్ చేయాల్సింది అప్లై చేసుకున్నప్పుడు ముందు ఫస్ట్ లేబుల్స్ యాడ్ చేయండి మీ లిస్ట్లో మీరు లేబుల్స్ చేస్తే దాన్ని అసైన్ చేయొచ్చు మనం ఇక్కడ మీరు డౌన్లోడ్ చేస్తున్నారు మేడం you next time when you go home you practice with your own data sets. I'm just showing one example of fruits only. If you have your own data sets, maybe mathematics కానీ physics లో కానీ chemistry లో కానీ సేమ్ ఇదే ప్రాసెస్ ఉంటుంది అక్కడ కూడా ప్రాసెస్ ఇదే అది అవసరం లేదు మేడం దాని అది సపరేట్ యాక్టివిటీ అది మీరేమనుకోవద్దు ఇది సపరేట్ యాక్టివిటీ ఇది ఏంటంటే డేటాని మనం అండర్స్టాండ్ చేసుకోవాలి ఎట్లా అండర్స్టాండ్ చేసుకుంటాం ఒకటేసారి హ్యూజ్ క్వాంటిటీ ఆఫ్ డేటా ఉంది కదా హ్యూజ్ క్వాంటిటీ ఆఫ్ డేటా ఉంటే మనం ప్రతి డేటాని మనం ఓపెన్ చేసి లేదు అది అది ఇది అది ఇండిపెండెంట్ ఇది ఇండిపెండెంట్ మేడం annotation correct annotation చేస్తాను అది అంటే నేను కొద్దిగా లింక్ చేశాను అంతే అక్కడ గబుక్కుంది మీరు రెండు యాక్టివిటీస్ చేద్దాను డేటా సెట్ ఇచ్చాను కదా ఇందాక మీరు మెయిల్లో మీకు ఆ డేటా సెట్స్ ఉన్నాయి ఆల్రెడీ మీకు మెయిల్ అది ఉందండి మేడం డౌన్లోడ్ చేసుకోండి కిందకి సారీ స్క్రోల్ డౌన్ చేయండి మేడం అదేంటి అది ఉంది కదా సర్వే ఓకే అది ఎక్సెల్ షీట్ వచ్చి మీకు డేటా సెట్ ఎక్సెల్ షీట్ ఒకటే వచ్చింది నాకు అదే తొందరగా వెళ్తుంది నేను మళ్ళీ పంపుతాను ఒక నిమిషం సార్ అయితే మీ నలుగురికి రాదు అది మీ నలుగురికి రాలేదు అది నేను సెకండ్ టైం పంపుతున్నాను మీరు చేయండి మేడం మరి చేయండి ఇది ఇంతవరకే ఎక్సర్సైజ్ అయితే ఇంతవరకే ఉంది నేమ్స్ ఎట్లేదు ఓకే ఇప్పుడు మీరు ఏమి లేదు వెళ్ళండి యాక్షన్ స్పాట్కి వెళ్ళండి క్లిక్ చేయండి ఇక్కడ ఎడిట్ లేబుల్స్ ఇప్పుడు అక్కడ ప్లస్ ఉంది చూడండి పైన 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 అది నాకు అది యాడ్ చేయండి అక్కడ Ma'am, I just send them. Please check it. మళ్ళీ మీరు అక్కడికి వెళ్ళి ఎడిట్ లెవెల్స్ నేను అక్కడ ప్లస్ నొక్కండి ప్లస్ నొక్కి మీరు గ్రేప్స్ యాడ్ చేయాలి వన్ సెకండ్ మీరు రిఫ్రెష్ చేయండి మెయిల్ కొంచెం ఇప్పుడు షేర్ చేశాను ఒక్క నిమిషం వస్తుంది మేడం షేర్ చేశాను పెండింగ్ మెయిల్ సార్ yes sir. See, you think that it is done, you go to the next image, sir. You have to do for yeah. Now you see Goa has to be added. Goa means ఇక్కడ peers ఉందనుకోండి కొత్త లేబుల్ యాడ్ చేయాలి ఎట్లా చేయాలి యాడ్ చేయాలి కొత్త లేబుల్ ప్లీజ్ ప్రాక్టీస్ ఇట్ ఫర్ పాలిగాన్ ఆల్సో ప్లీజ్ ప్రాక్టీస్ నాట్ ఓన్లీ రెక్టాంగిల్ పంపించాను మేడం నేను ఆల్రెడీ మేడం యు ఆర్ దేర్ ఆల్రెడీ వస్తుంది మెయిల్ వస్తుంది మెయిల్ వచ్చిందా మేడం మెయిల్ okay please all of you just have a practice on polygon also just look for the polygon so when you click polygon what is that advantage of polygon yes you can give the dots here so what is the advantage of polygon What will be the advantage of polygon over bounding box? Precise, yes, more accurately. For different shapes, more accurately the labeling can be done instead of rectangle. Because in rectangle, some parts of the images will be eliminated. If you are using polygon, you can select each and every point very closely. Bordering will be done properly. Yes, yes, yes. Madam? Polygon, yes, starting point and ending point for a polygon is same. If you don't close it or if you don't prepare a polygon, label will not come. First you have to represent that particular shape into a particular polygon shape. అంటే ఎగ్జాక్ట్ షేప్ సార్ షేప్ రిజల్ట్ అప్పుడు కంప్లీట్ అయినప్పుడు మీకు చూపిస్తుంది సార్ అంటే అప్పుడు ఎలో చేస్తుంది మీరు లేబుల్ ఇవ్వటానికి అది మేడం డిడ్ యూ రిసీవ్ ద డేటా సెట్ మ్యామ్ వచ్చిందా మేడం డేటా సెట్ Okay, so you please try to do it. All of you look onto my screen once please. So morning session, this was for the mathematical sciences group, the content to be delivered, what content I need to discuss with you all. This is your syllabus, the AI data pipeline, stages and components, key stages, data collection, annotations, pre-processing, splitting, feeding into AI models. This is an introductory part. What are called core components, ingestion, storage, processing, validation and all. Collecting the collection methods for AI, manual input, that is through surveys. Anyway, you have done one small activity. Sensors and IoT device also, you can collect the real-time data using system logs, using APIs. Then you have data annotation and labeling. What is the definition, what is the importance, annotation methods, manual annotations, automated annotations, types of annotations, classification, you are seeing the bounding boxes now, segmentations, transcription and name entity recognitions. What are these? Are all the topics that are discussed in the theoretical one. This is all theoretical one. Now coming to the lab one. So please look into the lab part. That is lab, understanding the data set, metadata and formats, take data sets in different formats, view metadata, compare domain specific data sets, medical data and finance. Lab part, data annotation exercise, use makesense.ai or another software called as VGG, but at least you are using makesense.ai. Annotate 10 sample images. Traffic science data set, I have already given the traffic science data set also. Please practice it in the evening to annotate it, fruits or some medical scans. Export annotations in XML or YOLO format. How to export it just now I have shown to you. Discuss annotation errors with and challenges. This is what the lab part. So in this one, the lab part, some little bit of discussion is there about the data set. Those who are doing, continue doing and listen to me about what are the different types of data sets. So go to my notes, open the slides. So what is called metadata? Metadata means not original, no. Meta, labeling, no. Technically speaking or meaningfully, metadata is data about data. So metadata in computer science and IT field is data about data. Means you are describing the data. So you are telling some, you are giving some information about the data itself. How do you give it? Already you know it. Actually, that is what new thing which is coming. What was the metadata in the previous Excel sheet in the CSV format? The metadata is will be expressed in the form of description. The features. What are called features? Your attributes, column names. That column name, the name of that column itself is describing something about what data it contains actually. That is called as metadata. The column names, the attributes, the features, the size, license, and of course, let us see some two different data sets. The two different data sets, I already given a link here. Open the slide which I am just skipping from your annotation. I hope you have done the annotation. Annotation is done or not? Are you able to export it? Okay, that activity is over now. Now please go to the other activity. No, make sense is only for data annotation now. Yes, Teachable or Orange or other softwares where your AI system is going to be prepared. Annotation, and that is only for image. What you have seen just image annotation. I have not shown you for text annotation also. Time permits, I will show you. I will tell you how to do it. Two things you need to understand here carefully. As per the syllabus, that's why it makes sense I have used it. But there are so many other softwares are there. So many tools are available in the market which are open source. Open source means they can be freely. But most of the annotation softwares, they go for price. Means they will ask for subscription. You need to pay because they develop that software. They put a lot of efforts there. But for people to understand what is annotation and all, to understand it, we use this make sense, and usually that's what syllabus was prescribed. But I suggest you, if you want to do a good things, really use RoboFlow. For 3 projects they will give free, but after 3 projects again there is a subscription for that. But at least for 3 projects you prepare a good annotation and prepare a good machine learning there, and automatically that software will allow you to prepare machine learning. You need not write a code also. RoboFlow, ROBO. You can just type it here on the website. I will just show you. Please see here. RoboFlow, computer vision tools for developers and enterprises. First 3 projects, maybe for physics people or chemistry people. If you have some images, if you have some text, if you have some audio files, if you have some video files, here a very easy tool, very easy, but needs internet connection. For 3 projects it is free. With our experience I am just sharing with you. Not only this one, I am not marketing here. There are so many tools like that are there. But what I suggest you is, please remember, if your data is important, don't share your data to any of these software. Data is most valuable. Practice only. dummy, you can call it as dummy, or you can call it as fake, or you can call it as synthetic data. But data is very important. Why? Because all these cloud platforms, what they do is they collect your data. They will do a lot of things in the background. Even Google also is collecting data. Knowingly or unknowingly, a lot of data is being collected from you. What you are doing, where you are there, what emails are coming, everything is monitored. Nothing is secure, please remember it. So, but when you are doing some research data, which is very much valuable, do you think, don't go for cloud-based platforms. You have to buy their software, install the software on your computer and do those things. That is the most preferable one. Just a suggestion I am just sharing with you. That is one thing. Now, the actual thing is, okay, you can go through this website, is actually self-explanatory. If you have some time, you can practice it on your own. Go through those things. Now, the point here is, open your slide and yes, I am talking about this. Okay, now let us see, understand here. Already I have seen, if you want to go to this, just click this link, heart disease data set. You will come up to this particular web page. Now, this is a data set from where? From University of California, Irvine. That is they have a lot of, like you might have practiced Kaggle. Kaggle, did you practice? Kaggle. Same thing like Kaggle. UCI is another repository. Repository means where a lot of collection of data are there. That data is available in different formats. So, one such format you see, that is the basic format. That format is CSV format, comma separated value. Just click here, this link, you will go to that particular page. I already provided the link to you. So, this is what the heart disease data set. Of course, this is very old data set, 1988, very old data set, but people use it for developing different applications. Now, what you have to understand at this point of discussion is basically, so what is this data? Now, when you see this one, this is what the basic information, data set characteristics, multivariate, multiple variables are there, different attributes are there here. What are those different features? Some are categorical, some are integer values, some are real values. Like in your Excel sheet, what type of data was there? The data which I collected from you all. Sorry, text means categorical data. Now, only categorical. What about mobile phone? Numerical also is there. Yes. Similarly, these data sets are also has got different data types. How many instances are there? Instances means how many rows, how many entries are there. How many features are there? What are called features? That's what columns. That is what 13 columns are there. For what purpose this data can be used for? Classification purpose. Now, you are doing image actually. That image data is also meant for your image detections and classification purpose, means categorically distinguishing between them. So, if you scroll down, you have a download option is there here. You can download it. Once you download it, all of you do that one, download it. So, madam, if you put your mouse pointer on this one, hand symbol is coming or not? Yeah, please do that one. So, once you click that one, you will land up to this particular web page. So, click the download, download it and open the data set. Again, if zip file is coming, what to be done? Unzip it. Already I have shown you how to unzip that one. So, once you unzip it, then you click, double click it. If suppose I know that this is basically what type of file, this is basically your CSV file. If the let it be open. First important thing is always remember, once you download it to the local system, upload it onto your drive. The important next step I am telling you, that is a good habit, so that your data will not be lost. Your data will be available in your own drive will be there. So, once you open the data, then you can open it and later you can play with this one. Now, see here at the bottom of the screen, there are different variables, 13 variables are there. whatever the information you are seeing here, this is what basically your data about data, the metadata, which gives you this particular information, and this is what the performance of that models. Similarly, go to the next slide. Next slide. Now this, if you see the next slide, there is another data set called as Alpha Vantage stock market data. Now again you can click this particular link. So once you click that, again you are lining up to this particular web page. Just scroll down. All of you please scroll down. So what you see here is basically, that's what I was able to tell you. What is that API we were discussing in the previous session? What is the full form of API? Application Programming Interface. So here API, you will get an API link actually here. So the API link will be there. Select that API link. Just scroll down. You can see here when you scroll down, you just click this particular link. This is an API link, we call it as. What is this API? What do you mean by API? Okay, I will put the question in another way. Yes, application programming interface, that is a technical name which you are giving to. Suppose you want to search my profile, what will you do it? What will you do it on the browser? Searching by name directly? No. So university website / then departments / then faculty / then the name, means what is that, the name, that / that is nothing but, no, it is a syntax, it is a particular rule is there to access that information. That entire thing is nothing but API only. API only. Basically you are seeing here, please look here carefully, https www.alphavantage.co/query. What is that query you are trying to do? Question mark, but some functionality is there. Of course, when I am searching my name, you are not doing any functionalities there. Of course, there is a rule for that one, how to search the functionalities, like question mark followed by function is time series, intraday, symbol is equal to IBM, interval is equal to 5 minutes interval, then the API key is demo, some access token key will be given here. By default here in this example is demo here. If you click this one, what is that you are going to see? I am just showing you. What is that you are getting? Now you are getting some data actually here, 5 minutes interval data, time series data is coming. Now you see the format of this data. What is the format of the data? That format is different from CSV format. Data is represented in different format here. This format is called as JSON format, JavaScript object notation. That is the name, is a subset name coming from JavaScript, a web technology, web programming language format is this. Why this format was come into picture? This was come just last 5 to 10 years back only. Earlier 30 years back this JSON format was not there. Little bit briefing I have done in the previous class. Can you able to recollect what was that I was trying to tell? JSON format, what is the importance of JSON format? Easily transported, not transform sir. Transform means changing its, transporting the data from one source to another source, from one process to, when I say process means in this computer there will be so many internal processes are running, means so many programs are getting executed. So data has to be coming from one program execution to another program execution, or sometimes I want to bring data from some other computer, or I want to send data from this computer to some other place. So what is the human readable format? Human should also understand, at the same time machine should also understand, and that should be very lightweight. Lightweight means it should not take more time for processing and more time for executions by the machines and all, because on a huge quantity of data has to be transported here and there on the internet and in the between the processes. So JSON format is a very lightweight process as compared to XML. Those people who know HTML and XML, that tags will be there. That was the olden days where data was been used to transport from one process to another process, or from one machine to another machine. But now the latest technology is on the JSON format. Now how the format looks like? The format looks like this. This whatever see, there is a colon, please remember the colon. Colon left hand side, colon right hand side. Whatever that is there left hand side, it is called as attributes, or the other name for attribute is key, K-E-Y, key. This is on the right hand side, it is called as value. So this is called as key value pair, one pair will be there. So what are the different values? So if you see here example, this is yesterday's data, the live data, that is what this stock market data is coming. You are getting the important data actually from the stock market related. This is 9/3/2026, 7:50 hours, that is 1950. You are open, it was, those who know the stock terminology, stock market terminology, you know what is open, what is high, what is low, what is slow, what is volume and all. So here these are the keys and these are corresponding values. This is at 7:55, this is 7:50, every 5-minute interval the data is been shown here. So now you are able to see the data here. So you can copy the data into your local system. So they are giving the data in this particular format in a very easy, within a fraction, less than nanosecond time you are getting the data actually. Of course they are giving data only little bit quantity. If you want 5 years data, 10 years data, you need to pay money for that. Most of the time these are real data are required, then you need payment and all. But for sample purpose, for academic and research purpose, for our practice purpose, they will give limited amount of data for you to practice. But when you see the data, don't get vexed up, don't get confused. The data looks like this. This is what called as key value pairs. So this data format is different from CSV format. So data collection, again, please, your purpose of this session is to understand that data is going to be existing in different formats for different applications. That is the point of discussion here. Just have an idea on that. Now coming to this slide. Yes, so this is what. Now this is what just what are the fields, what is the metadata? Metadata is nothing but the attributes that are talking about this particular data values. So you are seeing that financial data, that is the difference between CSV and JSON format. So what is the basic difference between CSV and JSON format? Please remember here, CSV format is very simple. I already given the notes to you, need not write it, please don't write it. Simple, flat table, easy for spreadsheets and machine learning tools, CSV format. But JSON is very flexible, transporting from one place to another place. This is hierarchical, means definitely hierarchical representation is there. Date wise is there, inside the date, again the product names are coming, inside the product subcategories are there in that particular hierarchical manner. Always data represented in a hierarchical manner has got a meaningful information that can be understood by the human as well as that can be understood by the machine here. That's what better for APIs and web-based data exchanges. So CSV data are common in structured research domains, whereas JSON data dominate in API-driven domains. This is the basic differences between CSV and JSON data formats, which we are using JSON for our various purposes. Now all applications for AI, ML, most of them, around 90%, more than 90% of the applications uses JSON format. Just to have an idea on that one. Yes, please. Yeah. So thank you. Any questions are there? Yeah. Don't know. Time is over now. So much of thing can be delivered, but I tried my best to maximum extent. The requirement is very high. Reception is little bit slow, but anyway, please continue practicing. Don't leave this session like this. After going home, please practice it so that it can be lasted for a more duration and it can be useful for your own students to do your own projects. So please don't stop here only and don't forget it. Please continue that one. Continuation is the most crux here, not the session attending and all. After the session is there, the actual work starts. Please do that one. All the best for your career and for other things. Any query is there, you already have my email ID. So please I'll try to respond, and whatever, just give me 1 or 2 days time. Sometimes I may not respond immediately. Definitely I'll respond it as early as possible. Thank you. All the best.
mention orange. Wait a minute. Infrastructure, foundation. Now A pipeline. Completed. Okay. Okay. Before that, what is the data planification, sir? Data annotation next extra. Which software? Lab, which software you use? Okay. Separate software, huh? Not orange software. Oh, okay. Okay. Orange data net. Yes, sir. We wait for some time, 5 minutes. Back question also. Desktop don't need, already installed. Within the desktop you can see the orange software in the please put your message in the group so that other people know. So WhatsApp group anything is it? Please type it. I think going to start this one. All mathematics practice, sir. Thanks, sir. Yes, sir. Yes, sir. start? Brief work.
Good afternoon, everyone. Welcome you back. So this session will taken by the Dr. C. Ganesh Kumar sir. Let me give you the brief introduction about sir. He is an associate professor analytics and operations at the School of Management, University of Hyderabad. He holds a PhD in management studies from Pondicherry University and completed a postdoctoral fellowship from IIM Bangalore under the Airbus endowed chair for supply chain management, focusing on agri-food supply chains. His teaching spans operation management, supply chain management, business analytics, research methodology, big data, AI ML, and digital social media analytics. His research interests include agri-food supply chains, sustainable operations, AI and blockchain in agriculture, precision farming, industry 4.0 technologies, and global supply chain resilience. Dr. Ganesh Kumar has published extensively in Scopus, Web of Science, and ABDC Index journals with work on topics such as AI in agriculture, blockchain in food supply chain, gamification in marketing, e-procurement and mobile app adoption in agribusiness. He has also undertaken consultancy projects funded by organizations like IFPRI, ADB, Tea Board of India, ICSSR and UNDP, and coordinated numerous FDPs, MDPs and workshops on analytics, AI and supply chain management. So, over to you, sir.
Yeah, thank you Anmol for kind introduction. Yeah, good afternoon everyone. I think after lunch it will be difficult. Anyway, now laptop is not desktop or laptop is not required. You take your notebook. First we will take some theory, then we will come to lab session. Okay, initially we are not focusing on lab. First we will take some theory of data visualization. Then we will start with which one? Anson, the orange software. All the desktop already installed. If it is laptop, mean you have to install. We will take it later. Okay. This is the content of today's presentation. There will be a 5 content. First content will focus on which one? Why you have to learn this topic. I think most of the faculty is from different background, physics, chemistry, mathematics. Okay. So, but in the part of this FDP program, you are learning this data visualization. Which software? Orange software. First, we will talk about why you have to learn this. Okay, as a faculty member from different discipline, why you have to learn this, how it is useful, we will discuss in the first part. Second part will be some of the basic principles of data visualization, we will discuss. Third will be the hands-on, there we will use the lab, what this software will. So, fourth will be some other AI tools. Even though we are using which software? Orange, there are other AI tools are available, we will discuss in the fourth part. Last part will be the summary and discussion. I will give some sample courses. There are other courses are available in MOOC, massive, here you have to laptop, laptop, that's it. If you look at this, there are a lot of courses are available in open, massive online open courses platform, we will see all these things. So, this is the plan. We start with the first part. What is the first part? Importance of data visualization. Any idea as a faculty member, we have to do 3 things. Depends on the institute, it will vary, but normally 3 activities. What are 3 activities? Teaching. Second will be research. Third will be some administrative activity, some dean, some outside activity. Normally we will do 3 activities. Teaching, it's vary to the institute to institute in terms of weightage. Some institute will focus on too much teaching, some institute focus on too much research. It vary to the institute to institute. Any idea how this data visualization is useful for teaching? Any thought? Teaching, how it is useful? Any thought? Very good. If you look at the pictures, normally if you look at our audience, normally there are different generations are there. So if you look at this, if you want to show anything, okay, nowadays even ourselves also we are very comfortable with the reels, what is Facebook, Instagram reels. So if you look at this teaching, whatever if you show some numbers, compared if you show some form of visual form, okay, physics, anything, if you any concept, we can convert into visual form. So if you, I'll show you some of the tools how to convert any one page of content, how to make it as a visual using some tools. So one, as sir mentioned, students are very comfortable with which one, which even we also comfortable with which one, visuals. At the same time, for next 1.5 hours, if you watch one movie on my session or some kind of a 1, 2 page, 3 page reading, which will remember better? Movies, because it's a visual form, So if you want to teach better to attract the students, okay, which one? Visual form will better. Whatever if you're putting one page of text or one slide of text, same thing if you put in form of visual, they will understand better. Any other angle? Teaching purpose? Any other angle? Any other angle? Teaching will be good. Any other angle? Very good. For example, if you want to, which students are performing better, seeing the data, it will be very difficult to understand. If you want to present to any this also, visualization will be better. Very good. Any other angle? Assessment, which that is also visual. Then any other angle? If you go to NAC accreditation and all, NAC, they have to make it a visual form in diagram. So that also we in teaching we can. Anything related to research? Models. Any paper if you see, there are some form of visuals we have to give. Even physics or anything, chemistry, some form of visuals you have to give. If you give visuals, it will some kind of readers or the reviewers also will not be 100% accepted, but some kind of push will be there in the research. And the research also, learning also will be easy. Okay. Any other related to administration? Administration, research. Even if you go for a research conference also, if you go, you present, audience will attract. And if you go for funding agency, so funding agency, DST or anything, if you present your proposal, some more visuals are there, the reviewers will have better idea. Okay, all these things are visual. Admin, anything, sir? You were telling something? Admin related. Advertising our program, that is okay. And if you are in HOD or if you want to, for the student welfare or a dean for hostel or anything, if you want to present some of the issues to the vice chancellor or dean, you collect the data. If you present in visual, they will understand very fast compared to talking in this one. If you're putting some good visual, so these are the issues, we have collect some data, some questionnaire, Google form, then you put in form of visual in the presentation, it will have better attraction. So always visual is better in form of teaching, research and admin. Okay, so we'll discuss some of the points I have, I'll discuss. Okay, any idea we are into which industrial revolution? We have industrial revolution, right? There are different industrial revolution. We are into which one? Any idea? 4. What is the 4? A, very good. A are but they are normally called cyber physical. What is the first one? Any idea? There are, as madam mentioned, we are in industry 4. We are going to 5. First one? Yeah. First one was stream engineering, mechanization. We call it correct only, madam. Somewhat stream engineering, mechanization. So initially, olden days, we used to manufacture product through hand-based product. First revolution started with which one? Mechanization. It started using machine. Particularly, they used which one? Steam, train, all these things. That was the first one. It was started in 17th century. Second one was which one? Electricity. So we can't imagine this world without electricity. Third one was computers and internet. Okay. So now we are into which one? Industry 4.0. Nothing but, as madam mentioned, what is that industry 4.0? A, cyber physical. So we are moving toward industry 5.0. What is industry 5.0? Generally, that is okay. That is already intelligence. Next, what is the industry 5.0? Any idea? This is the industry 4.0. Similarly, electricity, without electricity we can't imagine. Future we can't imagine without A also. So if you look at this, we are moving to industry 5.0. What is the industry 5.0? How to work both A and human. Now currently lot of AIs are coming. Feature will be, what is the feature? How to collaboratively work with not only human being, how to work with not only robots, co-pilot, chat GPT, who knows, your attendance system feature will be some AI cameras will be there. We don't know, after some time, your examination, nowadays some Bangalore University, they are using paper correction, which one, some kind of AI system. Even yesterday I was checking this one, what is this, SRM University, faculty recruitment, screening of application, they are using some platform. Okay, so lot of new technologies are there. Your coordinator or what is subordinates or your co-colleague will not be only which one, human being. You have to use some kind of AI tools. Future, lot of companies, lot of institutes. Already, if you look at the companies and all, co-pilot become the common. Co-pilot, chat GPT and all, they have to use. What is the future? Next revolution will start. How to accommodate, how to work with A, that is the next. Currently lot of A's are coming, how to work, how you are understanding your friends know, similarly how to understand how A works. So that is the future. So if you see this company Amazon, this is called A product. What is A product? This is a kind of robot. It will go and pick the product from the warehouse. If you look at this person is the warehouse employee. So if you look at this, is collaborating with the robots. Robots will pick the product. If you take the product and based on the order it will give. Only human has to which one? Verification. So this is called which one? Industry 5.0. It's not collaborating with human. It is which one? Robots. Okay. So that kind of things are changing. So if you look at this example, I have taken from some online LinkedIn page. So if you look at this, if you order any product in the this quick commerce, but quick commerce, Swiggy, there are no dark stores will be. If you go to Swiggy, there is a 10 minutes deliveries will be there. So that is called quick commerce. If you order within 10 minutes something they deliver. Okay, so if you order the product in quick commerce, Swiggy or Zomato, it will use some kind of analytics A, which is the nearest store, which is the nearest delivery person. It will do some algorithm, it will allocate. It will not check whether the order is right or wrong, whether it create any problem, that it will not check it. But if you see after somebody's order midnight, lot of rat poison, this person has not delivered the product. As per order, he got the order because he may be near to the place, but he didn't deliver the product. This is called which one? Collaboration. Okay, he escalated to manager and they have stopped the suicide. Okay, so that is called which one? Feature. So now we are going to use one of the AI tool or the tool called Orange to understand the data visualization. The feature will be like this, lot of tools will come. Okay, so if you look at this same thing, I want to take it for my student. So I have taken this from which one? LinkedIn page. So this is the text I got it. If you present this text to some student, ask them to read, it will take some time to which one? Read, and their concentration will not be there, lot of issue. Same thing what I have done, I converted into data visualization. Can you see this? Same paragraph, I converted in which one? Data visualization. See this? It is looking better, no? Still some issues, it is better than which one? Previous one. So what I use, please write down, notebook LM, please write down, notebook LM. I will just show you, don't do it, just don't do it. After that you can, but write down the name of the software. What is the name of the software? Notebook LM. Don't open your laptop or anything, just I will show you because time limitation. What is the point here is, what is the software? Notebook LM. It's a free. If you are using Gemini based, notebook LM, try. Here, what is the point here is how to convert some form of text. For example, if you have 2 pages of basics of our organic chemistry, same thing you want to convert into visual. Currently, you have only the 10 pages of this one are basic about physics. Something is there. If you want to make it as a slide, okay. So what we can do is create this one. This is a text. You can upload as a file, PDF file. You can upload a YouTube. You can upload as a drive. This is the text. I just select the text. Just say Control V, insert. So can you see the left side? This side, we can convert into audio. If you want to show us audio, video, mind map. So I'll go with the infograph. Simple this one, but you can convert. You can language also. You can change it. Even though text was some other thing, you can create a small video. What is the concept? Students very happy to listen, happy to this one. Only classroom you can take it for discussion, question answer. This is called flipped classroom. Learning will happen outside the classroom. Only inside you can do exam, so that whether reading correct or not. Okay, so like this we can change it. So what I am going to change this text into which one? Infograph. You can change anything also. So it will take some time. The point here is the data visualization. So how we are converting a text into visual. Not only text, we can convert into other forms also from this one. So same process you can adapt. You can after the class, whatever the next, please try. Okay, next when you go to college, how to convert whatever you were lot of PPT. Try to convert in visual. If you present this one, so the young generation, future also it will decrease concentration power, all these things. So they are able to understand. So what is the software? Notebook LM. Okay, please after that if you go to YouTube, a lot of videos are available. You can check the tutorial for Notebook LM and try to use it for your course teaching purpose. Okay, so this is the one tool we can use it for which one? Data visualization. So it takes some time. Now I come to the presentation, then I'll show the output here. Okay, but problem is it will not give same output. Same text, same paragraph you upload today and tomorrow you will get different format. The The concept will be same, but the layout will be different. That is the advantage of which one? Artificial intelligence. Nothing, madam. Just if you don't do it now, see later you can check it. If you type notebook LM, the online, you can. No. So I'm not. That is not our focus. Orange software is focus. Just I want to show you for this one. I'll share some video, madam. There you can enter step by step process will be there. If you go this one too much, no, where time is limited. Only 90 minutes is there. I have to teach other thing. Don't worry. There are a lot of YouTube videos are available. You can check it. Okay. So if you just if you go to notebook, you have to sign in with Gmail. There is an option to upload. If you see the main page, there is an option called which one? Copy text. If you go to the main page, there is one thing option called copy. Don't try, madam, because this now it will take a lot of time. If you teach, this is a separate topic. So we don't want our focus on which one? The orange software that will complete. Don't worry, I'll share some resources. You can check it later. Okay. The point here is, what is the point? There are some tools. There are other tools I'll discuss. One of the tools is which one? Notebook LM to convert any format. What is any format? Text to visualization, audio, video, anything you can do it. Okay. You can upload your entire book also, PDF book, and convert into, there is an option called slide also. That all these things are possible. You can explore later. It is a free one, but there are option Gemini. They are giving free. If I am using university ID, they are giving for 1 year, and daily if you use, they can use it for 3-4 times. Next day they will give, okay, not too much time, but if you are giving for 1 year subscription free, they can use it for any time. Okay. So it's almost free, but too much data they will ask for this, almost free only. Okay, fine. So what is the first point? We are in industry 4, we are moving towards which one? Industry 5. What is the 5? How to collaborate. Now I collaborated with a notebook LM, how to teach. Similarly, exam paper correction, attendance, lot of things, even I don't know what will happen to future, lot of things will come. So already it's coming in the healthcare sector, automobile, all these things. Similarly, it's already it's coming from the education. Private colleges already is there. The too much pressure in private ultimately will come to the government also. Okay, everything is competition only. Okay, fine. So in this industry 4.0, one of the skill is which one? One of the skill is which one? Analytical thinking. Where is the cursor? Slide changer it will be. Yeah. If you look at this, what is the analytical thinking? So if you look at the data visualization is part of which one? Analytical thinking. How to analyze the data. So one of the skill we have to teach our student is analytical thinking. Okay. So if you see this job, what is this job? 2009. What is this job? Aerial photographer. It is now it is the drones. Even agriculture also, farmers. Some of the agriculture they are using which one? Drones. So if you look at this similarly, some of the skill we are learning now may not be useful in the future. Even lot of researchers now, chemistry faculty, they have started using a platform to design the new, all these things. So new things are coming. Similarly, any of these people are using this product? No. If you are developing skill on this area, or how to market, how to manufacture this, how to design, whether will our students will get a job? No. Similarly, these are the some of the issues. Okay. So even for currently the war also, which one they are using? It's not fighting between human to human. It is which one? Drones are fighting. Even for US also, they used Anthropic for this war, Iran war. They are using AA. Future will be which one? Mission to mission war is there. Okay. So if you look at this, everywhere what is there? A is there. In faculty job also, lot of things will come. In future, we don't know, after 5 years, 10 years, we don't know what will happen. Okay, new things will come, which we have to be only one department, 2 faculties will be the remaining, how to manage with the other things. Okay, we don't know. The point here is, the data visualization is one of the new age skill, which you have to develop in terms of research purpose, teaching purpose, and administrative purpose. Okay, so if you look at this, if you want, you can type this, note down this name, National Strategy for Artificial Intelligence. It's a Niti Aayog report. They have come up with some kind of strategy for, there are 3-4 sectors they have taken. One of the sectors they have taken is agriculture, healthcare, another one is which one? Education. How to use AI in education, they have some strategic plan. Okay, you can take this and propose some project or anything. Okay, you can check this freely available report in the online. Niti Aayog, what is the national strategy for AI? One of the sectors they are focusing on which one? Education. Apart from, they are focusing on which one? Healthcare, another one is agriculture, and language translation and other things. Okay, fine. So if you look at this, AI started 1950 itself. People nowadays, people are talking about lot of AI and other thing. Any other? What is the reason? Any idea what is the reason? Huh? Anybody hear about this core analytics, all these things? No? No, right? Previously, now everybody talking about analytics, AA. Even AA summits are happen. Somebody was thinking, what's that? Data, very good. So main thing is, as sir mentioned, the main reason is which one? Data. Even though 1950 itself they know what is AA and other things, people are talking about artificial intelligence now because of main reason is which one? Availability of data. There was a say that even 1 day data we are generating is equivalent to 1950 1 year data. 1 year how much data will generate? We are generating in 1 day. Okay, that much data is coming. So any idea how many? What are the types of data? Structured and unstructured data. If you see 2005, how much data was there? 130. 2010, how much data is there? 120 exabytes. 2015, 790. 2020, it's going in a exponential growth. Can you see? We are getting more and more data. So in order to develop a artificial intelligence, what is required? Data. Ours, we have which intelligence? Natural intelligence. For natural intelligence, we create from the experience. Okay. For artificial intelligence, what is required? Data. Nowadays, everybody fighting for which one? Data. What is the new gold? Data. Okay. Old gold was oil. Nowadays, people are fighting for data. So more data is there, more artificial intelligence. Okay. So if you look at the data, there are two types. What are the two types? Please write down. Structured data. Another one is unstructured. What is structured data? Numbers. Numbers. For example, if you type 7, I type 7, you will get same structure or different structure? Same structure. My voice, your voice. My image, your image. Same structure or different structure? Different. That is called which one? Unstructured. Numbers are structured data. This one unstructured data. Any idea which is more in the world? We saw a lot of data, right? Any idea which is more in the world? Structure or unstructured? Unstructured. Any idea how much percentage? 50, 50, 60, 50, 40, 78, 30? 70. There was almost 80 to 90% of world data is which one? Unstructured data. So as a faculty member, lot of scope for doing research in this area. Lot of people will work on which one? Only structured data. Lot of scope for unstructured data. Okay. Even recently, some of the government they collaborated with some satellite company, farmers loan prediction and all. They are using satellite data. So they are predicting the land structure, what is the expected yield. They are using satellite data to give the loan for the farmers. So as a faculty member, lot of scope for which one? Research on which one? Unstructured data. Any idea this data is coming from 3 sources? Please write down. We are getting a lot of data, right? Structured data, unstructured data, it's coming from 3 sources. What are 3 sources? Organization. What is the organization? Any idea? Organization, particularly there is something called ERP, otherwise called which one? Server. You know AWS, what is AWS? Amazon Web Service. Even though your Gmail is there, data will be in the cloud. Okay. So the first source of data in the world is which one? Organization. Organization in which place? ERP. What is ERP? Enterprise Resource Planning. Sometimes they call server, otherwise called cloud. Okay. That is the first source of data. Whatever the data, even if you Facebook and all your account, right? Your data will be stored in some server, Gmail. Whatever the data, it will be in some kind of servers. Okay. That is called which one? Organization. Second one is machine. What is the machine? Please write down. Machine is IoT. Other IoT is called sensors. IoT otherwise called sensors. Second source of data in the world is coming from which one? Sensor. Can you see this mobile? Very old mobile. Okay. How much sensor can you see? IoT are there. Can you see? Almost 14. If you look at your mobile phone, who knows? Lot of, if you are sitting here, you are sending data to Google, Facebook, all these things. If you see the Facebook, 99% of money they are getting from advertisement. They are giving free to you, but they are taking your data. If you search something in Google, in Facebook or something you see in the Google, they are selling to your product. Even Google is initially advertisement company. Now they are starting with what is this? Mobile phone, glasses and other things. All these companies are which one? Data is the main source. Okay, through this they will get lot of money. Are you paying any money for Facebook? Nothing. How they are making money? Through advertisement. You are taking the data and selling to different company. Okay, based on this, you will get different ad. If you search something, if you open in YouTube, you can see that. I have searched something, why you are getting this ad? All because of they are sending data to different companies, they will make money. Okay, the second source of data is from which one? Machine. Even if you switch off your mobile phone, Google can track which place you went, what are the things you have searched. They know better than your family members. They can able to track. Okay. So if you look at that is called which one? Even that lot of wars and all, they are tracking. Even Israel and all, they are using this. What is this? That's why a lot of big people and all, they will not use Facebook, Instagram, all highly sensitive data. They will take it. Second one is which one? Mission. First one is organization, ERP, whatever server. Second one, mission. Mission is which one? IoT, otherwise called sensor. Mobile itself, you see lot of sensor. What is third one? People. What is people? People mean from social media. People mean social media. See here, what is 1 minute? How many seconds are there? 60 seconds. If you see the 60 second 2020, how many people are logging? 1.3 million. If you see after 1 year, how many people? 1.4 million. If you see the Instagram, all the places, if you see, it is increasing. It is increasing. It is little bit old data. I have little bit latest data also 2013, 2015 also it is there. Okay. So if you see this, the time they are spending on social media year by year, it is increasing. Okay. So third data we are getting in the world is from which one? People, where they are generating social media. Even my parents and all now started using reels. They are checking reels. They are very comfortable, and like this they are coming with spending more time. If you go one reel, we see one reel, similar kind of pattern will come, immediately will come. You see how they are changing using algorithm, analytics, all these things. Okay. Now the question is, among the three sources, which is more? Any idea? In the world, we have got lot of data, right? I connect data visualization later. Which is more? People. Second, mission. Third, organization. Okay. Actually, first one is mission. Second one is people. Third one is this one. The most data we are getting from which one? Mission. Even though people will sleep, but who will not sleep? Machine will not sleep. It will continuously, even if you keep your mobile somewhere, it give data to different. If you accept, right? That is nothing but they will understand which reels you are checking. Next time you open the similar reels, they will show. So which will not sleep? The machine will not. Among the data, which data is more in the world? Machine data. So we have lot of data. Now how to convert into beautiful form to understand? That's why the data visualization comes. Okay, we have lot of data. The main problem is how to get this data. Nowadays people are talking about big data. What is big data? Big data, if you want to write down, there are 4 V's are there. What are the 4 V's? Volume, variety, velocity, veracity. Volume means book volume. We are talking about TBs of data. Okay. Variety means text, image, all these things. Velocity means the data will come real time. Okay, real time it will come. Veracity means sometime it will come more data, sometime it will come less data. For example, morning and all will get more data. Okay, evening time, midnight will get less data. But it come regularly, but you will get a different. This, if you have this property, this data is called which one? Big data. Volume, veracity, all these things. Okay, so we have lot of data in the world. The question is how to use the data. One way to use the data is which one? Data visualization. How to make it very beautiful, so that we will understand, we will take a decision. That's what the data visualization is very, very important. We have lot of data, but how to use data into visual form, that is very, very important. Apart from data, computation power. Even I have one desktop during my PhD time. The RAM was somewhere 1 GB RAM. Same time I am using my mobile now, 8 GB RAM. So the processing computation speed are very fast. People are talking about quantum computing. Lot of it is new things are coming. Apart from data, computation, algorithm, neural network, new algorithms are coming. So because of this reason, we are into artificial intelligence. One of the problem here is we are getting lot of data. We have to convert the data into visual form to understand form. Further, the data visualization very, very important. Okay, we'll see. Any idea what is this company? Anyway, this is the any idea what is the GPU? Any idea? This is the number 1 company in the world. It's beating our GDP also. It's almost 3 to 4 trillion. Okay. Previously Apple, Microsoft was there. Now this company, this is not a software company. This which one? We in computer we love CPU. There is something called which one? GPU. What is GPU? Graphical processing unit. If you want to process the high volume of data, they are creating AI chips. Okay. So this company is coming now. Okay, so world is changing. Okay, new things are coming. This it is more than how many trillion? 3-4 trillion, not billion, trillion. This is they are supplying lot of semi chips to different companies. Okay, fine. So today we are going to discuss which one? Data visualization. So how a data visualization and AI are different, we will discuss now. So if you look at the AI is the product. AI is which one? ChatGPT, Copilot is which one? AI product. Inside the, to develop the AI product, what is required? Data analytics. What is required? Data analytics. If you put some words, it will go to the server, it will do some algorithm, there will be LLM algorithm, it will get the output. But we are getting in fraction of second, but actually backside what is working? Some kind of analytics. What is the analytics? Data analytics. Are you able to understand how the AI is the product? Inside the AI, what is there? What is there inside AI? Data analysis. Whatever you use Copilot, ChatGPT, anything, if you type something, what is the best food in Hyderabad, it will immediately go to the algorithm. Some backside algorithm will process and will give the output. But we will get it immediately, but backside they will do some kind of which one? Data analysis or analytics. Okay. So if you look at the data analytics, there are three types. What are the three types of analytics? Descriptive, predictive and prescriptive. Okay. Descriptive means what is happened, which students are coming late, which students are failed in my exam. If you want to answer this kind of question, which analytics you have to use? Descriptive. What will happen? Which students will fail in the future? Which student will leave my course? Okay. If you want to understand the future, we have to go for which one? Predictive. Prescriptive, what best can happen? Which combination I can teach so that all students will get the best marks? Okay. All about which one? Prescriptive analytics. Okay. AI is the product. Inside the AI, what is the data analytics? Data analytics, how many types are there? Three types. Okay. Any idea? Data visualization come under which one? Descriptive, predictive or prescriptive? Descriptive. It is come under which one? Descriptive. We are not analyzing future and all. Only pie chart, bar chart, dashboard. Only we are focusing on which one? What has happened. We are not able to understand the feature or best. Mostly this is come under which one? Descriptive analytics. Are you able to understand? AI is the product. Inside the AI product, what is there? Analytics there. Analytics, how many types are there? Three types. Data visualization come under which one? Descriptive analytics. Descriptive analytics focus on what has happened. Okay. So are you able to understand? Okay. So we are focusing data visualization on descriptive analytics. Can you see this? This is the data visualization of Facebook. Facebook has come up with some data visualization. X-axis which one? Month. What is the month? January to December, 12 month. Every month, how many people are announcing breakups? If you see this, I don't know how many people are using Facebook. There is one option called in relationship breakup is there. If you see this, they got this visualization, data visualization using descriptive analytics. They got it. Okay. If you see this visualization, lot of breakup happening on which month? December. If you see this other February also December. So they got this data, and the business people want to understand why this happening, how business can use this data. Okay, that is the question. Can anyone tell me why December lot of breakup? Which are the business will affect? Which are the business will get a positive, negative impact? Any idea? Can you see this? Lot of breakup. What is the breakup? They are in the married people. They are breakup, like I'm a divorce, something like that. In Facebook, they are announcing breakup or something like that. So based on this collected data. Now question is how to use this visualization for our business purpose. What is this public purpose? Any idea? First you tell me why there is lot of breakup in December. Any idea? Yes sir. That is okay sir. Start a new life. Why lot of December? Why not in November? New life also we can start November, no? Immediate depression, huh? Any idea? Which one sir? January. Okay, very good. Yeah, new resolution. Huh? Yeah, very good. See, if you look at the maybe sir also right. If you look at the December in US and all, we'll get Christmas vacation and January vacation will be there. Maybe who knows that during the remaining month they'll be busy with the work. December we get lot of vacation. They'll talk each other. They'll found he's talking too much. Some kind of issue will some kind of misunderstanding. So that's why lot of breakups are happening in the December. That is not our issue. Let them do whatever they want. But our role is as an analytic, how to use it for business, how to use it for decision making. So now second question is, what is the second question is which are the business will affect, which are the business not affect. Any idea which are the business will have positive impact? Vacation, very good. So I don't know, vacation will go, very good. Any other industry? Law, very good. Law firm, a lot of people go for counselors, law firm, They will ask for some kind of counseling. Very good. Tourism counselors, law firms. Any other? Any other? Gift shop, I don't know. New mean okay. This is a separation, no? Separation. Maybe they'll enjoy. We don't know. But the point here is how their companies are using data from this one to other. For example, as I mentioned, there are more traffic will come for which one? Dating. So that the servers should be ready, and the counselors, lawyers, as I mentioned, there are demand for housing price. They want separate new house. After buying the house, household item will be. So the December, all the companies should be very active because they love lot of demand. So see here how the companies are using visualization for different decisions. Similarly, as a faculty member also, we have to use the visualization for taking a decision about our student, our project, all these things. That is the purpose of which one? Data vision. Even though we are taken for this breakup, but you have to connect with our purpose also. Okay, so how this company, Facebook, they are just simply they are giving one option. Anybody, I don't know how many people. If you see one option is there in relationship, something is there, one option. Using that option data, they are trying to create a business model. See this Facebook. Okay. So same thing I've done it in this one. I'll show you the previous one. What is the previous one? That rat poison. I think it has come. See here this visual has created. Same thing you can convert. I convert into visual. See this visual. It's created a visual. I've just copied which one? One paragraph. See this visual. Same thing on upload PDF or anything. Okay. Similarly, this also I have done as a visual. What is that visual I have done? Breakups. Fine. So write down. There are different types of visualization. Which visualization we are learning now? Data visualization. What are other types of visualization? Concept visualization, information visualization, text visualization. There is very broad visualization, very broad subject. We are focusing only on which visualization? Data visualization. Okay. See this, lot of charts are there. Like in chemistry, we have that table. Similarly, this is a table for which one? Visualization. Similarly, there is a information strategy visualization. It's a very big subject. We are focusing on which visualization? Data visualization. It's come under which type of analytics? Descriptive analytics. See here, which one is better? This is the boarding pass, and this also boarding pass. Which looks better, clear? Why down? More visuals are there. Here more, which one is there? Text is there. So this will understand very fast. Okay. So that is some of the companies they are using more visual compared to text. So normally there is somebody told right initially. What is the main purpose of data visualization? A picture is worth 1,000 words. If you read this 1,000 words and same time one picture, which one able to relate, connect better? Picture. That is the basic purpose of data visualization. Here our brain also, if you see our brain, I told you right, if you watch 3 hours movie, 3 hours study, we will remember which one is better movie. Why? Because our brain also focusing on which one? Data visualization also. Okay. See this average span of human 2000 how much? 12 seconds. Now how many seconds? 8 only. We will distract here and there. Okay. Even it will be less for which one? Students. Okay. Goldfish concentration power is which one? 9 seconds. Ours is lesser than the goldfish. So that means the important subject nowadays is one? Visualization to attract the students. There also problem will be there. They will not, if you show visual, they will not learn everything, but it is better than which one? Showing the lot of text, okay, numbers and others. Fine. This I will leave it. Can you see this? This is the cholera outbreak in 1854. London, there was a cholera, okay. So there was a big outbreak of cholera. Lot of people are getting cholera, okay. So the London government not able to understand where they are getting issue. Okay, there was they were doing lot of survey. This nothing able to understand. So there is a person called which one? John Snow. So what he has done is he had drawn the data visualization. Can you see this visualization? He draw the map of the cholera outbreak. If you see the dot denotes which one? The cholera people, affected people. Okay, based on this diagram, he found that lot of people are getting cholera from the one surrounded place called one common public pipe, the water pipe. Okay, so from the data visualization, you understand that because of the people taking the water from this pipe, they are getting more cholera. They are going with a different direction. So using simple visualization, he is able to solve the biggest problem of which one? Government. Okay, similarly life also, and this also always try to visualize any problems or why it is happening. Try to mind visualization and do some visual. Always are able to solve the simple problem. Not only general problem in life also. Okay, that is the power of which one? Data visualization. Are you able to understand? So if you book a Ola, Uber and all, nowadays which one they are using? Data visualization. If you book a Ola, you can see the driver photo, auto car, what is this? Some picture about that car and what is this numbers. So they are also using which one? Visualization. If you take any car and all, data visualizations are there. So everywhere they are trying to use which one? Data visualization, because the concentrations are going down. They want to attract. Okay. Similarly, as a faculty member also, we have to use more and more data visualization, not only student. If you are going for presentation for dean, vice chancellor, anything, try to use more and more visual, so that the people will attract more, and funding agency. So I am not saying 100% visual, try to use as much as possible. Okay. Fine. So if you see the accounting data, these are some of the accounting visualization: finance, human resource, marketing, operation, engineering, science. So everywhere lot of visualizations are there. Okay. So the main important point, what is the important point is the data visualization better than the text or other form. Okay. So in faculty, for understanding the student, visual is better. For teaching the big concept with a simple visual, we can go for data visualization. Even for student performance, attendance in the NAC documentation and all, we can use which one? Data visualization. These are some of the things we can use it for which one? Teaching purpose. Similarly, research purpose, if you want to communicate the good idea in conference or some poster presentation, visual is better. And understanding purpose also, in grand research proposal also, if you are making some research proposal, try to use which one? Visual form. Okay. The third one is administration. What is administration? If you want to communicate in monitoring some committee member, okay, all these things we can use visual. Okay. So please understand what is the important point. We are in industry 5.0, previously 4, we are going to industry 5.0. A lot of issues are there, lot of data is there. Problem is how to make it visual to understand the audience. For that, this topic is very, very important. Are you able to understand? The first topic is, what is the first topic? Importance of data visualization. Everybody understand, no? Why we have to learn data visualization. Now we are going for the second. What is second? Data visualization principles. Please write down. First one, data visualization principles. Then with the third step will come to the hands-on part. Okay. What is this one? First one is clarity is important than beauty. Don't think data visualization is beautiful chart. Nothing, that is okay, but main thing is which one? Clarity. Compared to beauty, which is important? Clarity. You have to communicate effectively. That is the important first principles of data. What is the first principle? Don't think data visualization is very good eye color, nothing like that. You should communicate properly. Okay. That is called 10-minute rule. Please write down 10-second rules. If your audience not able to understand within 10 seconds, you can improve the clarity. Okay, the clarity, which is important, beauty or clarity? Clarity. So the 10 rule, if your audience not able to understand within 10 seconds, there is a scope for, it's not a bad chart, there is a scope for which one? Improvement. Okay, that is a, so it is not like that, no, data visualization is not for, it is for the audience, they should understand. Okay, the first rule is which one? Clarity is important, there is beauty. What is the rule? 10-second rule. They are not able to understand 10 seconds, there is always scope for improvement. If you look at the data, this temperature, same data I converted into heat map. Can you see this? This is better, no? This is better than the this one. This also okay, not very bad, but takes some time to understand. Okay, if you see this, higher the color, higher the temperature. They are able to connect faster than the previous one. So that is all about which one? Clarity is better than the beauty. What is the rule? 10-second rule. Please write down second one. Second is purpose driven chart selection. Purpose, what is the second point? Purpose driven chart selection. See here, first point is clarity is important than the beauty. Second point is which one? Purpose driven chart. So any idea how many charts are there? We know what are the different charts? Pie chart, bar chart. Okay, if you see lot of more than I don't know, n number of charts are there. Okay, look at my screen. Please look at my screen. Trend. If you want to analyze the trend, what are the charts are there? Cycle, timeline. See this. If you want to show the density, some charts are there. If you want to show the relationship, some charts are there. If you want to show the composition, some charts are there. If you want to show the geospatial data, some charts are there. If you want to show the ranking, some charts are there. If you want to show the flow, some charts are there. If you want to show the part to whole, some charts are there. If you want to show time series, some charts are there. If you want to show the correlation, some charts are there. Similarly, see network. I'll share the PPT, don't worry. Okay, network, some charts are there, multivariate, some charts are there, structural, qualitative, gauge, anatomy, behavioral, text based, deviation. See this? Based on the purpose, there are different. If you want to show the relationship, which chart you have to show? Can you see the scatter plot, bubble chart? If you want to show the composition, ranking, there are some charts are there. The second one is, similarly, if you look at the distribution, concept, proportion, hierarchical distribution, comparison, almost I mentioned how many charts? 100 charts. What is the second point? Purpose driven chart. Each chart has some purpose. Assume that I want to show the relationship between the student performance and student attendance and performance. Show the relationship. We have to go for relationship chart. Okay. If you want to show how many males or females are there in my classroom, I have to go for distribution. For some, what is this? Pie chart. So like that, you have to select the chart based on the purpose. Okay, that is the second. Each chart has some purpose. So if you want to show the distribution male and female, don't use which one? Line chart. Line chart is for some other purpose. Are you able to understand? Based on the purpose, you have to select the chart. Each chart has some purpose. That is the second point. Are you able to understand? Okay. Third point, please write down. On-come quadrant. Write down. Third, what is the first principle? Clarity is important than beauty. What is the rule? 10-second rule. What is the second one? Purpose. Each and every chart there is some purpose there. According to the purpose, you have to select. Okay. Third one is on-come quadrant. If you see the data, there are how many group of data? 4 group of data is there. What are the 4 groups? 1, 2, 3. Each group of 2 data, 2 variable. What are the 2 variable? X and Y. If you see the number are different or same? Different number, right? Different number. I am going to convert into 2 ways. One is visual, another one is descriptive statistic. What is the descriptive statistic? Mean, median, some standard deviation, like that. I am going to convert into 2 ways. What are the 2 ways? Visual way, another one is which one? Descriptive statistic. Same data. Okay. Can you see my screen now? Please see this. What is the difference? Same data. There are 4 groups, each group of X and Y. Can you see the data? What do you understand from this? What is the mean here? 9. What is the mean here? 9. What is the mean here? 9. What is the standard deviation? Same. But data is different. When you do this, mean, standard deviation, correlation all same. But what about visual? Different. That is the concept of which one? On-come quadrant. Visual always will give better representation. Don't believe on numbers. Okay. Compared to average, always try to use which one? Visual. Visual is more powerful than this one. Simple number. That is called which one? On-come quadrant. Are you able to understand? So when anything is there, don't go only with number. Try to do visual form. So that will get better idea. That is all about which one? On-come quadrant. Are you able to understand? Okay. Next one, write down. Data source dozen. Same previous same only. The on-come quadrant and this one is same, but they used to only this one. Same data will get different size. Okay, dinosaur size, different size. That is called which one? Data source. See this same data. Can you see the data? Different size. Okay, same. What is this? Different, but the mean will be same. Everything will be, but the size will be different. Okay, this is also similar to on-come quadrant, but different size. Okay. Next one is, please write down, data ink ratio. Fifth one is first one, clarity is better than beauty. Second one is purpose driven chart. Third one is which one? On-come quadrant. Fourth one is data source. Okay. Fifth one is data ink ratio, Edward Tuffy. Okay. So always you have to give more color to the data compared to the unrelated data. That is called which one? Data ink. You have to give more weightage to which one? Data. If you look at my screen here, see unwanted, can you see? Back side, can you see color? So you have to give more color to which one? The numbers, the tables compared to this background. That is all about which one? Data increase. You have to give more weightage to which one? Data compared to the background, the backside color, all these things. That is all about which one? Data ink ratio. That is the fifth principle. What is the next one? Please write down. Avoid chart junks. Fifth one is avoid chart junks. Avoid chart junks. Previous one which one? Data ink ratio. Now it is which one? Avoid chart junk ratio. Same person. Avoid chart junks. Okay. Shall I show an example? See here, this is too much color, no, backside color, unwanted line. This is called which one? Chart junks, unwanted background design. Okay, same chart we can put it in without background, without anything. This is very simple. This is called which one? Avoiding chart junks. Some people use it, but if you don't like it, very simple chart is better. Okay, that is called which one? Chart junks. Next one, please write down pre-attentive attributes. Next principle of data visualization is which one? Pre-attentive attributes. Pre-attentive attributes. That is the 7th point. These are some of the principles or rules of which one? Data visualization. Look at this. When you present to somebody, if you want to highlight something, use some orientation. All other will put some, if you put this one, you can highlight, color, size. This is called which one? In visualization, if you want to show something, highlight, you can use the color, size, orientation, or some add mark. If you do this one, people will understand. Okay, if you look at this chart, I highlighted which one? Among this, which one I highlighted? Company culture. I want to highlight some important issue. If you are presenting the BC will not look and suddenly if you highlight some red color, something, why it is like that, if then you will ask, can show also, so that you will have better idea. If you want to highlight in presentation, always use this one, pre-attentive attribute. One of the pre-attentive attributes is one, color. What are other things are the size, shape, tone, all these things. So that is the 7th principle. Are you able to understand? 7th principle. Next one is start with the gray. Always back side of the chart should be light color. When you are presenting a chart, back side of chart should be light white, light dark. Don't put the back side is which one? Very dark color. That is all about which one? Start with the gray. What is the start with the gray? Always the back side should be which one? Light color. Normally they put white color. Okay. Next one is minimal eye travel. Always what is the previous one? Back side color should be which one? Light color. Okay. Now this one, please write down 9th one, minimizing the eye travel. Whenever if you see the chart, assume that this is the chart, always eye will go to this corner. Nobody will see in the this side, somewhere in the left side and all. Always you start from this one. Okay. When you logo and all, we have to put it here. Title you have to put. Always eye movement will be start with this side. So you have to group together. Okay. So corner and all, you have to focus. How the eye moves, accordingly you have to visualize. Okay. That is about minimizing the eye travel. 10th one, context is mandatory. If you are presenting a chart, what is the chart? Pie chart. In my class, in my department, 20 students are female, 70 is 90, 80 is male. That is only which one? Just a description. Context, why it is. That is important. When you are presenting somebody data visualization, don't present what is there, why it is. That is very important. People will not interested what is, what they will ask why 20, 80, that's okay. But why male are more, female are less? There is a problem with the geographical region, or some the students are not comfortable. We don't know. So if you explain this, people will, oh, like that they will ask. If you show only visual, they will see, very good, they will go. But if you want to remember, if you want to see this, you have to create a context, why it is. That is very important. Next one is story principles. So create a story. For example, context I told you, right? More female, males are the female. What is the reason? What is the data? It's across all the department. You have to tell. It's not only our department, chemistry department. Even if you take other department also, same. Because this village, they are not encouraging what is this girl for this. If you bring some story, some real story, this is what happened. This is something if you told, no, or people will interested in your data visualization. If you simply say 0, 20% male to 50, 80% like this, if you stop me, nobody will interested. If you say the content, why it is, what is the story, if you tell, the data visualization become very powerful. Okay, that is the 11th principle. 12th is which one? Ethical visualization. What is ethical visualization? There are 3 types of lies in the world. Lies, damn lie, another one is statistical lies. People will mislead with which one? Statistics, wrong statistics, wrong thing. A lot of issues are happening in government also. We don't know the statistic numbers, we can lie. Okay. So if you look at this, normally we are looking for which one? Good chart. What is the good chart? Very no problem, nothing. That is the good chart. Another chart is which one? Bad chart. What is the bad chart? Confusing chart. It is good only, but there are very difficult to understand. That is called which one? Bad chart. Good chart is nice, no ethical violation. Bad chart means not ethical violation. What is the problem? Confusing. It's very difficult to understand. Next chart is which one? Ugly chart. What is the ugly chart? Unethical chart, misleading chart. If you see this, percentage is not 100. If you put like this, no, looks good, but the problem is the data is not matching logically. It's a violation of ethical. So you should not focus on this chart, we have to focus on at least this one, good chart. That is the basic purpose of, you should not mislead the audience with the unwanted or the wrong data. That is all about this one, ethical this one, data visualization. 13, please write down, visualization font size and style. So normally in report and all we'll use which font, anybody? Times New Roman. But if 12, okay, 1.5, okay. For example, if you want to in the report and PPT and all, we can go for this one, okay. There are different font size are there. This is for the dashboard. This we'll use for Word. PPT and all we can go for. These are standard, but it's up to you. Up to you, you can use it, okay. So I'll share this PPT. You can check it later. Similarly, PPT and all, you should not use font size 10. At least you should use title and all. Which one? 36 to 44. Sections will be 28 to. If you use 10, 12 and all, very difficult to see by the audience, okay. And these are some font size. General rule is, please write down, PPT minimum how much? 14, and dashboard are minimum 10, okay. Dashboard means there is one interactive dashboard, 14 you have to mention, okay. So this is the third minimum font size you have to keep it. All about, this is all about which one? The font size, style and size. How many we completed so far? 30. 14th is this one, clarity is important than simplicity, narrative, design function, we already have discussed, okay. This one. Last one, this is very important. The last principle is 3 questions. Before applying any visual, we have to ask 3 questions. For example, if we are getting a data, student data, before applying visualization, we have to ask 3 questions yourself. What are 3 questions? What type of data? Whether data is a time-based data or cross-sectional data, what type of data, that is very important. Second question is which one? What is the objective of analysis? I am trying to find out the relationship, all these things. Third question is, who is the inducer? Inducer is highly technical people or normal like us, or very lower than they are not able to understand what is chart. Accordingly you have to select. If it is very highly educated people, very technical people, you can go for complicated chart. Very simple people, very school student, you have to go for which one? Basic pie chart, basic chart, okay. First one is what type of data, second one is what is the purpose. You did remember second principle. What is second principle? Second principle, purpose. This is all about you have to select the chart with respect to purpose. Third one is, what is the third one? End user. Who is the end user? You have to check it. Accordingly, you have to use your chart. If you are following this, it will be effective data visualization. Are you able to understand? So we completed 15, but this principle. What are the 15 principles? First one is which one? Clarity is important, okay. It's not about beauty, clarity is important. Second one is purpose driven chart. Third one is on-scam content. Always data will sometimes mislead, visualization. Data source also same thing. Fifth one is, we have to give more color and this thing for data compared to the background other thing. Another one is jot chunk. Don't put too much background, too much color. May focus on this one, okay. Seventh one is prior. You have to, if you want to highlight something, color, size, you have to add. That's a prior. Eighth one, gray. Back side should be light color, okay. Always. Then item, whatever corner, top, you have to keep proper information, important information. If you want to show anything, the top corner will be very, very important compared to the down and other thing, okay. Then context and story. Another one is story. The context is always people will sit for visualization, not for only seeing how you are going to explain, showing the visualization, connecting some important story, some example if you give, they will be very happy to look at your presentation, okay. Each slide, that is the next one. Okay, yeah, the ethical visualization is there. That we are looking for not good. We are getting good chart. Okay, font size we have discussed. Last two is key principles and 3 questions. These are the basic. It's very difficult to follow everything. You keep in mind whenever you use visualization, whatever possible you try to use it. Okay. Now we are going for the third part. What is third part? Hands-on in the data visualization. Please, if you see your desktop, there is a orange software. Just open that. There is a software called which one? Orange. Just go to your desktop. There is a software called which one? Orange. Just open that. Just open that. Okay. There are a lot of softwares are there. We are going to use which software today? Orange. Okay. Please write down this one. This is also important. There is a Gartner report 2025 last year. Market leader data visualization. Please write down. Please, Power. Microsoft. What is the software? Please write down. Power BI. Power BI. Another software is called which one? Salesforce. Salesforce, what is the software? Tableau. Please write down. Microsoft, what is that software? Power BI. BI mean B for Bombay, I for India. Power BI. And Salesforce, which software? Tableau. These two software is which one? Market leader. There are other softwares are there, but we are going to use open source software called which one? Orange. But this two software is very powerful for which one? Data visualization. Very Power BI. Next one is which one? Salesforce. Fine. So we are going to use which software today? Orange. Can you open the software, please? Everybody open the software. See, please understand. We completed two parts. What are the two parts? Introduction to data visualization. Why the importance of data visualization? We understand why it is all these things, how it's useful, all these things. Second, principles we completed. What are the how many principles? 15 principles. Now we are going for the third part of our presentation. What is that? That hands-on experience we are going to do in the lab. Please open the software. Everybody having the software? I'll also open here. This is the Orange software. We are going to focus on data visualization. Okay, everybody ready? This window, please close it. This window, please close this. Everybody come to which window? This window. Everybody ready? Already desktop it is there. I think they have installed almost. Laptop, if you want, you can install. So you type Orange. What is that name? Data mining. I'll show you. If you want to install in your computer, I'll show you. Look at my screen. You have to type Orange data mining. What are the first window you have to open? Okay. This is for those who are bringing laptop not install. In main page, this is Orange data mining. Just you have to click download Orange. Download Orange. Don't other people don't do it, but those who are not downloaded, just after this you can download. This is for Windows. There are Mac and other thing will be there. This is for Windows. If you click this, it will open. Windows. See here it is downloading. I am not installing. Okay, because already I have installed. 2 click. Go to the Orange website. Download Orange. It will show the different version. Mostly people use which one? Windows only. Just Windows. There are Mac and other things are available. Only Windows is already. I think most of the laptop it is already there. If it is not there, please change the computer. There are other computer, any free computers are there, change it. I think it will. I think they have. I have taken some 2 sessions. Most of the laptop it is the desktop it is there. So can you open this? Go to file. Data. Everybody come to data. Can you see the different windows are there? Left side there is something called which one? Data. Click the data. There is something called file. Just click that. Okay. If 1 click it will come here. 2 click 2 times will come. It is not available, madam. Anmol, please help me. Wait, madam, it's downloading. I think it's there, no? Not there, madam. It is there, no? Already. Why you are downloading? Directly open, madam. I think you open multiple times. It's already is there. Why you are multiple times? You are opening multiple times. 1 time is enough, madam. Come 1 minute. It's coming. Just close this. That's it. Wait. Anybody needs support? No. Go to desktop. It is there, no, orange. Please check your desktop. There is a logo called which one? Orange. Just click that. Don't download, because those who are having laptop, you download. A desktop mostly it will be there. I think here also it is there. Orange is there. You think everybody having orange? Don't download. Only just click the desktop. There is something called orange. That's all. Wait, sir. Don't do. Please understand. First time you are using, don't click anything extra. Just learning purpose. Just follow my instruction. After that you can try. You can install anything. But for learning purpose, please come along with me so that you can learn. So everybody open, everybody this window everybody ready? Okay. Now just click which one? In the data there is option called file. Can you see? File, just click one time. Don't click multiple time. One time. Assume that if you click multiple time, you put Control Z. What is the Control Z? Undo. Undo. Okay, or you can click and delete. That's fine. So you click one time, you got which one? File. Ready? Now we have to import the data here. Okay. So we are not going to import any data from outside. We are going to import data from the Orange software itself. Okay. Shall we do it now? So everybody ready up to this file? Just double click here. Please again I will repeat, don't do any extra, please follow the instruction. First step is opening the software, second step is clicking the file. Now we are going to third step, we are going for which one? Importing data. Okay, listen here, just double click the file, double click the file, are able to see this window? Okay, so if you want to import your external data, outside the data, you can go for, don't do it, just listen, you can click this folder option for importing which data? Your own data. But we don't have any our own data. We are going to use which data? Orange software itself. Okay. For that, please, there is something called browse documentation data. Click here. Are able to get this window? Don't click the folder. You have to click which one? Bottom one. Are able to click it? So you are getting this window. Click the or this is tab. This data. Or this is tab, click this or this is tab, open, or click or this is tab, open, that's it. Then close this. Can you see or this is? I will repeat again, please listen. Click this file, then which one you have to select? Browse document. Are you able to see lot of data is there? Which data you have to select? Or this is open. Then or this is tab dot metadata, don't open. Or this is tab, that's fine. Click which one? Open. Already open, okay. Then close this. Ready? Now third part is over. We imported which data or this is. Now want to see the data. Symbol, Anmol, you check it. Which symbol is coming? Anybody getting symbol? No. Only file will be there, inside data. Now we want to see how the data is there. So if you see the file, there is something called data table. So in the data, we already import a file. In the data, there is one more tab called which one? Data table. Are you able to see? Just click that. Data table. Data table. Locked, So now you have to click which one? Data table. Okay. 1 minute, I'll come. Just give me 1 minute. To browse, madam. Browse. What is this? RDP. That's it. And close. Now just click the tab. To me, madam. Or this is. That's okay, madam. We'll see. That's okay. We'll see. Is working.
There is a message is coming, sir.
If data is there, no problem. Wait. Correct. Some message, some problem, leave it, no problem. Okay. After that, now two tabs are. What are the two tabs? File and data. Now you have to connect. You want to connect and see. So please listen. 1 minute. Please listen, everybody. Look at my screen. Can you see the dotted line here and there? Okay. Dotted line. Please go to the first dotted line. Click this and drag and drop it here. Can you see the dotted line can become full line? Can you see? Just drag and drop it here. That's it. Now both are connected. Data and the table. Now you can see the data in the table form. Can you click the data table? Double click. Can you see the data table? All the data are. How many rows are there? 303 rows are there. How many columns are there? 3 columns are there. Are able to, the column is features and row is this one. Are able to see? First column is diameter. How much the diameter of this one may be, age, gender, like this is there. How many columns are there? 13 column, 303 sample, maybe like this each sample. Are you able to understand? file, and now we have to do some data visualization. Shall we do it now? We taken the data, we saw the data, now we are going for which one? Data visualization. Okay, now please come to the visual. There is a tab called which one? Data is over, now we are going for which one? Visual, our focus on visual. Please click, there is something called visual, and first one, what is the first visual? Tree map. Second one is box plot. Click box plot. Click box plot. Are you able to get it? Directly connect data to box plot. See, it is not in data, it's there is a data visual. Data visual. There is a option called data visual. Please go to there is a box plot, no sir. Just double click that. Here double click or click one click is enough. If you are getting two chart, undo. Now after dragging the box plot, double click the box plot. I will explain. Madam, it is there, no madam? It is there, no? Down. See? Visual. Double. You put it here and again same. Drag it. It is there. Okay. Okay. Now after dragging the click, madam, data visual. Which one your box plot? I'll repeat again. Box plot you have to click. Once you click, it will come. If you get 2 times, if you click, what will happen? 2 times will come. Undo, you do it. 1 time. One you remove, madam. Just click and delete. Okay, everybody got this box plot. Now I want to see the visuals. Just double click here. Can you see the visual? Okay, now what is the visual here? Can you see this? Can you see the line selected here? Can you see this? Chest pain and age. Chest pain and age. If you look at this, I don't want this one, I'll change it. I'll change it which one? Gender. Gender and yeah. Diameter narrowing and gender. Yeah. Okay, you just try age and gender. Age you select there. See, if you look at this gender, why only two box plots are there? Male separately for male, separately for female. If you see this is the minimum age of the which one? Male, and this is the maximum age. This is the mean age. This is the first quartile, this second quartile, like that. Okay, this is the minimum age of which one? Female, and maximum. Can you see the dot here? This is the first quartile and the second quartile. This is the average. So why we are getting 2? Because of the gender. If you want, you can change into chest pain. What is this? Cholesterol. Okay. Sorry. Like this we can change it. I will go with gender. Like this you can go. Okay. This is all about which one? Box plot. Okay. Please close this. So if you want to use this for my PPT, I want to use this for my report. I want to download this image. So please look at my screen. Can you see something called save here? Save button. Down, can you see? There is an option called save. If you click, it will we can download as a which file? PNG. You can give the name. Any name you can give, and you can download. Are you able to see? There is an option called save. Just click and this one. It will show as an image. Then you can copy paste. I'll repeat again. Please look at my screen. How to save this? Here. Down, can you see? There is an option called save. So whatever image if you want, you can save. You can change here and there and save it. Is it fine? So we completed the box plot. Like this, we'll try to 5 to 6 chart. Save option is there, sir? Which one? Yes. Maximize, sir. You maximize. You maximize. If you see the save option is there. Maximize. I think you are seeing the back window. You have to see this window. You have to maximize. The save is there. Maximize. Double click, sir. Double click the box plot. Maximize. Maximize center. Center. See the save. Save. Can you see? So you have to maximize the box plot window. If you see this previous backside window, save will not be there. Okay. Any name you can give, it will and copy paste into PPT or in the Word document. Are you able to understand? So you have to maximize the which window? Box plot window. Okay, I'll close this and delete the box plot. How to delete? Just click here and delete button. So we over which one? Box plot is over. Now go to the left side. What is the next one? Violin plot. Just drag and drop it or double click. Either way it will work. Either drag and drop it or which one? Click. Violin chart. Before that you delete which one? Box plot already over. Now how to connect? Anybody? File to this one. Just click here file and drop it here. File to violin chart. Are you able to do it? Just double click. Now you want to see the chart. See, now you have to go to box plot to violin chart. Same, how to do? There are two ways we can do. Out the two ways, double click or drag. After that you have to drag, line it. Now if you want to see visual, what to do? Double click the violin chart. Just double click the. Well, not joy, huh? Okay, maybe some problem is there, leave it, no problem. Okay, some people are getting violin chart. Okay, I think some downloading issue. So this is similar to the, what is this? Violin chart not there. First you delete, sir. Delete first. Click and delete. Delete button. Delete button is somewhere, it will be there. That's it. Now drag the second violin. Go up a little up. Somewhere violin chart. Here left side only. Here a little bit over. Second. Now drag from here. Here. File. I think somebody doesn't have violin chart, no problem. It's similar to the what is this box plot, but it will show the data. It will show the data also, not only this one. Can you see the left side? This gender and cholesterol. If you want to see the what is this major set by exercise. So all these things will get it. Okay. So this also you can Y2 male and female. Okay. This is a male minimum and maximum. This is the data point. Okay. So close this. Violin chart over. Next chart, delete it. Next chart, what is the next chart? Distribution chart. How to take it? Just double click. 2 times mean delete one. Okay. I will put it somewhere in the file. Directly collect in the file. I will come out of this better. This is called which one? Distribution chart. Can you see the distribution? The line will not be, I think you don't have line, no? You see this normal, you have to click. Fit distribution, none will be there. You have to use which one? Normal. Okay. So how to do a distribution? Just double click and connect file from this. That's it. If you are getting line, what you have to do? Change the distribution from none to which one? Normal. For you, I think none will be there. You have to change it to normal. This is the distribution of which one? Age with respect to gender. Age with respect. What is the color denotes? What is the yellow? What is the blue color? What is that? Anybody? Female. And red color is which one? Male. Okay. The x-axis is the age. Y-axis is which one? Frequency. Are able to do? Frequency distribution. Very good. Tell me, madam. Normal, madam. No. You see left side, there is something called fitted distribution. Can you see? And the yeah, good normal. Normal. Normal line will come. You know normal distribution, right? That's a normal line. Is it okay? So we completed 3: box plot, violin, and normal. You see this normal to but data might have, I have taken age and here gender, age and gender, you check it whether you have taken different. I have taken gender here, there I have taken which one? Age. If you are taking this combination, you will get this chart. If you are getting different combination, different, don't worry about chart this one, understand how it looks, okay. Based on the same variable you will get it. So, is it okay? Are you able to do it? Shall we proceed? Anybody need support? This side okay sir? This side? Okay. Please close this. Now delete which one? Distribution. Now you put the scatter chart. Now which chart? Scatter. How to delete? Did you know, right? How to, just go to their particular place and delete it. Then you take which chart now? Which chart now? Scatter. Now what is the procedure? You know, already know, right? What is the chart procedure? Just connect with the file. Which file? Disease file, that R disease file. Just double click, you can see some charts. There are different things are there. We have to age and cholesterol. Color, you change the different, let's say. Okay. Yeah, scatter plot. I have done here left side. Can you see? I use age and cholesterol. When age increasing, cholesterol also increasing. Can you see this? You change only which one? Age and this one. If you want some color, you put legends, grid line. If you want, you can put it, or no problem. Regression line. If you want, you can put it. Okay. What are the variable I have taken? Same process. Drag the scatter plot, connect the file. You change this. I am finding the relationship between age and cholesterol. What is the x-axis? Age here. What is the y-axis? Cholesterol. When age increasing, cholesterol also increasing. Can you see this? This dot related to age 70 and low, I don't know. But here if you see age is 70, cholesterol also. But most of the thing is there. Okay, fine. Is it? Yes, only thing you have to try with the different combination. If you are finding the relationship for any two variable, for example, chemistry, yes, sir. Chemistry, if you want some x-axis, you can use it. Color also you can use it. Based on the logic only you have to use it. If you have some base paper, base support is there, you can use it. So only this chart is focusing on a relationship. Scatter the x-axis, y-axis relationship. If you want to focus on relationship, you can use any variable. Okay. So please close this. How to save this? You understand, right? How to save? Just down and save it. Please close this. Now delete. Next chart, line chart. Line chart. Drag and drop it. Line chart. I have taken gender, range, line. Fine. See, x-axis is the age of the male, age of the female, average age of the rest, like this. See, can you see the gender here? Gender I have selected. Only two colors. If you select the chest pain, how many colors are there? 4 type of chest pains are there. Can you see? Gender 2 type, chest pain 4 type is there. What is the x-axis? Numerical variable, age and anything. This is the average. I will use only gender, so that we will use this gender. Okay. Which chart it is? Line chart. Previous chart delete, connect and double click. Very simple. Only thing I am using one example. After the class you try with the multiple exam. You can import your own data also. You can explain. Anybody need time? Shall I proceed? Text, there is a different image option is there. They have to use. That's advanced chart. That is also possible. Correct only, sir. Correct only. Correct. You click gender. Same chart, no? That is okay. This is fine. No need to change. Yes, this is fine. No, don't change anything. This is a default software that customizes the Python. Okay. Next chart. Please close this. Please close. Delete the line chart. Now bar chart. Which chart? Bar chart. Drag and drop it here. Now which chart you have to use? line chart delete. Now you have to use which chart? Bar chart. Click that, you will get the bar chart. This is the bar chart. Values, age, group by, okay. X-axis is the male and a female, height is age related. The color denotes the diameter narrow, 0 and 1. 0 means no hard problem, 1 is hard problem, okay. Like this we can. If you want to change the different try later, okay, I use which one? Age, gender, and a heart diameter, okay. Any problem is there? Problem means 0, no problem means 0, 1 is problem, okay. This is all about which chart? Bar chart. Please close this. Please close. Delete this. Next one is CV diagram. Drag and drop it. Double click. This next chart. Delete the bar chart. Now use this chart. This is the cross tabulation chart. This is the cross tabulation between chest pain and gender. Gender, how many options are there? I think 2 options. I think chest pain, I think 4 options are there. 4 into 2, 8 boxes will be there. Can you see the 8 boxes? Can you see 8 boxes? Why 8 boxes? 2 gender, chest pain is 4. So 2 into 4, 4 combination. So mostly male and the first chest pain more people. Okay. So this is male and second and third is more. Female we are getting first only, but first and third is common between male and female. I think third and second chest pain is less better. Just click that. No sir. This is the combination. See here, what is the x-axis? What is the y-axis? Gender. Okay. If you see the gender, how many options? 2. So this is the data of which one? People 3. Male and which asymmetric. This is which one? Female and asymmetric. So bigger the chart, bigger the people, the combination. These combinations are more. Okay. So the size is more sample. Out of 355, more people are this combination. The size denote under this one, the more combinations are there. Typical and female, yeah, very less. Line leave it, maybe the size only, overall size. The line don't, the size only important. The line inside this don't go, size only, overall size only important. Okay. Yeah, are you able to understand? This is like a cross tabulation. Okay, last chart will take it, delete this, go to heat map. Which one? Heat map. Heat map. Heat map. This will show the distribution, heat distribution. Maybe we have to change some other variable. This is the, there is a k-mean clustering, and this is a heat map of a combination. 0 to this one. The diameter narrowing heat map. Clustering, here we will get the clustering also. Okay, fine. This is the heat map. Higher the color, higher the intensity. Lower the color, less intensity. Okay. Leave it, heat map. Like this, lot of charts are there. Okay. So just I will summarize the entire chart. I will share this PPT. See, this there are advanced charts are there. I will show you. Here, pre-vis chart. This chart is useful for machine learning. I am not teaching machine learning here. This advanced topic will come later. Some people will teach all these advanced techniques. This is the basic data. What are the charts we have discussed? Line chart, bar chart, column chart, box plot, violin chart, another one is which one? Scatter plot. This is a basic chart. Remaining charts, other charts are, this is not a simple chart, it's a complicated chart. For example, machine learning. This is chart used for which purpose? Classification purpose. What is the chart? Previous. Okay. Similarly, if you look at this chart, linear projection chart, this is used for the high dimensional data. Okay, this is not for, because if you teach this very difficult now, this is not a basic chart, this is advanced chart. Okay, visualize. The red BC is for, okay, this is another chart. So if you see the linear heat map, there is a Venn diagram chart is there. This is for the logistic regression purpose, machine learning purpose. This silhouette plot, this is for the k-mean clustering. Okay, Pythogram chart is there. This is for the tree-based visualization, hierarchical clustering. Okay, Pythagorean forest is there. It's advanced this chart. Okay, these charts and all normally not used for which purpose? Basic descriptive chart. This is for, okay, these are the chart. Please look at my screen. If you want to use single numerical variable, which chart is better? Histogram and two numerical variable, scatter plot, time series pair, line chart, categorical chart, bar chart, two categorical, this chart. These are the advanced machine learning based chart. Now, we are not focusing. Okay, we are focusing only on which chart? Basic visualization chart. There are advanced chart. If you teach this, very difficult, without concept is very difficult. We have discussed only 7 to 8 chart, which is basically for descriptive statistics, descriptive analytics. Okay, fine. So we completed the 3 parts, just another 5 to 10 minutes I will complete. Okay, so now napkin tool, another tools. So which tool we use for data visualization now? Orange. There are other AI tools are available, that is for advanced purpose. Okay, please write down. The first tool is called which one? We already know what is the tool. Just 5 minutes. Napkin tool. What is this? Notebook LM. Okay, already we have discussed this one. Okay, another tool. Please write down. Napkin. Okay, after the class, please check it. There are YouTube video and websites are available. Here also similar to Notebook LM. If you give some video, audio, or voice message, or what is this? I am going to teach this concept. These are the things. If you give voice or upload some text, it will create. It's similar to Notebook LM only. This is also very powerful for using the data visualization. First one is which one? Notebook LM. Second one is which one? Napkin. Third one is if you are using a PPT. If you open your PPT Office 365, there is an option called which one? Copilot. Another one is suggest design. If you Copilot, I am teaching basics about organic chemistry, basics about physics, practical, give some slide design. If you type it in, automatically slide will be created. So there is an option called which one? Can you look at my screen? Slide with the Copilot. Design it, you can interact. You can type some message here. Add Copilot. Give some idea for creating a student is +2 student. I want to teach this subject. Can you design the slide? It will create. This is not separate. It is that in Office itself. Okay. First one is napkin, notebook column. Second one is napkin. Third one is notebook. What is this? The PPT itself. Third one is Gemini. There is something called Nano Banana. Anybody know this? In the Gemini, if you go there, it will create a. We can see the Facebook and other things. The people are fighting. No, this one. There are new videos. It's something called Nano Banana in Gemini is there. Okay. Another one is Nano Banana. It's coming from which one? Gemini. This also you can explore. It will create a very beautiful video. If you want particles talking to each other, chemistry, something. If you want situation, automatically create some kind of actors, something. It will talk each other. It will create. Show to video to this your student. They will be very happy. Okay. Come show some video also. Okay. In principle, how many principles we have discussed? 15. And data visualization just now we have taken. We have taken 7 to 8 charts, basic charts here. There is other charts also. This advanced chart. I am not teaching. There are after that we went for 4 to 5 AI tools. Okay. So this is all about this one. And if you want further reading, okay, there is a YouTube channel called which one? Orange Data Mining YouTube, official YouTube channel available. If you want, lot of videos are available. Data Mining YouTube, official YouTube channel available. If you want, lot of videos are available. So what we have listened just basic. If you want to learn further any kind of new things, there are regularly this YouTube channel. This is official channel, not from any private people. Official channel of which one? Orange. They will posting lot of video related to Orange. If you want not only visualization, other things are available. Okay. And another one, if you I told you right, there are main software. What are the main software in data visualization? Power BI and Tableau. Apart from Excel is common for everybody. If you take any laptop, any company, anywhere, if you go desktop, anything, basic software is which one? MS Office. In MS Office, what will be there? Excel. The Excel also we can use it for data visualization. If you want to learn this, there is a course that university, the Coursera, if you want to certificate, you have to pay. For just learning purpose, there is an option called audit. So you can just see all the video, download data, and you can check it. This is for which one? Excel. Excel. You know Coursera, right? Yes. Another, this is for Python. There is a one popular software open source called which one? Python. So there is a course called IBM course. It is also available in Coursera, talking about which data visualization? Python based data visualization. Python is which software? Similar to Orange, that is also open source software. Next one is data, this is for edX. You know, there's one Coursera, another one is EDX. You know EDX? edX. So there is edX. Okay, thank you, sir. Okay, thank you so much. Thank you so much. Thank you for active learning. Thank you. Thank you so much. We'll meet some other time. Thank you so much. Thanks. I think tea. Thank you. Tea is available, I think, sir. Please. I think again another session also will start marathon. Okay. Thank you so much. Thank you for your time. Thank you. Participant, okay, I don't know. Please answer because they are asking. Other sessions they are not asking.
So this session will be taken by the Dr. Jovan Jose, KV. Let me give some brief introduction about this sir. He is an associate professor of theoretical and computational chemistry at the School of Chemistry, University of Hyderabad. He earned his PhD in chemistry from University of Pune 2009, followed by postdoctoral research at Ruhr University, Bochum, Germany 2010-2011, and Indiana University, USA 2012 to 2016. His research focuses on developing new theoretical methods for spectroscopic properties of large molecules, predicting crystal structures, building reactive force field using neural networks, peptide folding pathways, molecular electrostatistics, and efficient algorithm for molecular flux. Dr. Jose has published extensively in leading journals such as Journal of Chemical Theory and Computation and Journal of Chemical Physics, with notable contributions to fragmented based approaches for biomolecular spectroscopy and neural network potential for molecular simulation. He also actively supported PhD postdocs and summer research opportunities with projects funded by DST, SCRB, and STARS, Government of India. Over to you, sir. Thank you.
Okay, thank you, Anmol. So once again, a warm welcome to my talk. So I was not aware of your background. Are you chemist, physicist, mathematicians? I don't know how many of you are chemist. Okay, chemist, biologist? No biology. Or physics? Okay, mathematics? Okay, sure. So I was not aware of your background. So the title that was given to me was Machine Learning in Chemistry. So since I am a theoretician actually, so I have to usually I talk on quantum chemistry. I don't just talk on chemistry. There are many things that is happening in chemistry, but I especially work in theoretical chemistry. So we basically make use of quantum chemistry. That's why I wanted to, I'll be discussing about quantum chemistry. Okay. So eventually I'll be discussing how we will make use of machine learning in quantum chemistry. Okay. And this is the agenda actually. The quantum chemistry is nothing actually, it's same as quantum mechanics. Chemists borrowed the quantum mechanics into chemistry, we made it into quantum chemistry. So I'll just give a brief introduction about quantum chemistry, then we'll worry about how we can make use of machine learning in quantum chemistry. Okay, so basic equation I will introduce, then we'll see how we can make use of machine learning to simplify our models. So in the beginning, actually, as we know all about quantum classical mechanics. This was one of the most celebrated mechanics till the beginning of 20th century. So using classical mechanics, people could able to explain most of the experimental observations. And as we know, actually, the foundation for classical mechanics was laid by Newton and Newton's three laws. And he published his 3 laws in this particular journal called the Philosophiae Naturalis Principia Mathematica. So as we know, actually, the 3 laws of Newton, the first law is the object in motion tends to stay in motion. This is the principle of inertia, law of inertia. And the second law is the force equal to mass times acceleration. And the third one, all of us know actually, every action has an equal and opposite reaction. So these are some of the well-known things for us actually. And using these mechanics, people were very happy till the beginning of 20th century. And some of the experimental observations in the beginning of 20th century, people could not explain using these mechanics. So there were 3 experimental setups actually. One was the ultraviolet catastrophe. This was this experimental setup is like this is the spectrum of a black body. Hope you know what is a black body actually. Black body is an object which can absorb all the radiation, and while we heat the black body, it could able to emit all the radiation out. And experimentally, when we look at the black body radiation, this is the relative intensity and the frequency of emission. And if you look at the spectrum of the black body, so it is a continuous spectrum starting from a low frequency to a higher frequency. But when we make use of the Newton's classical mechanics to explain or to justify this distribution, in the classical mechanics, it could able to explain the distribution of the spectrum only up to a frequency. Beyond that, this line goes to infinity. That's why it's called a catastrophe. So thereby, this mechanics, the classical mechanics could not be able to explain this behavior of the black body. That is one observation, one of the experiment that classical mechanics failed. Another experiment was by Stern and Gerlach. Stern and Gerlach were 2 of the German scientists. What they did is they took silver particles and they passed these silver particles through a magnet. So this is the north pole of the magnet, south pole. And when they passed these silver particles through a magnet, what they saw is, instead of 1 point in the detector, they found 2 points on the detector. Suppose imagine this was a classical object, maybe it's a cricket ball. If we pass a cricket ball through a magnet, what do you expect actually? We expect only 1 point in the middle of the detector, because the cricket ball is not going to deflect by the magnetic field. But on the other hand, since they use silver particles, what they saw is they found two dots in the detector. Okay, so justification for this can be given based on the electronic configuration of silver atoms. So if you look at the electronic configuration of silver atom, the outermost valence shell is having single electron. The single electron can have a spin of half, plus half, otherwise minus half. So the plus half and minus half spin will behave differently in the presence of magnetic field. That's why they were getting 2 spots in the detector. Another observation was on the hydrogen spectrum. In the hydrogen atom spectrum, this is the emission spectrum. So what we expect is, just like a black body, it can absorb any kind of light and it can emit any kind of radiation. But in the atomic spectrum, what they saw is, in the emission spectrum of the hydrogen atom, they could see only series of lines. So the lines were not continuous. The hydrogen atom was emitting only radiation with certain specific wavelength. Okay, so it means there are certain quantization within the atomic energy levels. That's what we can conclude from here actually. So these experimental observations, people could not be able to explain based on the classical mechanics. And when we go to the miniaturization, like of the order of nanometer scale, when we are at the meter scale, we don't really see the quantum effects. But when we go to the millimeter also, we don't really see the effects of quantum effects. But when we go to the nanometer scale of the order of, when we start looking at molecules or atoms, of the order of nanometer scale, we start seeing the quantum effects. And I just want to know how different are these classical behavior and quantum behaviors. So this Thomas Young, he was one of the physicists actually. He is the first one to prove the wave nature of light. So as you know, the light behaves like a wave. So he is the first one to prove the wave nature of light. He had a setup called Young's double slit experiment. So Young's double slit experiment setup is something, this one. So there is a source here, there is a source, and this source will be passing through two slits. So in the first wall, there are two slits, one slit and second slit, and behind the slit, there is a detector. And what Thomas Young did is, he passed light through these slits, and he detected the light in the detector. And he just saw certain patterns in the detector. So what we are going to do is, we'll take the same Thomas Young experimental setup, we will play with one of the classical object, another wave we'll play with, third one is we will play with electrons. So in the first case, we are going to take a classical object, we can take our bullets. So we can take bullets of the same mass and of the same size. Okay, and what we do is, we will perform the experiment with a classical object in 3 different phases. In the first phase, what we do is, we'll start firing the bullet from this side, and in the first phase of the experiment, we keep the first slit open, and we keep the second slit closed, and we detect the classical particle in the detector. Okay, we will keep the appropriate detector to count the number of bullets reaching this detector. So when we count the number of bullets reach the classical bullets reaching this particular wall or the detector, we get a Gaussian distribution, something like this. Because at the middle of the detector, we get the maximum probability. As we move away from the center of this slit, the probability will decrease. So we get a Gaussian distribution, something like this. And similarly, in the second phase, what we do is, and in the first phase, we call this total intensity, the total probability as P1. So this is a Gaussian distribution, the total probability is P1. In the second phase, what we do is, we keep the first slit closed and we keep the second slit open. We start again firing the bullet, it's a classical particle, then we detect the bullets on the detector. So we again get a Gaussian distribution, something like this, and we define this probability distribution as P2. Okay, now in the third phase, what we do, we keep both the slits open, we start firing the bullets from this side, and we detect the bullets in this detector. Okay, so when we detect the total probability in this detector, what we can see is, we get a total probability, something like this. We get a single dumbbell, because the total probability is an additive sum of the individual probabilities. So this is the way a classical object will behave, because the total probability when both the slits are open is going to be P1 plus P2. Okay, so this is the behavior of a classical object. The classical object has a mass, we can measure, we can detect, we can feel it, right? Now, the same experimental setup we are going to play with a wave. Okay, so the same setup. In the first phase, we are going to keep the first slit open. So here in the second phase, we are going to play with the wave. Here we are passing a wave. This can be wave front, it can be light, whatever actually. So these are the waves, okay? And we pass this wave through the first slit, and we measure the wave at the detector. We put the appropriate detector to measure the corresponding intensity at the detector. So we get a Gaussian distribution, something like this, when we keep the first slit open. In the second phase, what we do? In the second phase, we keep the second slit open, we pass the wave again, we detect the corresponding wave at the detector. We get again a Gaussian distribution, something like this. Now in the third phase, what we do? We keep both the slits open, we pass the wave through both the slits, and at the detector, what we surprisingly see is an alternative dark and light bands at the detector. Okay, so this is the special behavior of a wave, because wave from both the fronts, from both the slits interfere at the detector, and when the two waves from both the slits interfere at the detector, we can start seeing dark light, alternate dark and light bands at the detector. So this is the special behavior of waves. So here, when we look at the total intensity at the detector, this is not a sum of individual intensities. This is not total intensity is not equal to I1 plus I2. The total intensity is going to be something more than that. there is an additive term here. That term is coming because of the phase difference between the two waves from the two slits. Okay, so we have to worry about the phases of the waves coming through the both the slits when we look at the intensities. Okay, I think it is very clear, no? No complications. Okay, now we are going to play with electrons. We just want to know how the electrons are going to behave. Whether the electrons are going to behave like a classical particle or it's going to behave like a wave. Okay, so just start firing electrons from the source. We will generate electrons from the source appropriately. And in the first phase, what we do, we keep the first slit open and we keep the second slit closed. We start firing the electrons from here, and here, since only the first slit is open, it will pass through the first slit, and at the detector we get a Gaussian distribution, something like this. Okay, and in the second phase, what we do, we keep the second slit open, we start firing the electrons, we get a distribution something like this. Okay, now in the third phase, what we do, we keep both the slits open, we start firing electrons. The electrons are free to go through any of the slits and it will fall on the detector. And when we look at the intensity of the electrons at the detector, what we surprisingly see is we get alternate light and dark bands. Okay, so what does it shows actually? It shows a wave nature, right? Even though electrons are particles, right? Electrons behave like waves. So this is called the matter waves actually. Electrons behave like waves at the detector. Okay. Okay, this much is clear. Okay, now what we do is, we will just tinker around with this particular experimental setup. What we do is, we are going to keep a small light bulb here actually. Okay, why we are going to keep a light bulb? Because we wanted to know whether the electrons are going to pass through this slit or this slit. We wanted to count whether the electron is coming this way or that way. Okay, so for that, we will keep a small light bulb there, and the intensity of the light is very, very dim. Okay, so we keep a small light source here. Why we are keeping a light source? Because the photon from this light will fall on the electron, and that photon will fall on our eyes. So we know, okay, the electron is coming this way. Okay, the electron is passing this way. Now, when we keep this light source, suppose if you could measure all the electrons, suppose I am firing 100 electrons from this source, I could able to measure all the electrons. Suppose I say 50 are coming this way and 50 are coming this way. If I could count all the electrons, what may be the behavior at the detector? When I could count all the electrons, the total intensity at the detector is something like this. Previously, when I missed all the electrons, the intensity was like a alternate dark and light bands. Okay. Similarly, if I miss all the electrons, how the electrons behave? The electrons behave like this. Okay, I could see alternate dark and light bands at the detector. But on the other hand, if I could count all the electrons, it started behaving like a classical object. Okay, so here, when I missed all the electrons, it was behaving like a wave. But when I counted all the electrons, it behaved like a classical object. Okay, now suppose imagine I could count 10 of it and I missed some of it. Okay, in that case, how the electrons will behave? The electron will behave something like in a jiggle and wigglish way actually at the detector. We get alternated light and dark bands, and this is a very absurd behavior actually of the electrons. So this is not neither yes, neither no. Okay, since our vocabulary is not sufficient to describe the behavior of the electrons, whether it is a particle, is it a classical object, or is it a wave-like behavior? Is it behaving like a particle or a wave-like behavior? So this is something in between actually. So we need to have some theory to describe the behavior of these electrons. Okay, and
some electrons missed to meet in the absence of light. Electrons
yeah, yeah, we could count electrons in the presence of light.
So electrons missed to meet in the absence of light.
In the absence of light. Yeah. Yes. When we counted, it means we lost the wave nature of the electrons. So this particular behavior is called collapse of the wave function.
Is it because of interference of light with the?
Yes, because during the action of measurement, it lost the wave nature. Okay, it lost the wave nature. So this is called the collapse of the wave function. This is very known actually. Okay. Now, you may be thinking this is a cooked up experiment by me actually. This is not a cooked up experiment by me. This I have taken from one of the book by Richard Feynman. Richard Feynman, he put it as a hypothesis. Okay, he put it as a thought experiment. But the real experiment happened only in 2013, 2012. They could publish this particular real experiment only in 2013. Richard experiment proposed this hypothetical experiment, thought experiment back in 1950s. But physicists could really carry out this experimental setup. They could construct the same experimental setup, and they could do the same experiment, carry out the same experiment only in 2012. They published this result in New Journal of Physics, and here these are the this is how the electrons, they took electrons as a source, and this is how the detector looks actually. So P1 is a case when there is only one P1 is open, and P2 is a case when only P2 is open. Okay, and when P12 means when both P1 and P2 are open, we could see alternate double and dark and light bands. Okay, so this is not a cooked up experiment. This is a real observation. So this is the real experiment carried out by some of the physicists, and they are published in New Journal of Physics. Okay, and this is a very strange behavior actually, because these particles behave like waves. These are called matter waves, and when they interfere, they create the alternate dark and light bands. Okay, so this is not the speciality of electrons only. People have done the same experiment with different atomic particles, like neutrons. People have taken neutrons instead of electrons. They did the same experiment. At the detector, they could see alternate light and dark bands. Similarly, people have done with helium atoms. Even with helium atom, they could see alternate dark and light bands. Similarly, with the molecules also they have done. C60 is one of the allotrope of C carbon. Here also they could able to get alternate dark and light bands. Okay, and these kind of behavior of these atomic particles we could not able to describe using classical mechanics. We need to have a very good theorem or theory called quantum mechanics. So the origin of quantum mechanics happened back in 1900, in the beginning of 20th century. And as we know actually, and the evolution of this quantum mechanics happened in 1926 by the introduction of Schrodinger equation back in 1926. And as we know, this year we are celebrating the 100th year of Schrodinger equation. 2026, we are celebrating 100th year of Schrodinger equation. Okay, and this how important is quantum mechanics? We can see quantum mechanics everywhere actually, starting with atoms, molecules, and to proteins. Because the title given to me is protein structure prediction and materials chemistry actually. Okay, I just wanted to connect that with this. From whatever we know, I just wanted to connect with protein structure prediction and materials chemistry. We'll be doing some hands-on in the coming classes. Okay, so quantum mechanics basically is rooted on certain postulates. These are some of the rules actually. So postulate basically in some of the books it is written as 7 postulates. I basically clubbed together 7 postulates into 5 postulates. Essentially, this even 5 postulates we can classify into 3. Basically, first postulate is all about defining the system. Okay, so if you want to play a football, we have to define the ground, right? So the system is defined based on the wave function. The wave function is a mathematical function of position and time. Okay, and once you define the system, postulate number 2 to 4 talks about measurements. Okay, how we can perform measurement on this particular system. So we'll come to it. What is the measurement actually? How do we perform mathematical measurements on this particular system to get certain outcomes? Okay, so those outcomes are the measurables in this particular process. And postulate number 5 talks about the motion of the system, basically how the system evolved in time. Okay, so we'll come to the details of these postulates in the coming slides. So what is the consequence of postulate number 1? Postulate number 1 talks about the state of a system. The system can be atoms, molecules, subatomic particles, whatever actually. The system has to be defined by a function or a wave function. This function is a function of space and time. Okay, this is a function of coordinate and time. So when we compare classical particle with a quantum particle, in the classical particle, how many variables we require to define one particle? Yeah, if we know the corresponding position and the momentum of a particle, we can pinpoint where is the particle, right? It's a classical particle. So this particular space is called phase space. Okay, where in classical mechanics it's called the phase space. So a space between position and momentum. Once you know the position and momentum of a particle, we can pinpoint the particle. But in the quantum world, it is called a Hilbert space. Okay, the distribution of the function, distributor of the system is defined by a function. Okay, so this is the function. We can only talk about the probabilities. We can say at the middle of this particular point, there is maximum probability, and as we move away from the center of this particular function, the probability keeps on decreasing. Okay, but we cannot really pinpoint where is my electron. I cannot just point and say, okay, my electron is here. Okay, that is against Heisenberg principle actually. We cannot find the corresponding momentum and position of an atomic particle simultaneously, right? But on the other hand, if I know the corresponding momentum and position of a classical particle, I can pinpoint where is my particle. Okay, so that's the consequence of postulate number 1. And coming to postulate number 2, it's all about measurements. Measurements means this is like performing a measurement in the experiment setup. So we prepare certain solutions, we put the solution inside the experiment. We perform the measurements. So mathematically, this is the way to perform measurements. So what do you mean by measurements? If you want to mathematically perform measurements on a system defined by a wave function, we need to construct something called operators. What is this operator? Operator correspond to a physical property. Okay, the physical property is an observable. Okay, so this particular property we need to decode into a mathematical object called operators. So this operator has to be linear and Hermitian operator. This is a mathematical criterion actually. Basically, it's a mathematical theory. So this operator has to be linear and Hermitian, and there is a definite way to construct operators. Okay, so the simple way to construct an operator for a physical observable is by writing the classical expression, and in the classical expression, wherever we encounter position operator, replace by position operator. Wherever we encounter momentum, replace momentum by momentum operator. So that's a mathematical way to decode a physical property into an observable. So once you have the physical operators, we can act this operator on the function to get certain outcomes. Okay, so if the operator is linear, this is a mathematical definition of a linear operator. If an operator operating on sum of two independent functions, okay, that should be equal to operator operating on F1 plus operator operating on F2, okay, independently. And on the other hand, if an operator is Hermitian, it's a mathematical necessity actually. An operator has to be Hermitian in quantum mechanics actually. The eigenvalues for the Hermitian operators are real. Okay, another is eigenfunctions of a Hermitian operators are orthogonal to each other actually. Okay, and any unknown state can be expressed in terms of these eigenfunctions of a Hermitian operators. And eigenfunctions of a Hermitian operator forms a complete set. These are some of the mathematical properties of these Hermitian operators. Now, once you define the system by a wave function, once you have the operators, we can perform the experiment on the system. How do we do the experiment? We operate the system. We operate the operator onto the wave function to get a number out and the corresponding same system back. Okay, so this particular equation is called the eigenvalue equation, and this number AI corresponds to the eigenvalues. This is the outcome of an theoretical experiment. Okay, when we perform a measurement onto the system, this is the outcome. This is the outcome that we can measure actually. Okay, so what is the consequence of postulate number 3 actually? So in the postulate number 3, suppose in the classical world, before measurement and after measurement, for a known state, outcome is deterministic actually in the classical world. But on the other hand, if it's a quantum elephant, okay, so the outcome can be anything. It can be a colored elephant or it can be a gray elephant. Okay, and also there is one more consequence of postulate number 3. In a classical world, when we perform a measurement on a system, the elephant initially and after the measurement is the same. Okay, there is no change in the state of the elephant. But when we perform a measurement on a quantum system, it will collapse into one of the state, one of the eigenfunction. Okay, one of the eigenstate. So if a system can exist in a superposed state, where we do a measurement on this particular system, it will converge. It will collapse into one of the eigenstate. That's what it means actually. Okay, but on the other hand, the classical object remains the same. There is no change. That's the behavior of quantum systems actually. That is the behavior actually. Okay.
The student has the same complex.
Yeah, that's a quantum behavior actually. So I just comparing classical behavior with the quantum behavior. In the classical thing, even if I measure your height 100 times actually, it's going to be the same, right? There is no change in you. But if I start measuring the momentum of an electron, after I perform the measurement, it's gone. Okay, it will collapse into one of the eigen state. Okay, so since we measure, so suppose if you perform the experiment n times, you will get n eigenvalues as outcome. Okay, now out of the n eigenvalues, which is the most probable eigenstate? Okay, so for that, postulate number 4 gives a simple way to find the average value of your experiment. The average value we can mathematically decode as this way: integral psi star a psi d2. So this is a simple mathematical way we can find an average of an experiment. Okay, now the postulate number 5 talks about the evolution of the system. How a system will evolve in time. Suppose we know the initial position of a classical object, we know the initial momentum and the initial position of a particular classical object, and if we impose the Newton's equation of motion onto this system, we can find what will happen to this system after a particular while. Right? Using classical equation, we can find the future of the classical particle. Similarly, in a quantum, if it is a quantum particle, we are going to define the function. We wanted to know how this system will evolve in time. After a particular while, how this system will evolve in time. So that evolution is defined by an equation called time-dependent Schrodinger equation. Okay, the time-dependent Schrodinger equation talks about how the wave function evolve with time. Okay, so the first derivative of the wave function, how it is evolving with time, is given as Hamiltonian into wave function. So this is one of the postulate. We cannot ask why it is so. Okay, this is one of the postulate. We cannot ask any question like why it is so. So this is the way the system evolves in time. Okay, and okay, so another question people ask is how to get a meaningful wave function for a system. The meaningful wave function for a system we have to get by solving the Schrodinger equation. Okay, suppose even if it is an atomic particle, if it is a molecule, if it is a protein molecule, if it is a material, even if it is a human cell, whatever actually, even if you want to find a meaningful wave function for a given system, we need to solve the Schrodinger equation. Okay, but there are certain limitations of solving Schrodinger equation, and unless we solve the Schrodinger equation, we cannot get a meaningful wave function defining the system. So a simplification for time-dependent Schrodinger equation people have done is like, since it is a very complicated differential equation, this differential equation we have to solve. So since this wave function is a function of position and time, what people have adopted is they came up with certain assumptions to simplify the differential equation. Okay, so what they did is they defined this potential. If this external potential is only a function of position, what we can write is, instead of v of x comma t, we can write it as v of x. Okay, similarly, if we can write the total wave function as a product of two independent functions, the first function is only a function of position and the second function is a function of only time. So since if we can adopt these two assumptions and if we put back into the time dependent Schrodinger equation, and if we just manipulate the equation, we get something called the time independent Schrodinger equation. Okay, and the solution of a time independent Schrodinger equation we can write as something like this. The total wave function we can write it as e to the power I et divided by h cross psi of x. Okay, and by solving the Schrodinger equation, we can find the corresponding eigenfunction and the eigenvalue. So the corresponding wave function is the eigenfunction and the corresponding eigenvalue is the corresponding energy of the system. Okay, so in general, we can write this time independent Schrodinger equation as an eigenvalue equation. So here we have the operator operating on the system, giving the corresponding eigenvalue times the same system back. So this is an eigenvalue equation. We are operating on the system, we get a number out and we get the same function back. So this is an eigenvalue equation, and essentially we are interested in finding, we have only one equation and two unknowns. Okay, we don't know what is the corresponding wave function, we don't know what is the corresponding eigenvalue. We have only one equation. Okay, so for solving these kind of equations for a many particle system, we need to come up with approximations. Okay? Maybe in our 10th class knowledge tells that if you have a linear equation in two unknowns, how many equations we need? Yeah, if a linear equation has two unknowns, we at least need to have two equations. Okay, if a linear equation has three unknowns, we need to have at least three equations. But we have only one equation. Okay, one equation with two unknowns. So we have to come up with certain approximations to solve this differential equation. Okay, we'll see it actually how to solve it. Okay, and this simple Schrodinger equation, the eigenvalue equation, we can use it to solve the simplest of the simplest pedagogical example, a particle in a one-dimensional box. Particle in a one-dimensional box, here there is only a single particle, there are no particles around. The potential inside this particular wall is zero because there is no interaction potential, so potential is zero. And since we are confining this particle within an infinite wall, beyond these two walls, we keep the potential as infinity. Okay, and for this particular system, if we solve the Schrodinger equation, we can find the corresponding wave function and the corresponding eigenvalues. Okay, we can find the corresponding eigenvalue and eigenfunction. It's a very simple differential equation we construct. We can find the corresponding eigenvalue and eigenfunctions. But if you have a system with many particles like molecules or atoms, in an atom there are so many subatomic particles, there are so many electrons around. How do we solve the Schrodinger equation, the time independent Schrodinger equation for a molecule? Okay, for that we have to rely on certain approximation. The first approximation is Born-Oppenheimer approximation. This I think most of us know actually, right? So when we look at the time independent Schrodinger equation, this is the eigenvalue equation. H psi is equal to E psi. Psi is the wave function and E is the corresponding energy of the system. This is the energy of the atoms or molecules, whatever actually. So if you want to solve this simple looking Schrodinger equation, we need to construct the Hamiltonian. Okay, so the Hamiltonian basically for a many particle system comes from different contributions. So here there are 5 contributions, there are 5 terms in this Hamiltonian. The first term is because of the kinetic energy of the electrons, second term is due to the kinetic energy of the nuclei, and rest of the 3 terms are the potential energy terms. So this term is coming because of the electron nuclear potential energy. This is due to electron-electron interaction. This is due to nuclear-nuclear interaction. Okay, so there are 5 contributing terms. The differential equation is going to be highly tedious to solve. Okay, we can simplify this by making use of Born-Oppenheimer approximation. Okay, so under this approximation, what they have proposed is, since electrons are very lightweight, okay, electrons are very lightweight, if we sit on the electrons and see around the molecules, we feel as if the nuclei are all static. Okay, electrons are revolving around. Instantly the nuclei are all at static positions. So if all the nuclei are static, we can nullify this particular term. We can say the kinetic energy of nuclei is equal to 0. Okay, kinetic energy of the nuclei is 0 at a particular instant. Similarly, since all the nuclei are constant, electrons are moving around, right? So the potential, the interaction between the nuclei are going to be a constant number because interaction between the all distributed nuclei are going to be a constant number. So this is the approximation Born and Oppenheimer come up actually. So if you adopt this particular approximation, we can throw away this particular term and we can make this particular term as a constant. And essentially, in the electronic Schrodinger equation, we essentially get 3 contributions in the Hamiltonian. We simplify this differential equation. And further, still this differential equation is complicated actually. We need to adopt another approximation called Hartree-Fock method. Okay, the Hartree-Fock method in the many electron system. In the Hartree-Fock method, what people have adopted is we have to construct the Hamiltonian from the 3 terms here. Okay, and the second assumption is we have to construct an initial wave function from a slated determinant. That is the approximation. Okay, so this is a slated determinant. So a determinant has all the property like a wave function. Okay, since electrons are fermions, okay, electrons are fermions, the determinant has the property to describe electrons. Okay, to describe a fermions. So that's why John Slater has come up with a very simple idea of constructing the initial wave function as a slated determinant. Okay, so since we have the Hamiltonian, we have the initial wave function. We put this Hamiltonian wave function into the Schrodinger equation, and if we invoke the variational theorem to calculate the corresponding energy of the system. Okay, this is a simplification actually. If you put back these two terms into the Schrodinger equation, we'll get this particular equation, and this is using the variational theorem. We find the energy of a system. Okay, so this approximation is called the Hartree-Fock method, and in the Hartree-Fock method, essentially we are solving the Schrodinger equation. As I told you, if you want to get a meaningful wave function for a system, we need to solve the Schrodinger equation, time-independent Schrodinger equation. So Hartree-Fock essentially is solving this time-independent Schrodinger equation for a system. So a system can be atoms, molecules, it can be macromolecule, whatever actually. We need to solve the Schrodinger equation to get a meaningful wave function and the corresponding energies. Okay? And people have already come up with a higher approximation on top of the Hartree-Fock, the method called Moeller-Plesset method, and people have already come up with a very accurate method called coupled cluster methods. Okay, so since these are more accurate method compared to Hartree-Fock, we can run this calculation only for system with only very few number of atoms. These methods are not meant for very large systems. Since if you want to deal with protein folding kind of problems, we cannot use coupled cluster kind of methods to solve protein folding kind of problems. Okay, so if you want to deal with protein kind of systems, we have to rely on some empirical methods or some approximate methods called semi-empirical methods or force field methods. So using these force field methods, we can handle the history of artificial intelligence. Right? Basically, this artificial intelligence people started hearing very recently, but the history goes back almost 75 years. Okay, the initial idea was started back in 1950s by a scientist called Alan Turing. So the basic idea was he was asking a very simple question like, can machines think? So this was an article he proposed actually. He conducted a simple test in 1950. That was the beginning of this particular era of artificial intelligence. Okay, he conducted a test called Turing test, and the result of this Turing test he published in this particular article actually. And one of the simple questions he asked is, can machines think? A simple question lead to a very evolution of a very big area actually. Okay, and starting with 1950 onwards, there are so many developments happened actually. I'm not going to the details of it actually. And in the last decade, we are seeing there is a lot of developments in the area of artificial intelligence and machine learning. Back in 2016, in the last 10 years actually, you may be knowing about Sophia. Sophia is one of the teacher actually. It's a robot, okay, humanoid robot. This robot has the effects of human in the eyes. Okay, this looks like a human being. Finally, this humanoid robot, got the citizenship of Arabia, Saudi Arabia. Okay, that is a funny thing actually that happened back in 2016. And also in our homes, we may be very familiar with Google Home. And back in 2020, we are very familiar in our mobile about ChatGPT, and in our WhatsApp, we come across Meta GI, right? Okay, and we come across in 2020 about the autonomous vehicles by Tesla kind of companies. So essentially, this artificial intelligence evolved over the last 75 years. Okay, and there are a series of developments. I am not putting everything actually. Okay, these are the few developments in the last decade. And essentially, this AI is transforming our society. So basically, we wanted to adopt this AI into our chemistry, in quantum chemistry. We wanted to make use of AI in quantum chemistry to solve chemistry problems. And recently, there is some other developments also happening. It's called quantum computing actually, quantum machine learning. So people wanted to integrate quantum computing with machine learning called quantum machine learning. Okay, so this is another area that is popping up actually. And since we are dealing with protein folding kind of problems, people were very much interested in developing that area for very highly difficult, sophisticated kind of problems like protein folding. Okay. So now the question is, can we use machine learning in chemistry? So what is this machine learning actually? So knowingly or unknowingly actually, we make use of artificial intelligence or machine learning in our day-to-day life, starting with our first email in our day and starting with our Facebook suggestion to the Instagram suggestions. These companies effectively make use of AI and machine learning in our suggestions and promote their companies. Okay. Now the question is, can we use these models? Basically, this machine learning is a collection of algorithms. Okay, it's a set of algorithms to learn actually. So the collection of algorithms to learn. So in chemistry, can we adopt these models to learn? So in simple way, what is this machine learning actually? If I ask a simple question, what is this machine learning? So this is a simple robot actually. So previously we used to give instruction to robots. We used to write programs and give instruction to the robot so that the robot will obey, and we get the task done by the robot. Similarly, how do we define learning actually? If suppose we take a small school going kid actually, how do we define learning? How do a school kid learn? Yeah, basically we all learn from instructions, right? We learn by instructions, and these instructions we keep in our mind, right? We don't forget, right? Some of the learning is through memory, and some of the learning is through logic actually. So ultimately, all of this memory and logic are a collection of data. These are all information, right? Suppose if you want to make a robot to behave like a human being, suppose if you want to make the same learning onto a robot, okay? The robots are dumb machines actually. We want to make this robot to think and behave like a human being. How do we do it actually? So how can we learn from experience? Because we learn from experiences, but can we impose the same thing onto a robot? Can the robot learn from experiences? Definitely yes, but there is certain manipulation we have to do. Okay, there are two important things. We can learn from experience. This experience we have to replace by data. Okay, and this learning we have to replace by algorithms. Okay, so in machine learning, basically there are two important things. One is data and another is algorithms. Okay, so depending on the nature of the data and the algorithm that we use, the quality of our prediction and our model will depend actually. Okay, so data, even for a molecular system, we need to have very extensive data. Okay, and we need to have very elaborate algorithms to learn the data and to predict. Okay, so important two things are the data and the algorithms. Okay, and when we look at the artificial intelligence or machine learning models actually, these are the algorithms. Out of the two, data is a data, and algorithms, if you look at the algorithms under artificial intelligence and machine learning, these are some of the collections of algorithms under machine learning. Okay, in machine learning, as we know, the three categories of algorithms, one is called supervised learning, another is called unsupervised, another is called reinforced learning. I will not go and discuss each and everything actually. I will discuss only one of it. Okay, and within the supervised learning, we have a regression. Regression we regularly do in our lab, in our physical chemistry lab or in physics lab, we do actually. In our lab, we do the measurements. Finally, what we do? We put a straight line, right? From the set of data we got from the experiment, we approximate it as a straight line by doing linear regression, right? So in the linear regression, we put the data into the statistical equation, we find the corresponding slope of the line, and we find the y-intercept, right? So based on the y-intercept and the corresponding slope of the straight line, we draw the straight line, right? It's not an arbitrary line, it's a best fitted line. That is why it's called a linear regression, right? So same thing actually, there is a connection between that experiment and what we are going to do in machine learning, because in linear regression, same thing we are going to do in machine learning actually. So in linear regression, what is happening actually? So in this particular model of machine learning, essentially there are two important things, there are two important steps. If you want, in any of these algorithms, there are two important steps. The first step is called training. Just like we were kids starting from our nursery onwards, our MSc, PhD, we were learning. So there is a training phase. Now we are in our testing phase, right? Now our students are the testers. They'll ask questions, then based on our experience, we have to respond, right? So our training was very long period, maybe 12 years, 14 years. After 14 years, we are under testing phase till our death maybe, right? Essentially, we are trying to make this computer very intelligent. We are trying to impose intelligence onto this machine. How do we do it actually? So what we do is, for example, if I want to train my computer to say, this is the fish as an output, What I do, I feed in fish as an input to the machine, then I associate the input with the output, and I say to my machine, this is the fish. Okay, same thing we did in our school days, in our nursery. Teacher showed the picture of a fish. Teacher told, this is the fish. If she would have said this is a car, then it would have been a car, right? But she didn't make a mistake, so we know this is a fish. So how did we identify a fish? Yeah, we draw certain features. We looked at the figure. From the figure, we identified certain features. Okay, there is a fin, there is a small eye, right? And there is a color, there is a fin, everything is there. So if we have certain features, we say, okay, this is a fish. Same thing we can do onto a computer also. Okay, using the algorithms, we can scratch out the features of any object. Okay, I'm just saying it is a fish. This can be molecule also. Instead of anything, instead of a fish, this can be a molecule. This can be aromatic molecule. This can be aliphatic molecule. This can be protein. This can be alpha helix. Whatever actually. I'm just showing, for example, this is a fish. Since this is the input, we extracted certain features. We associate that set of features with the output fish. Okay. So during the training, what we did, the teachers showed so many features. Okay. We identified, extracted all the features. Then we associated all the features with the fish. That's how we learned. We do the same thing onto the computer also using algorithms. Okay, so once the training process is over, then if you introduce any unknown fish to the machine should be able to say, oh, this is a fish. Okay, identifying the fish, identifying the features, the machine should be able to say this is a fish. So these are the two essential steps. One is the training and another the testing. Now, so when we look at the collection of algorithms, so one of the most important algorithm under regression, under supervised learning regression is neural network regression. Neural network you might have heard actually, right? You may be familiar actually, neural networks. So neural networks are again an algorithm basically, okay, is for training, is an algorithm for training actually, okay, algorithm for learning. So in this particular learning, what we do is, so basically the terminology artificial neural network has come up from a biological neuron. There is no connection between biological neuron and real artificial neurons. Okay, only the layout is the same. Okay, in a biological neuron, we have the center of the neuron, and as we know actually, these set of neurons are connected to so many neurons in the forward direction. Okay, the information from this cell, neuron cell, will pass through this axon to the next neuron. Okay, it will pass in this direction, right? And we have a central soma. This is called the cell body actually, and connecting this nucleus, we have the corresponding axons. Okay, and similar to this biological neuron, we can construct an artificial neuron. Okay, so in an artificial neuron, so this is the input for this particular neuron. Okay, so we put it as input. Okay, corresponding to this part of the biological neuron, we put it as input, and corresponding to the axon, we have the corresponding hidden layers, and this is connected to the corresponding output. Okay, so similar to the biological neuron, we have this particular neuron. Okay, this is an artificial neuron. That's why we call it as an artificial neuron. So this is a simple picture of an artificial neuron with only one node in the input layer and one node in the hidden layer and one node in the output layer. Okay, essentially, this is a simple picture to construct mathematical equations. Since we discussed about linear regression that we do in our regular labs, okay, there is a connection between linear regression and this equation. Okay, that's what I wanted to make out. So how do we connect this input with the output? This is the simplest of the simplest neuron that we can think. So essentially, we are drawing to construct mathematical equations. So there is a certain procedure we have to follow to construct the mathematical equation. Okay, so when we are connecting this output with the input, okay, what we need to do is, first, what we need to do is, we have to multiply the input, and every layer, there are one node. Every node is connected through an arrow. Okay, every arrow corresponds to one weight. Weight is some random number actually. So every weight and every node is connected to one bias. Okay, and what is the output that we get here actually? So what is the output? So how do we construct the mathematical equation? The way to construct the mathematical equation is by multiplying the input with the corresponding weight. Okay, multiply x1 into w1, and add this bias weight to this. So the information that is passing from the input to this layer, to this node, is x1 into w1, this one, and bias plus b. Okay, so that is the information here at this particular point, and this information we pass on to the output. Okay, so when we look at this particular equation, this is very similar to a linear equation. So this is equal to mx plus c. So the bias weight is like a y-intercept, and the w1 is like a slope. So y is equal to mx plus c. So the information that we are getting is a linear equation, linear information. To make it as a non-linear function, what we do is we pass this information through something called activation function. Okay, activation function. There are so many different variants of activation functions. We make it non-linear. Okay, we make it non-linear and we map it onto the output. So the output is equal to the activation function, and here we pass this z as a function of this particular activation function. So we get a non-linear function as the output. Okay, so this is a very simple way to construct a relationship between output and the input. Okay, so now similar to that, if you add more nodes to the input, okay, so corresponding to each line there is corresponding weights. Okay, there is a line connecting this node to the next hidden layer, that is w1, connecting this node to the hidden layer, there is another weight w2, corresponding xk to the next hidden layer, there is another weight wk. Okay, and what is the information that we reach here? The information is going to be w1 into x1 plus w2 into x2 plus wk into xk. Okay, that is the information. To this we have to apply the bias plus b. So this equation looks like a linear equation, and this information we have to pass on to a linear activation function to make it non-linear. So the activation function is z. We pass this z to the activation function actually to get a non-linear function. So this is a simple way to construct a neural network function actually. It's a non-linear function. So this is a very general way to construct the neural network equation actually. So this is the input and this is the corresponding output. So how is this neural network important in our chemistry? Basically, if you want to really get the eigenvalue or the energy of a system and the corresponding wave function, we need to explicitly solve the Schrodinger equation. Okay, so without solving the Schrodinger equation, how we can get the corresponding eigenvalues? That is a very simple question we ask actually. Without solving the very hard differential equation, how can we get the corresponding eigenvalue? So just by making use of this neural network method, we can find a connection between the structure input structure and the corresponding energies. Okay, so once we train this structure with the corresponding energy, we can get a known function. Okay, once you get a known function, we can find the energy of any unknown system. I'll show an example actually. So this is the example of this is a DFT calculation I did for a copper dimer. Copper dimer means there are two copper atoms. I bring copper atom from infinity close to each other actually. So this is the distance between two copper atoms. If I bring copper atom from infinity to close to each other, this is the potential energy diagram of a copper dimer. Okay, so that corresponds to the DFT energies. So what I'm trying to do is I'm trying to use neural network to learn the distribution of energies. Okay, so I'm trying to construct a function, neural network function, to describe my potential energy surface of a copper dimer. Okay, so initially what I do, I put random weights onto the inputs. Okay, I initially put random weights. Then what I do, I get the initial iteration as a very rough function. Okay, now I keep on doing an optimizer actually, keep on changing the weights in such a way that this optimized function, the optimized red function, matches exactly with the actual function. Okay, so that is a training process. So once I have a trained function for any unknown structure, I can find the energy. This is the case of a dimer. I can just show only the case of a dimer on the slide. The same thing can be done for a molecule also. Okay, but molecule we cannot really draw on the slide, because for a dimer the degree of freedom is only 1. We can show the r distance in one of the coordinate, but for a molecule there are so many degrees of freedom. Okay, if we change in any of the direction, the energy is going to change. Okay, otherwise we can move only in one direction. We can show how the energy is varying. Okay, but we cannot show in all dimensions. But for a dimer we can show. Okay, and this is the way the optimizer works actually. In the first iteration, 0th iteration, the red one, red is the line. That is a very rough way of getting a function. And we can use an optimizer to keep on changing the weight in such a way that we finally land up in this purple color actually. At the 10th iteration, we get a best fitted line. Okay, so essentially the neural network is helping us to find the eigenvalues without solving the Schrodinger equation. So once we have the function optimum weights for a given system, for a copper dimer, okay, given any dimer at any distance, I can find the energy of a dimer. That's the idea. Similarly, for a molecule also, I keep on changing the molecule in different directions. I have so many data sets. I have the corresponding energies. Train this molecular structure with the corresponding energy. Construct a function relating the structure with the energy. So make a one-to-one connection between structure and energy. Construct the neural network potential. For any unknown structure, I can find the corresponding energy. That is the simple idea we follow actually, because that is very much important for protein structure prediction kind of problems. Because if I want to solve a Schrodinger equation for a protein, it's going to be highly tedious because the degrees of freedom are going to be more, number of atoms are going to be very high. So number of terms in the differential equation are going to be it's very difficult actually. Okay, we cannot really solve the Schrodinger equation for many particle systems. So this is a similar case for hydrogen molecule. When I bring two hydrogen atoms from infinity close to each other actually, this is the potential energy diagram. So this is how the electronic energy varies when we change the distance between the two hydrogen atoms, right? So we know this distribution is called the Lennard-Jones potential, right? So this is a Lennard-Jones potential, and we know this is the minimum energy point, and the distance between this to this is the bond distance. We define it as the bond distance. So this is a simple potential energy diagram for hydrogen molecule, H2 molecule. The same thing when we look at for a protein. Okay, now for a protein, it's very hard to show the potential energy diagram of a protein, because for a protein there are so many minima, there may be so many saddle points, there may be so many maxima, and there is no way we can find which is the global minimum. Okay, so each of these minimum are the local minimum, and out of all the local minima, there is no mathematical way we can say, okay, pinpoint this is the global minimum. Okay, other than trial and error method, there is no way to find the global minimum actually. Okay, but even to find the energy of a protein, it's a very hard problem actually. Okay, because to get the energy of a protein, we need to solve the Schrodinger equation, and to solve the Schrodinger equation, we have to solve the differential equation, and solving the differential equation is going to be highly tedious. Okay, that is an impossible task actually, because if you want to scan this particular coordinate of a protein, it's going to be challenging problem actually. Okay, and not only that actually, suppose if I take a protein with n amino acids, right? This protein can fold into these many number of ways actually. Okay, our lifetime is not sufficient to, suppose I can calculate the energy, I can solve the Schrodinger equation maybe for one particular snapshot I can solve in 1 second. Okay, just see how many possibilities are there, how many seconds you need. These many seconds are not sufficient for our lifetime to complete to scan the potential energy surface of a protein. Okay, then we need to have a very clever way to do the protein folding problems. Okay, the protein folding problem, as you know actually, is a simple problem actually. Suppose given a chain of amino acids, as you know actually, a protein is a collection of amino acids which are all connected by covalent bonds. So these are amide bonds which are connecting between the amino acids. Okay, so once we give this as an input, and we should be able to find the native structure of the protein. Okay, so that's the simple protein structure prediction problem actually. So this because this was considered to be one of the hardest problem actually in the literature. Okay, so why it is considered as the hardest problem? As we said, we have to solve the Schrodinger equation to get the energies. So to scan the potential energy surface itself is a very hard problem. Okay, so people have come up with very large number of methods to solve this problem, and there is a collection of scientists they conduct every biannually one competition called Critical Assessment of Structure Prediction. It's called CASP actually. Even this year also there is one CASP. So what they do is they give some unknown protein. Okay, they give only the sequence of the protein. Okay, and they will test our method. Okay, they will give the sequence to us and they will ask us to use our method to find the protein structure. Okay, and finally they will compare our theoretically predicted structure with the experiment. And whomsoever is matching, they are the winners. Okay, surprisingly, in the last cast, the prediction was 100%. Okay, that's how the Nobel Prize happened actually. Okay, the prediction happened because of this AlphaFold. Okay, AlphaFold, they have been participating in this competition back in 2018 or so. Okay, but there are different variants of AlphaFold. AlphaFold is the name of the program. Okay, so this AlphaFold is basically essentially making use of neural networks, deep learning basically. Whatever the method I just discussed, the same method they have been using to find the native structure of proteins. Okay, AlphaFold currently it is in the stage of AlphaFold 3. Okay, so AlphaFold 3 is not only meant for amino acids, not only meant for proteins, they can also find the structure of DNAs, they can find the structure of RNAs. Okay, so they have evolved actually from AlphaFold 2. Okay, this is a state of this protein structure prediction, and this is the algorithm they have come up actually. We'll discuss this algorithm tomorrow actually. Okay, we'll discuss about this algorithm tomorrow. But another problem that is very much interested is about machine learning in materials. Okay, it's called materialist project. So even in materials, as we know actually, these are materials with the periodic structures. Okay, there are a collection of atoms. Some of the systems are very, very large. Okay, even for these systems, even to predict the energies and properties of these materials, we need to solve the Schrodinger equation. We need to get the wave function, we need to get the energies. Unless we know the wave function and the energies, we cannot predict anything actually. Okay, theoretically. So in this materials project, people have tried to bypass the calculation of Schrodinger equation. Okay, that we'll discuss actually on Friday. Okay, so people have come up with a very elegant way of dealing with materials. People can predict new materials with special properties without solving Schrodinger equation. Okay, that we'll discuss. In the hands-on, we'll do something actually. Okay, and this is about the materials project. And not only that, chemists are highly systematic. Okay, whatever we do, we document. So even for a protein, even for a molecule, okay, even for a drug, we document everything. We put it in a very special place. So there are a series of databases for molecules and materials. Okay, so these are some of the standard databases available actually. We'll also look into these databases. We'll get some information from there. We'll play with these databases actually. Okay, we'll see what are the informations available in these databases in the coming hands-on sessions. Okay, and okay, and yeah. So even before going into the protein folding and materials simulations, what I am planning to do is, I'm just going to say what we do in our lab. Okay, because protein folding is a very difficult problem actually. So as a starting point for predicting structures, what we did is, we try to predict the potential energy surface. Okay, so what we do is, why the potential energy surface? Because potential energy surface basically is a graph between the energy of a molecule as a function of geometry. Okay, so once you know the potential energy surface, we can decode anything actually. The many aspects of chemistry can be reduced into the problem of finding potential energy surface. Suppose if you know the potential energy surface of a system, we know the structure. Okay, why we should know the structure of a protein? Why yes, even for drug designing, right? We cannot design a drug in air, right? We have to design a drug for a particular target. Unless we know the structure of a target, we cannot predict the drug, right? So just for a simple example, drug designing, right? So that is one of the simple application of protein folding actually. Once you know the exact structure of a protein, we can very well design the correct drug so that we can denature the protein, or we can manipulate the protein so that we can kill the disease, right? So that is one of the applications. So similarly, once you know the potential energy surface of any system, we know almost anything. We know the properties of that particular molecule actually just by knowing the potential energy surface. Okay, so now the question is how we can characterize the potential energy surface. The way to characterize the potential energy surface is just like the way we characterize a function. Because the function, as I said, in the neural network, we are constructing a function connecting structure and the energy. So this is a function. Suppose if you look at this particular function, there is a minimum, there is a maximum. we can just use the method of calculus to characterize the potential energy surface. We can say whether it is a local minima or it's a maxima or a saddle point, just based on finding the first derivative and second derivative. If the first derivative has to be 0 at the minimum and the maximum, okay, and if it is a minimum, the second derivative has to be negative, right? And if it is a maximum, the second derivative has to be calculus to characterize a potential energy surface, right? So using neural network, we can define a potential energy surface. Once you have function, neural network function, okay, we can find where is the maximum, where is the saddle. So this is the distribution of the simple potential energy surface. We can see there is a maximum and there is a maximum. These two maxima are connected by a saddle point. Okay, and there are two minimum, and again these two minima are connected by a saddle point actually. Okay, so this is a very simple potential energy surface, but for a protein, this is going to be highly complicated because there are so many minima, and pinpointing each and every minima is highly tedious. Okay, now coming to going to the proteins, what we did in our lab is predicting the structure of atomic clusters. These atomic clusters, okay, does it follow any patterns? Suppose if you take an atomic cluster of certain number of atoms in the cluster, and we wanted to know how this atomic cluster will grow in size. Okay, so for that, what we did is we started looking at the property of these atomic clusters. We started looking at the electrostatic potential of the atomic clusters, parent atomic clusters. So what we are seeing is this is a parent cluster, and we started looking at the most negative region of the parent cluster. That is the prominent place where a small nuclei, how these atoms are coming closer and forming a bigger nuclei. Okay, and this is a silver cluster. With the silver cluster, we started looking at the electrostatic potential minimum. So these lobes are the most negative region, and these are the points at which we can add new atoms and grow in size. Okay, and this electrostatic potential, essentially we define at a particular point. This is a scalar field of a particular molecule actually. At a particular point R, we define as a contribution from the set of nuclei and the contribution from the electrons. So since there are two contributions, if the nuclear contributions are higher, the potential at this particular point is going to be positive. If the electronic contribution more at this particular point, clusters. But one important thing is, if you want to find this property of the parent cluster, we need to explicitly we need to solve the differential equation for this parent system. We have to get the wave function, we have to get the energies. Okay, unless we solve the Schrodinger equation, we cannot get the property of this particular parent system. This is highly tedious, and we relied on DFT for these calculations. But one important thing is, one important question that we asked is, can we bypass these calculations? Can we bypass these calculations using machine learning? So definitely yes. What we found is we can learn the distribution of the electrostatic potential minimum using machine learning actually. So what we did is we constructed a graph neural network. This is the parent structure, and essentially we correlated the parent structure with the minima of the parent. So these vectors are the minima point of the parent, and essentially we property of the structure with the input geometry using a graph neural network actually. So using this graph neural network, we train the neural network. Once we complete the training, we can predict the electrostatic potential of any unknown structure using this graph neural network. Okay, so why these graph neural networks are very important actually. Graph, as we know, in chemistry, these molecules can be decoded as graphs. Essentially, graph is a collection of nodes and edges. So every atom in a molecule can be decoded as a node, and every bond we can decode as a edge. Okay, and just by looking at this particular structure, we can construct an adjacency matrix actually. Okay, so in this adjacency matrix, if these two atoms are connected, we put a number label 1. If these two atoms are not connected, we put a label 0. Okay, so if it is adjacent, we put a number 1. If it is not adjacent, we put a label 0. Okay, so that's how we construct the adjacency matrix. But there are certain mathematical requirements this adjacency matrix has to follow actually, because this adjacency matrix does not have the information. Suppose if I look at the connectivity between 6 and 1, there is no connection. There is no information between 6 and 1. Okay, how I can get information of 1 at this particular point? So I can get the information of 1 at the node 6 by using something called message passing. So we have to follow a mathematical procedure called message passing graph neural network actually. So using that, we can pass the information of 1 onto 6. Okay, even though it is not really connected, we can pass the information of 1 onto 6. Similarly, all the non-adjacent atom information we can pass on to the neighboring atom using this message passing graph neural network actually. So these are the mathematical equations by which we pass the information actually in this particular graph neural network. So once we train the graph neural network, given any unknown structure, without solving the Schrodinger equation, we can find the corresponding electrostatic potential minima. So these are the red arrows are the minima points of the parent structure. And these points are the place where we can add new atoms and grow in size. Okay, and we have studied so many parts starting with the different variants of the initial structures. Here we started with the Mg13. This is the magnesium cluster with 13 atoms. So these are the minima of this parent. So we can see something like 20 minima for this Mg13. So we can add essentially 20 different atoms at this minima to grow the cluster into Mg33. Okay, and again we started looking at Mg33. For Mg33 there are 12 minima. At this 12 minima we can again add new atoms to grow in size. So essentially we studied the nucleation process, how a small atomic cluster is growing in size to form a very large cluster. So starting with the different symmetry point groups of the starting nucleation clusters, we follow different paths here. Okay. And now the question is, you may be wondering actually, how accurate are these predicted electrostatic potential using graph neural network? So this is the connection between the symmetry function of the actual calculation and through the predicted one. So it's almost showing a linear correlation between the predicted and the actual calculation. And the distribution of the arrows also shows a very simple connection between the predicted and the actual calculation. Okay. So using this simple approach actually, we could scan a large number of paths for the magnesium clusters. Even though we took magnesium as a prototype system, we can essentially look at any system like gold cluster, we can look at it. We can look at silver. We can look at any heteroatoms like alloys, or we can also look at to a very large size actually. Okay, and here we went on up to of the order of 500 atoms for the largest system. This is of the order of 3.5 nanometers actually for the largest. We essentially, theoretically, it is very hard to construct the structures of these sizes, okay, with the different point groups. But from starting with a very small nuclei, we grow the structure to we grow the structure up to almost of the order of few nanometers. Okay, another problem that we were interested in is about reaction mechanisms. As a chemist, we are essentially worried about reaction mechanisms. How a reactant will pass from the reactant side to the product side in the energy profile. Okay, so if we can learn the energy profile through a neural network, we can find out the corresponding transition state. We can find the activation barrier. We can find the thermodynamic parameters. Okay, the heat of reaction. We can find the activation barrier. We can find the rate constant. We can calculate all the parameters just like an experiment. Okay, so this is a simple elementary reaction where the reactant is passing from the reactant side to the product side through a transition state. Okay, this is a simple elementary reaction, but most of the cases, the reactions are not elementary. This may be a complex reaction with multiple elementary steps. Okay, now the question is how we can scan this reaction starting from the reactant to the product side. Okay, the simple approach that we followed is using neural network approach actually. So here in this literature, in the chemistry, these methods are very well known, like intrinsic reaction coordinate scanning and double-ended methods. Just by knowing the reactant structure and the product structure, we can find the structure of the transition state for an elementary reaction. Similarly, for single-ended, just by knowing the structure of a reactant, we can find the structure of the transition state. Okay, these methods are very well known in the literature. But the question is, suppose if there are multiple transition state in the reaction path, how do we scan it actually? So for that, we have come up with a very simple method called force approach actually. So one of the simple way to construct this kind of method is by defining the reaction coordinate. Okay, first thing is we have to define the reaction coordinate. Okay, there should be a unique way of defining the reaction coordinate, and another way is to another expensive thing is finding the derivative of this energy function is a very highly tedious process actually. Okay, so in this particular mathematical procedure, what we did is we translated the geometrical information into a set of parameters actually. Okay, these are set of symmetric functions. Okay, so we were working in a feature space. Then what we did is we defined the reactant and the product. We defined the features of the reactant. We defined the features of the product. Then what we did is we reduced the difference between the features of the reactant and the product through a simple numerical method actually. So this is a simple cost function that we have in this particular process. We define the cost function that defines the difference in the features of the reactant and the product. In a simple mathematical procedure actually, we decrease the difference between the cost function, and we could able to look at the corresponding reaction mechanisms. Okay, so this is the cost function we defined. We followed the simple mathematical procedure of calculating the first derivative of the function, and by decreasing the distance between the features of the reactant and the product, we could essentially able to scan the reaction mechanism of these reactions. Okay, and when we do this particular procedure, this is the path we get. Okay, and once we get an initial path, what we did is we did a constrained symmetry function optimization to land the minimum energy path actually. It's a iterative procedure we followed to land up in the minimum energy path. Okay, and this is about a simple COP rearrangement. This is a simple elementary reaction actually. So this is a simple reaction where this bond get broken, and there is a formation of the simultaneously formation of another bond. So in this particular process, this is the reactant and this is the product. This is the potential energy surface of this reaction. So when we move from the reactant side to the product side, it is passing through a transition state. Okay, so when we look at the structure of this transition state, whatever we got here, this is the transition state we got through Gaussian package, and this is the transition state we got it through our calculation actually. So when we look at the corresponding frequencies of this transition state, the numbers are almost close, minus 524.4, and for Gaussian through an actual calculation, this is minus 522.6. And we can also see the corresponding vibration of the transition state. Okay, the vibration are also similar actually for through our method and Gaussian. Okay, and we scanned a very large number of elementary reactions, starting with addition reaction, hydrolysis reaction, elimination reaction, substitution reaction, and ring closing, Claisen rearrangement, functional group rearrangement, and these are some of the elementary reactions in chemistry actually. So for each of this reaction, we could able to scan the reaction mechanism actually. Okay, so that's what we did in this particular method, and this is the comparison with actual calculation and our method. So this is about the energy, how different are the energies of the transition state, and this is the error in the frequencies of the transition state for these elementary reactions. Okay, so if you want to know more about these methods actually, maybe these are some of the books actually. Okay, this Forestman and Frisch is one of the book, and Frank Jensen is another book, and Attila Szabo, Modern Chemistry is another book actually. Andrew Leach has another book. DJ Wales is another book actually. These are some of the books, and if you want to learn more about these methods in the literature, these are some of the papers. Okay, these are some of the papers in the literature, and in the coming classes we will continue from here. Actually, we'll look at the materials project and we'll look at this alpha fold, how we can do this alpha fold, protein folding using machine learning, and what we can do in material project actually using machine learning. That's what we'll do in the coming classes actually. And I thank my group and the funding agencies and the organizers. Thank you for your attention. So we didn't begin the protein folding. So I just gave a base for the protein folding because it's a very tedious process to really find the protein folding. It's a very hard problem. Okay, because it's a highly time consuming business. Okay, if you want to very accurately get the energy of a protein, we have to solve the Schrodinger equation. Without solving the Schrodinger equation, we cannot get the energy of a protein. So essentially, we cannot really solve Schrodinger equation for many particle system. We have to rely on some approximate methods like bone open approximation, Hartree-Fock methods, and some of the correlated methods like molar placet, or some of the semi-empirical methods and force field methods. Okay, these are some of the approximations we have to adopt. And on top of these methods, we can make use of machine learning. That we'll discuss in the next class actually. I didn't discuss how how the AlphaFold is working. Okay, so without solving any of these equations, we can find the protein structure, native protein structure. So that's all they want the prize, AlphaFold 3. They could able to predict the structure of proteins, RNAs, DNAs. Even we are also free to use these packages freely. I'll show you actually how to handle these packages online. Do you have any questions?
Thank you, sir, for the good presentation. The next class is what we're expecting. We are taking to chemistry, undergraduate and postgraduate.
Ah.
So, how is AI and ML used in today's chemistry?
Right. We'll discuss actually. That we'll discuss. You have some idea on orange package? You got? Just now you got, right? Last class, huh? Okay. We'll see how do you make use of orange to handle databases, how to visualize the distribution of, because two important things is about data and algorithms. Okay, if you have a decent data, we have to see what is the distribution of the data. That is first thing, and we have to learn about the methods, algorithms, how to use the algorithms. Okay.
Is that AlphaFold also no?
AlphaFold is yeah, we'll see. AlphaFold we can use their servers. We can submit certain calculation in AlphaFold. We'll see what is the outcome of the AlphaFold. Okay.
Chemistry we have retrosynthesis for design synthesis. For that we can do using AI. To any AI tools.
There are tools. There are free tools.
We don't know how to use the smile plant. We know only chemical.
Okay.
Maybe tools we need maybe smiles.
Okay.
That's very useful to us.
Okay. Smiles code we'll discuss actually. How to construct Smiles code.
How to predict the retrofit of a particular molecule using the existing AI tools, or how to predict reaction conditions or catalyst for a suitable reaction.
Okay. Okay. We will discuss actually. Retrosynthesis, right? We'll discuss.
AI tools that are used
Yeah. There are free available tools are there online. We'll discuss that.
for a particular example. We will do.
Yeah, we'll do it. Yes.
And predicting conditions, grainer forming, like that.
Okay.
Thank you.
Yeah, we'll do some hands-on on protein and materials also. There are so many databases available actually. We'll see on these databases. We'll see the distribution, what are the properties available. All these things we'll do in the coming classes. Okay? Yeah. Yeah.
Thank you so much, sir, for the insightful sessions. Might be some people didn't understand because of the background, like chemistry people can understand.
Yeah.
Yeah. Thank you so much, sir.
Yeah, okay.
Thank you, participants. Tomorrow we'll meet again. Please join for dinner tonight. Thank you.
Okay, thank you.
We need your PPT if possible. Can you
PPT.
send? Yeah.
I'll share you.
And tomorrow is also
I'll give you tomorrow.
join for
I'll
lunch
give you.
also, sir. Yes, you can is on.
Because we have class, no? We have lab and everything is there.
Thank you, sir.